एक माला के मोती हैं सब, शिक्षा के मंदिर के ज्योति हैं सब। नहीं है यह केवल एक महाविद्यालय का आंगन। हेलो। यह तो है स्नेह भक्ति से सजा श्री के घर का आंगन। Good morning everyone. It gives me an immense pleasure to extend to you a very warm welcome on behalf of the Vedanta PG Girls College Ringus, who has clubbed all of us for the first international conference on emerging trends in science and technology. And now we are going to start our third day of first international conference, the Galaxy of Intellective, Honorable Principal, invited guests, teachers, and our beloved students. How phenomenal is this day? You are witness an entertaining and amusement program. Now, we are going to start a poster presentation and the first, now we are going to start our oral presentation and the first abstract ID is IC138 Neelam Kumar. I repeat, IC138 Neelam Kumar. Is not here. And the next abstract ID is IC147 Sudeep Bhattacharya.
Yes,
I repeat, IC147 Sudeep Bhattacharya.
Yes, ma'am. Audible? Yes,
Sir, are you there?
Yes.
Sir, please use your microphone because your voice isn't clear.
Yes, I'm audible? Hello.
Yes, sir, you are audible, but your voice is not clear.
Okay. Let me present, please.
Now it is audible, okay?
Now it is fine. Okay, sir.
Okay.
Please continue.
Okay. Let's see. Okay.
आपको पोस्टर लेके आओ.
Okay. Is it visible?
No.
My slide is
No.
No.
okay.
क्या हुआ?
Excuse me.
एक मिनट सर visible नहीं हो रहा.
Excuse me, sir. It's time for oral presentation. We will take poster presentation after some time, okay?
No. It is not what oral. Actually, it is oral presentation.
Sudeep, sir, please repeat.
Yes.
Yes, sir. Please share your screen.
Okay.
And there is an instruction for you. Please sum up your presentation within 5 minutes due to, time limit, okay?
Yes. Ma'am.
Okay.
इनको देर हो रही तो किशन को बुला लो, किशन कुमार को.
Yes, sir. I'm ready for to present my presentation.
Okay, Kishan, share your screen.
आयुषी देर हो रही तो किशन कुमार बुला लो.
Okay, sir.
Yes, sir.
किशन कुमार.
I'm audible, sir.
Yes, sir. What's your name, sir?
Krishna Kumar, ma'am.
Okay, so you can start your presentation and please tell me your abstract ID.
115, ma'am.
115. Okay then. Now you can
Yeah.
start your presentation and please sum up it within 5 minutes, okay?
Yeah, definitely, ma'am.
Okay.
Okay. Can I present, ma'am?
Yes.
Yeah. My slide is visible?
Yes.
Okay.
Please make it full screen.
Try to
Make
talk
it-
about your research work only.
Yeah, sir. Definitely.
No introduction.
Okay, sir. Once. Okay. My research work is related on the visible light dry and selective reduction of carbonyl compounds, metal-free. One second. Metal-free induced electron transfer system. And first of all, introduction. As a visible light is a widely believed and solving the future problem, and visible light is a clean, sustainable, abundant, and economical characteristic. And light are essential for many industries like medical, agriculture, research work, visualization, and also entertainment. And in this field, visible light as a use in photocatalysis reactions. As a catalyst is a photochemical process in which non-valuable compounds convert into valuable compounds. As the example says that photosynthesis is a type of a photocatalysis reaction. What is the process of photocatalysis? And most of
And
reactants
your time is
can't.
Kishan, your time is short. 5 minutes. Go to research work only.
Okay, sir. Okay, sir. And in this field, my research work, I synthesize carbonyl compound using carbonyl compounds using a diverse method, means synergetic effect of eosin Y, graphene oxide, and ammonium oxidate in isopropanol using visible light reduction. First of all, we synthesize GO in the modified Humbrus method, and GO is a significance for many qualities as like a good water dispense and high compatibility, high surface area, high thermal stability in this regarding. And graphene oxide have a CWH group. For this properties is act a acid catalyst and behave as a acid catalyst, and uh, it is our spectra analysis. This is a 2 theta of XRD and SAM and TAM and FT also FTR. And in this FTR we can see that first we proceed the first run, and we recycle the geo, and then proceed again same reaction. Then we can easily say that no major changes in geo qualities in this field. Yes, sir. Synthesis of carbonyl compound as a we choose a model reaction of aldehyde into form a alcohols, and this is a phenomena. And in this reaction, eosin wise act as a photosensitizer, and geo nanoseed is a electron conduction, and geo also is a acid catalyst for use of the presence of oxygen functionality, and AO is a whole squenger in this moiety. First of all, eosin Y absorb visible light, and excitation ground state to excited ground state to higher energy level. Then electrons goes to geo nanoseeds, and geo nanoseed act as a electron relay conductor. Then and carbonyl compound carbonyl compound absorb a electron for form a radicals, and isopropanol give a proton indicator, and then also for a electron, and for a anions, and also form is isopropyl, and proton is isopropyl and form alcohol.
Excuse me,
And
will
in
the
this
participants
field,
please mute
ammonium
themselves?
oxalate act as a whole squencher. That's why photo catalytic reaction is goes to high intensity and electivity high. In this field, Geo, and Eosin Y as a synergistic effect, and this geo synergy in this reaction of synergistic effect, we are also analysis of UV visible photofluorescence, FELM, and TCPSM, and this is the pictures of FLIM. In this picture, we can see that in the duration of reaction, many visible light absorbed by the AO and means synergy effect. This is the scope of we synthesize a compound via using GEO and AO and eosin by catalyst. Advantage of our protocols that environment friendly and use a metal free containing and simple, high efficient and superior photocatalytic and avoiding need to inert atmosphere and environment to begin catalyst. And this is the spectra of benzyl alcohol for we synthesize benzyl from the benzyl aldehyde. And conclusion is this approach totally approach of green approaches chemoselective effect and green synthesis that well defined and base economics and design easily recover and recycle chemistries. And I also acknowledgement of UGC for giving the fellowship and Department of Chemistry University for giving the space for research work, and also acknowledge of IIT Delhi, MNIT, and CDRI and SAFE providing the spectral analysis. Thank you, sir.
Thank you so much, sir.
If any queries, please ask.
Good presentation, question.
Yeah, thank you, sir.
And before going to graphene oxide,
Yes,
did
sir.
you try graphene also?
Graphite, sir.
Okay. What is the thickness of geo sheet?
And this thickness of 100 to 200 nanometers, sir.
Oh, I see. Okay.
Yes, sir.
Anybody want to ask question? Can ask. Otherwise, thank again. Question.
Yeah, thank you, sir.
Thank you so much, sir, for being here with us. So
Yeah,
now
thank
we
you, ma'am.
have the next abstract ID is IC 147 Sudeep Bhattacharya. I repeat, IC 147 Sudeep Bhattacharya.
Yes, ma'am. Let me share my presentation.
Yeah.
You're not visible. Sudeep, you are not visible.
Okay, ma'am. 1 minute. Ma'am, please let me 1 minute because I will present just one after.
Ayushi, meanwhile, you can call somebody else.
Okay. That is be better. Actually, ये share नहीं हो रहा है.
Okay, it's okay, no problem. You take your time.
Ask somebody else.
Yes, sir. So next we have abstract ID IC 150 Vijay Udhav Gore. Okay, he is not with us. So next we have the abstract ID 165 Anupama Sharma.
Good morning.
Good morning, ma'am.
Anupam, you're not visible.
Ma'am, please share your screen.
Anupam, what is happening? You're not visible.
My screen is visible right now.
Yes, start now.
Okay, sir.
Don't
The
delay.
screen is
You're not visible.
It's checking. Wait for a moment. Wait. Still sharing.
If every
so my
minute
screen
takes time,
is visible.
Sorry, ma'am, please repeat that.
हर
I
कोई
think
टाइम
you
ले
are
रहा है.
having,
My screen is visible.
ma'am, your voice is cracking. You might have internet issue.
I'll check in the Hello.
Yes, ma'am.
Your screen is visible to us. Now please continue.
Good morning. First of all, I am very much thankful to ICETS for giving me this opportunity. I am Dr. Anupama Sharma, Geology Department of Vinayak PG College, Chennai. Today I am going to present a mini review on which we are discussing about the impact of corona on the environment. These are clinical symptoms.
Anupama, directly go to your research work.
Sir, I have
Directly go to research work.
I haven't done the research work, it was just a review. So,
Avoid introduction.
hello.
Avoid introduction, go to research.
Okay. Sir, I haven't done the research work, it was just a review. It was just a review, sir.
Yes, visible.
Okay. Introduction. As you all know that the coronavirus is a severe disease caused by SARS-CoV-2. SARS is the virus which is known as severe acute respiratory syndrome. And as you all know, it is a pandemic disease which causes huge morbidity and mortality in affected countries worldwide. As it affects world economy, industrial growth, environment directly or indirectly. I think everyone knows the symptoms of corona, like we have tiredness, and less common are like sore throat, headache, aches, and pains. Now, the statistics of the coronavirus statistics all over the world, data presented as per WHO. There are several variants of the virus which are involved and the human population worldwide of mortality and the morbidity. As we know, there are the 4 variants which are right now affected all over worldwide. It affects the social economic status and the gross domestic product of the affected countries, and it also affects the movement of the population drastically, particularly during lockdown in order to stop the spread of COVID infection. This is the data which I had before submitting my abstract on 23rd February. In this, the worldwide total case of the corona is 4.26 billion. Among them, the mortality reported was 58,99,578. And in India, the total corona cases was reported 28 lakhs 67,030. The mortality reported is 5,12,622. But now I will discuss about the COVID and the environment. COVID might be impacting environment directly or indirectly. Some has reported that they have a positive impact, but in cost of the morbidity and mortality, if it is a positive impact, we don't need that positive impact, because lockdown restrictions, slow down economic activity, reduces the secondary pollutants like nitrogen oxide, GSC, chlorofluorocarbons and etc. and reduces the source consumption and waste disposable also. But they have a negative impact also. Like we are using a PPE kit, pressure in hospital hamper recycling activities, which also increases the medical waste, and haphazard disposable of PPE kit increases the plastic waste and solid waste. Extensive use of sanitization in the chemicals also discharges of various harmful chemicals in the environment, which causes air pollution. And recycling activities increases the environmental pollution. As you know that if we are get COVID infection, we have to use a mask, gloves, sanitization, which are disposed of. If we are disposed carelessly, like if we are disposing carelessly, it creates disturbs the marine system as well as the land sites also. So, as per the guidelines, we have to dispose the waste as per the guidelines, and most of the government imposes complete and restricted lockdown across the world to stop the virus spread. And these restrictions resulted in the reduction of pollutants, greenhouse gases, nitrogen dioxide, and certain pollutants into the environment. But the infection caused the morbidity, mortality, and the economic losses. So, if we get vaccinated, cover mouth and nose with elbow and the tissue when you are cough and sneeze. If you develop symptoms, test positive. Don't fear that I am a COVID positive. Go and check up and self-isolate until little recover. From my review, I will conclude that due to the other restrictions control the COVID infection, it drops the traffic and movement, industrial commercial activities, tourist movement, which affected the economy of the countries. And however, it also affected the education sector. Student was taught through online mode to some extent, which declined them for practical experiences. Yes?
I'm sorry to interrupt you, but your time is over now.
Okay, ma'am. I will finish. While it might have some impact on the environment, but it causes a huge loss of the revenue. Acknowledgement. Thank you, everyone, for listening to my presentation.
Thank you so much, ma'am. Now we are, anybody have any question? Any questions from any participant? No? Fine. So thank you so much, ma'am, once again. And now we are going ahead. Let's move. Abstract ID IC 254 VS Rao.
Ma'am, I am available now. Ma'am, 147.
Sir, please use your microphone.
Hello, ma'am, 147. IC 147. Yes.
Yeah, sir. You can continue now.
Okay. Okay, my topic is efficient fabrication of pH modified graphene nano absorbent for highly sensitive and stimulus determination of multi-class multi-pesticide residue for easy monitoring and market fresh vegetable by GCMS. The toxic pesticide residue that is edible vegetable measure cause of health risks and the consumer, hence the quantification. And then the essential, however, the determination of the intervention residue of multiple class in the complex matrix, thus the simultaneous stress level remains the difficulties of the analytical challenge. The reduced graphene oxide is a promising absorbent for the determination of pesticide residue in various substrate like vegetable also.
Can you avoid introduction? Go to research work.
Okay, sir.
And you are not visible.
Okay, sir. This is objective is to prepare the sensitive and cost-effective method for pesticide analysis in vegetable using gas chromatography and simultaneously the monitoring of multi-class and multi-residues, that is more than 20 pesticides at a time, and preparation of graphene oxide nano-absorbent as a SPE, solid phase extraction, and the monitoring of markets for vegetable also. So in that case, we had prepared the graphene oxide, reduced graphene oxide in pH modified method. That is, we use that is acidic reduced graphene oxide and basic graphene oxide to use as a solid phase absorbent, and then the pH modified graphene oxide is characterized by the XPD, that is GO, this is graphene oxide, RGOA, that is acidic graphene oxide, RGO normal, the neutral graphene oxide, and RGOB, that is basic graphene oxide, and it is the UV spectrum, and then it is also XPS spectra adopted from the analysis of graphene oxide and graphene oxide basis. That is the efficiency of basic graphene oxide is higher than any of these, that is acidic or neutral. And then that a DSP and sorbent combination, that is a three combination we have studied, that a three combination, that is sorbent one combination is that basic graphene oxide plus PSA, primary secondary amine, then the only PSA, and the third combination is the fluorosil with C18 combination. And we have method that is adopted, that is modified Coechart's method, that is graphene PSA and C18, which is used as a solid phase absorbent, and the initial volume of the sample is the 15 gram, and the final volume is only 1 ml. And then this is the GCMS parameter, and this is the standard chromatogram of GCMS, and we adopted and this is the recovery study also, that is PSA and graphene and C18, and it is clearly observed that the recovery study in case of graphene is quite acceptable as per Sante 1027 guideline, as also the 2017 guideline also, that is more acceptable in case of graphene oxide. And it is the comparison average recovery percentage in brinjal, that is graphene was almost 100 recovery percentage, and the cost effective in case of the price point of view, that is the graphene is much lower cost than others, that is C18 and PSA. And that is the monitoring sampling point of West Bengal, that is the 3 sampling point, and these as the monitoring result, that is chili, cabbage, tomato, and cucumber. We had collected 3 types of vegetable, and it is the monitoring data, that is quinalphos, malathion, chlorophyphos, all are the OP, organophosphorus pesticide. It is pointed, and the result is 0.01, 0.1, that is almost the maximum residue limit. So this is the conclusion. Graphene found to be the quite satisfactory result in the relative standard deviation less than 12.8 for all 30 pesticides. We are monitoring 30 pesticides, and the study shows the graphene oxide has significant potential as a encouraging new absorbent for the pesticide residue analysis for vegetable. And the graphene mix clean the method proved that the best providing average recovery percentage range from 77 to 118 with the precision that's RSD again 12.8, and a graphene can be replaced as a new generation nano absorbent, that is DSP cleanup for the DSP technique, and Coechart's technique for DSP and GCMS combination. This is much more acceptable for the monitoring of pesticide residue vegetable. Thank you, sir.
Thank you so much, sir. Question session is open for audience. If anybody wants to ask any question, he or she can.
What is the thickness of your graphene?
Sorry, sir.
What is the thickness of the graphene?
Sir, I've not studied yet. That is graphene. Actually, it is reduced condition. We have not studied actually.
Okay.
Okay, so thank you so much, sir, once again. And now we have the abstract ID 254 VS Rao. I repeat, IC 254 VS Rao
This IC 138, 164 are ready.
Yes, sir.
IC 164 and 138 are ready.
हमारे मैसेज डालो चैट में, आई एम रेडी.
Okay,
Okay.
please, may I know your name, ma'am? Ma'am. Okay, so VS Rao is not here with us. So next we have abstract IDs 198 Sonia. Abstract ID IC 198 Sonia. Okay, so next we have abstract ID 199 Simran Dave.
Yes, ma'am.
Okay, so you start your presentation, ma'am.
Okay, ma'am.
Simran, you are not visible.
Yes, sir. एक फोन में चला रही हूँ सर.
Is anything wrong, ma'am?
Yes, ma'am. My screen is working.
Ma'am, please use your microphones.
138 is ready.
Okay, so next we have abstract ID.
Yes, sir, I am ready.
Neelam Kumar.
Yes, ma'am, I am ready.
Yes, you may start.
Please allow me.
Ma'am, excuse
Sir.
me, ma'am. Excuse
Yes.
me, ma'am. I'm visible my PPT. Hello.
Okay,
Yes, ma'am.
please continue, Simran, ma'am. Please
Okay,
continue.
so you continue, ma'am.
Okay. Good morning, everyone. Myself Simran Dave and my research scholar at Department of Zoology, NRN University. Introduction.
Simran,
Agriculture.
Simran, directly
Agriculture
go.
is a depend on
Simran,
maritime.
Simran,
Yes, sir.
directly go to your
हाँ.
research work. Simran, directly go to your
Yes.
research work.
Yes, yes, sir. Okay. Sir, ये बता सकते हैं स्टडी एरिया?
हाँ, ठीक है.
ठीक है. My study area is Jodhpur. Jodhpur is the second largest city of state Rajasthan. It is a historical city. The Jodhpur district of Western Rajasthan extend between 27 degree to 29 north to 25 degree to 99 latitude, and which account for 11.6% of arid zone of Rajasthan or 67% total area of the state. My topic is wild boar, crop riding by wild boar. The wild boar is one of the most widely distributed large mammals occurring in North Africa, Europe, and Asia. Worldwide, there were 16 species of wild boar and wild pig. The reproduction period is in wild boar seasonal and mostly correlated with availability of food and other climate factors. In recent years, the species is majorly included in crop riding and it has become a major pest in agriculture ecosystem. Wild boar are omnivorous.
Simran,
Yes, sir. Yes,
Simran,
sir.
Simran,
Yes, sir.
try to avoid introduction. Go to research work.
Okay.
Yes.
Okay. Material and method. Data on the wild boar was collected during from 2019 to 2020. During the study, 15 farmers were interviewed and a questionnaire was prepared to gather information on the type of crop affected, crop right behavior, seasonality of food preference, crop protection, strategy, economic loss, and other issue concerning people's livelihood and wildlife conservation issue. Photography also confirmed the presence of wild boar in study area. This is the evidence of crop damage by wild boar. First is वो कैसे खेत के अंदर एंटर करता है, वो खेत की बाउंड्री के अंदर होल मार्क करता है, फिर उसके अंदर एंटर करता है. तो फर्स्ट पिक्चर इज शोइंग दिस, and second is damage crop by wild boar, and third and fourth is wild boar are present in farm. Observation table. Wild boar consume mainly crops mustard, maize, gram, wheat, groundnut, kapas, pulses, gur, and sesame seed. And month when consume mustard is December to January, maize August to October, gram November to March, and wheat November to March. Groundnut consumed November to January. Kapas is September to October. Pulses August to October. Gur July, November, and sesame September to October. Result and discussion. The wild boar also observe eating roots, stem, both young and mature leaves, flowers, fruits, and occasional plant. Mostly wild boar damage crop are wheat, bajra, groundnut, and gur. And crop protection strategy by farmer. Farmer use mainly method to protect their fields and orchards from wild boar. This including patrolling the fields, watchdogs, fencing, guns, potash bomb. And another method are used by farmer is constructed fence out of the thorny twig and branches of Vilaiti babul, and jarberry, and bear and thor. And thank you, sir. Thank you, sir.
For audience, if anybody wants, okay. Question session is open for audience. If anybody wants to ask any question, they can.
इमरान, इन सब के बावजूद भी तुम कैसे बचा सकती हो खेत को वाइल्ड एनिमल से?
सर ये तो बच नहीं सकता है, बट एक नाइलॉन नेट या फिजिकल बैरियर नाइलॉन की रोप लगा दें तो थोड़ा सा नुकसान होने से बच सकता है, बाकी कोई चांस नहीं है.
Because wild animals are also very brilliant. They have their mind. They can use it.
Because sir, forest destruction is more
Okay.
Farmhouse.
Okay, thank you.
Hello.
Thank you.
Thank you. Yes, ma'am.
Hello.
Thank you.
Am I audible to you,
Thank
ma'am?
you, sir. Thank you, sir.
Okay, thank you so much,
Yes,
ma'am.
ma'am.
Okay, thank you so much.
Ma'am.
Okay, next we have abstract ID IC 138 Neelam Kumar.
Hello, ma'am.
Neelam Kumar, you're not visible.
Okay, sir, I try.
You are not visible. Your video is off. Yes, start.
Good morning, sir. Am I visible?
Yes, you are visible, but
Yes,
not
sir.
your slides are not visible.
Okay, sir, I will try.
What's happening?
I try to connect.
Any problem?
Sir, am I visible on screen? My slide is also.
Sir, you are sharing. No, sir,
No,
not.
sir.
No, sir. You are sharing screen from mobile phone or from desktop
Sir,
laptop?
sir, I share the screen from mobile phone.
Connection weak है सर, आपका connection weak है.
Sir, connection थोड़ा सा weak है, लेकिन I will try.
If you can speak, you can start without PPT. You can start without PPT too. Now you can share, sir. Now signal are good. You can share now.
इसमें कोई ऑप्शन ना आ गया स्क्रीन का आता है स्टार्ट
There is a green button.
Hello, sir.
Share a screen. Share a screen.
Okay, sir.
Screen is shared. You can continue, sir.
अब हो जाएगा, कर लो, कर लो। यहाँ से कहाँ से लगा दूँ? Visible हो रही है। So am I visible? My
Yes, you are.
slides.
Please continue, sir.
Sir, I am Neelam Kumar, research scholar from Uttarakhand University, Dehradun. Actually, sir, my work is on progress. I have not completed my research work. So my topic is polymer-based nanocomposites. Actually, I want to say that which polymers, nanocomposites we can use in research. That is we can remove the heavy metal from the wastewater. So this is the polymer introduction. Adsorption process, heavy metals. Sir, heavy metals often group name the metal that have been associated with the contamination with the potential toxicity or ecotoxicity. Actually, the common metal we know that copper, iron, zinc, mercury, lead, cadmium, and nickel. Actually, sir, we know that about the toxicity of heavy metals. So, the polymers, that is the polymethyl methacrylate, zinc oxides, PTH polythiophene iron oxide, and the other polymers that we can use in remove of the heavy metal from the wastewater. Some metal oxide nanopolymers, inorganic metal oxide nanoparticles have received a lot of attention due to their advanced physical and chemical properties. The common metal oxide, that is zinc oxide, copper oxide, iron oxide, cerium oxide, zircon oxide, magnesium oxide, nickel.
Neelam, directly go to your research work.
Actually, sir, my research was in progress, not till completed. Actually, but the topic is the metal oxide nano-based composites. So I want to tell the some common metal I take, that is the PMMA, ZNO, Fe3O4, PTH polythiophene. So, sir, I want to tell these nanopolymers. Because I have, sir, not completed my research work till now. It is just let's started. So I want to tell the some polymers, metal oxides, that I will tell.
Okay.
Because my experimental work is going on, so I have prepared PMMA, PMMA ZNO, polymer nanocomposites.
Okay.
So, sir, these are the nanocomposites, metal oxide, that is the SiO2 polyaniline polypyrrole Fe3O4, sir, polythiophene modified Chitson magnified. These are the polymer metal oxide nanocomposites. एक्चुअली सर ये नैनो कंपोजिट्स मुझे प्रिपेयर किए मैंने, जैसे पीएमओ और पीएमएमए पॉलीमिथाइल मेथाइलेट और जिंक ऑक्साइड को मिला करके पॉलीमर मैंने प्रिपेयर किया। बेसिकली वो पॉलीमर अपने एडजॉर्प्शन कैपेसिटी से हैवी मेटल्स को वाटर के से रिमूव कर देगा एडजॉर्प्शन प्रॉपर्टी से। और इसका जो काइनेटिक स्टडी है वो लैम्यूर एब्जॉर्प्शन आइसोथर्म से मुझे स्टडी करना है। तो एक्चुअली सर माय रिसर्च वर्क अभी तक कंप्लीट नहीं हुआ है, मतलब एक गोइंग ऑन है। तो मैं अभी पॉलीमर प्रिपेयर कर रहा हूँ सर, जिसमें से एक पॉलीमर में प्रिपेयर हो गया है पॉलीमिथाइल मेथाइलेट जिंक ऑक्साइड के साथ मिला करके।
ठीक है।
मैंने रेडीमेड पॉलीमर लिया सर पीएमएमए और जिंक ऑक्साइड से मैंने मिला करके उन लोगों ने इंटीग्रेट करके प्रिपेयर किया है। उसकी प्रॉपर्टी को सर एक्चुअली मुझे स्टडी करना है। तो 3 पॉलीमर सर मेरे टॉपिक्स में है, एक तो पीएमएमए ZNO है, एक Fe3O पोलीथायोफीन है और सर एक आपका CO एनिलीन है। ये तीनों पॉलीमर मुझे प्रिपेयर करके इनके काइनेटिक स्टडी करना है और इनके एप्लीकेशंस और एडजॉर्प्शन परफॉर्मेंस जिससे हम हैवी मेटल को रिमूव कर सकते हैं। एडजॉर्प्शन मतलब सर सरफेस फिनोमिना के थ्रू।
ठीक है।
स्टार्ट रिसर्च वर्क, इसलिए सर मैं अभी आपको रिजल्ट कंक्लूजन नहीं दिखा सकता।
कोई बात नहीं,
बिकॉज एक्चुअली मैं अभी इनका काइनेटिक स्टडी करूंगा। इनका जैसे सर ने बताया FTIR से, यूवी स्पेक्ट्रोस्कोपी से, FESM से, एक्सा टेक्निक से सर मुझे इनका स्टडी करना पड़ेगा। उसके बाद मैं रिजल्ट को मतलब शो ऑफ कर पाऊंगा सर।
ठीक है।
Okay, thank you, sir.
Thank you. Thank you.
Okay, thank you.
Ayushi? Ayushi, next one. Next one. Priyanka, invite another one.
कितना हो गया? नहीं टाइम नहीं हो.
प्रियंका, किसी और को बुलाओ.
Hello.
हाँ प्रियंका, कहाँ हो? आयुषी कहाँ पर हो?
Hello, hello. Sorry for
आयुषी,
disturbance, sir.
बुलाओ किसी को.
Yes, sir. So
Sorry,
next
sir.
we have.
Hello. Am I
Hello.
audible, sir?
Who are you?
Hello. Am I audible, sir?
Who are you?
Priyanka here.
हाँ audible है, but दिखती नहीं हो.
Okay, so next we have abstract ID IC202 Dr. Vijayshri Milind Hemke. Okay, he is not with us. So next we have the abstract ID IC148 Sunita Gaur.
Yes, ma'am. Can you
Okay.
audible, ma'am?
Yes,
Yes,
but you are
you're
not
audible.
visible. You are not visible.
Now, sir, now. Now,
Yes.
sir.
Yes.
Yes, visible. Yes.
Okay, okay, sir. Now I'm sharing my screen.
Yes.
Ma'am, I would like to inform you that you have only 5 minutes, okay?
Okay, okay, ma'am. Okay, ma'am.
Okay.
It is visible, ma'am.
Yes.
Good morning, everyone. Myself, Sunita Gaur. I'm research scholar of Jaina and Vyas University, Jodhpur, in the supervision of A.V. Singh, sir. The topic of my presentation is synthesis and characterization of Guardium-based resin and their application for treatment of effluents obtained from steel industry.
You change your
Sir,
slide.
I start.
You change your slide.
Yes,
Your
sir.
slide.
Start from methodology or from starting, sir?
Yes, yes. Yes, start.
Sir,
Yes.
only methodology or from starting, sir?
No, you just tell your research work.
Okay, okay, sir. Okay. Okay, sir. In laboratory, I prepared Guardium 1-butane sulfonic acid resin for the treatment of effluents, treatment of heavy metal ion obtained from effluent. The process of preparation of Guardium 1-butane sulfonic acid is as follows. First, preparation of Guardium epoxy propyl ether. For this, we take 81 gram of Guardium sample in a round bottom flask. To this, we add 15 ml of 40% sodium hydroxide solution and agitate it at 60 degrees centigrade till pH reached 8.5. To this, add 9.25 gram of epichlorohydrin and with constant stirring. After that, and heat for 5 hours at 60 degrees centigrade to remove impurity from epoxy propyl ether. We treated under vacuum and clean with methanol. Second is preparation of Guardium 1-butane sulfonic acid resin from epoxy propyl ether. For this we add this solution we add 16.01 gram of 1-butane sulfonic acid in dry resin and allowed to in epoxy propyl ether and allowed to react 4 hours at 60 degrees centigrade. After that, the final product was with methanol and few drops of HCl to remove inorganic impurities and and neutralize excess of NaOH. And after that, we dry this, and the yield of Guardium-based resin is approximately 42.2 grams, sir. This is the reaction for the absorbance of the metal ion, heavy metal like iron, especially for iron. This table is given. In this table, the maximum absorption for different ppm concentration solution of metal ion, maximum absorption occur at 18 ppm solution, which is 0.37, and minimum occur at 2 ppm solution, which is 0.056. This is the graph between ppm solution and absorbance. Next is the distribution coefficient, which is distribution coefficient KD value is measured by batch method. Different resin used in weight amount, and the formula is given as KD is equal to amount of metal ion resin divided by gram amount of dry resin, and totally divided by amount of metal ion solution and ml of solution. Iron metal ion chelating resin. For this, we take 0.2 molar sodium acetate and 0.2 molar acetic acid in different conical flask to reach pH of 3 to 8. In another conical flask, we add 0.2 molar ammonium hydroxide and 0.1 molar ammonium chloride to achieve pH 8. Each container contains 0.07 gram of dry Guardium-based resin and 1 ml of iron solution of 1000 ppm concentration solution. This contain maybe stir for 1 hour, magnetic stir for 1 hour, and determined by the concentration of the iron solution is determined by the AAS processor. This is the KD value graph for iron metal, in which maximum absorbance occur at 5 pH solution, which is 70.01, sir, in percentage. And the moisture content of this resin is approx 15%, sir, and the sulfur content in 1 gram is equal to 11.35%, sir. And ion exchange capacity is equal to 1.67. Result and discussion, sir. Heavy metals are selectively removed. This resin selectively remove heavy metal from steel. Actually, sir, my work done on steel industry, effluent of steel industries. And the KD value first increases, after that decreases when pH is increases, which is the order of the KD value is given as follow. And for iron solution, the maximum absorbance occur at 5 pH, which is 70.01%. This is my work, sir.
Okay, so question session is open for the audience, and anybody wants to ask anything, he or she can.
Sunita, what is the use of Gbsa resin?
Sir, for removal of heavy metal from waste.
Oh, I see. Waste
Yes,
means
sir.
which type of waste?
Sir, from steel industries waste, I taken waste from Jodhpur steel industries, and I'm also prepared sir stock solution, or after send in laboratory for AAS treatment, sir.
Okay, thank you. Good work. Thank you.
Okay, thank you, sir. Thank you.
Well, thank you so much, ma'am. And next abstract ID is IC148, Sunita Gaur. I repeat, abstract ID IC148, Sunita Gaur.
Ma'am, already done. 148,
Oh,
Sunita Gaur.
Okay, sorry. So next abstract ID is 251, Manisha.
Am I audible?
Yes, ma'am.
Yes, audible, but you're not visible.
Yes, of course. And
Now, sir?
Yes, now you are visible, and ma'am,
Yes.
there is an instruction for you. Please sum up your presentation within 5 minutes, okay?
Okay, sure.
But
Okay.
your slides are not visible.
Yes, sir. I'm sharing, sir. Now, sir?
Yes, visible.
It's visible now?
Try to go for research work on it, not
Okay,
for
sir,
the introduction, so that you can get time for the research work.
Okay, sir. So this is the plant that Madanfal That's botanical name is Xander dumetorum, that were collected from the local market and then identified the herbarium department of botany. Then preparation of extract, the dried this plant fruit part we are used were ground to fine powder using a grinder. Then powder to almost 2.5 kg were placed in a Soxtet apparatus and then extracted with chloroform for 12 hours for 3 days on a water bath. Excess under vacuum in a rotatory vapor, excess solvent was removed, and then almost 35 gram to avoid unwanted fat, the chloroform extract was treated with acetonitrile, and aliquot of the acetonitrile phase was transferred into a centrifuge tube and stored in a freezer for 2 days, where with the major part of fat precipitated, then almost 50 gram fat was separated, and then we have 35 gram yellowish mass was obtained that subjected to the column chromatography. This is the in this table shows that column chromatography that we have used petroleum ether 100% and the ratio of chloroform and PET ether and the ratio of chloroform and acetone and 100% chloroform. So these are the residues left after removal of the solvent. So after that, we use preparative thin layer chromatography with these solvent systems. The number of spots were detected. We have isolated 6 compounds from the fraction number 1 and fraction number 2 that solvent system used, that is PET ether, benzene and chloroform, and hexane, benzene and ethyl acetate. Then this is the GCMS analysis. Total 19 compounds were present in that chloroform extract that is shown in the table. So majorly phenol 2,4 bus 1,1 dimethyl ethyl was found in the highest concentration, that is 7.34%, followed by hexatecanoic acid 6.39 and pentacyclo compound, that is 5.45%, and tetra-contain, that is 5.28%. So these are the compounds present in the extract of the chloroform, and this is the GCMS spectrum of chloroform extract of this plant. Thank you so much.
Okay, so question session is open for the audience. If anybody wants to ask any question, he or she can.
Okay, Manisha, thank you for your presentation.
Okay, thank you.
Okay, so thank you so much, ma'am. And the next abstract ID we have IC 255, Jyoti Rani.
Yes, ma'am, I'm present.
But you're not visible, Jyoti.
Actually, sir, there is a network connection problem. If I will switch on the video, I won't be able to, get able to share my screen. Oops.
Ma'am, please share your screen.
Yes, I am trying to do
Okay.
screen. Okay. Start.
And ma'am, there is an
Is it visible?
Yes, now it is visible.
Is it, ma'am?
Yes. And
okay. Is it?
Please share your presentation. Yes, now it is visible. And now you can start.
Okay.
And there is an instruction for you. Please sum up your presentation within 5 minutes, okay?
Okay, ma'am. I will try to do my best.
Okay.
Hello, good morning, everyone. I am Jyoti, and I am here today to present my research work on health risk assessment of heavy metals through the consumption of vegetables in the National Capital Region of India. These are the content of my presentation. I will not waste time on it. We all know that India is a very large nation, and we are having huge population, human as well as cattle to feed. And nowadays, due to industrialization and we can say irrelevant agricultural practices, heavy metal content is increasing in the food commodities day by day. So I selected my study area from the National Capital Region, Haryana, that is 4 districts: Sonipat, Gurgaon, Faridabad, and Panipat. The reason for selecting these reasons is that this region is constituting near about 50% horticulture area of the Haryana and is having more than 60% macro, medium, and small scale industries. So we have collected vegetable samples from the different fields. Approximately 2 kilograms of vegetables were collected from the 5 different locations. And these samples were prepared by washing under tap water, and they were cut down into small pieces and oven dried at 80 degrees centigrade temperature. The dried vegetables, they were grinded for the AAS, for heavy metal analysis on the AAS. These are the vegetables which are sampled, and N is representing the number of samples for each vegetable. Digestion of the vegetable was done following standard procedure. 1 gram of dried vegetable that was taken into a beaker, and it was digested using 15 milliliter of triacid solution. Beaker was kept on hot plate under fume hood until a transparent solution was obtained. That solution was up to 50 ml and was filtered through filter paper for heavy metal analysis. These are the result of my research. I have analyzed 10 heavy metals, that is aluminum, cadmium, chromium, iron, nickel, lead, zinc, etc. It was observed that aluminum was the maximally reported heavy metal in all the vegetables. The reason of it may be that we are using aluminum phosphide as a agrochemical in the fields, and is also abundantly available in the earth crust. Then cadmium, I have shown here that the permissible limit of the cadmium in different class of vegetable is like it is in brassica it is 0.05 milligram per kilogram, in potato it is 0.1 milligram per kilogram, and in leafy vegetable it is 0.2 milligram per kilogram as per the WHO limit. So we can see here that most of the vegetables, they are exceeding the permissible limit. Same in the case of cobalt, vegetables, they are exceeding the permissible limit for human consumption. In chromium also. Copper was within permissible limit in all type of vegetable samples. Its permissible limit is 40 milligram per kilogram. Iron was in excess amount in leafy vegetables like mustard, fenugreek, and spinach, etc. Manganese was within permissible limit in all the vegetables. Nickel was also exceeding permissible limit. Chenopodium, nickel was reported maximum in the chenopodium. Okay. Lead was not reported in all the vegetables. It was reported in few vegetables, but its high concentration was reported in mustard, spinach, coriander leaves, potato. Next is zinc. Zinc was also within permissible limit in all the vegetables. Its permissible limit is 60 milligram per kilogram as per WHO recommendation. Then statistical analysis was also done in order to understand the correlation between the different heavy metals. So these were the Pearson correlation analysis result. It was observed that aluminium was positively correlated with iron, manganese, and lead, which shows that they can have some common source of origin. Principal component analysis was also done, which showed that the principal component 1 was having high loading of aluminium, chromium, iron, manganese, and lead, which is showing that they can have some common origin, and these are the industrial source in the current area. Health risk assessment was also done. Standard formula was used to calculate the health risk. So this was the formula. Health risk, it is estimated by calculating the target hazard quotient caused by heavy metal exposure by ingestion. So these are the different values of different parameter which was used in that formula. So these are the result of health risk analysis. So if the THQ target hazard quotient is equivalent to 1, that means there is no health risk. But if exceeds value of 1, it indicates that there is some health risk. So I have calculated THQ in children as well as in adult. So from here we can see the different, these are the different vegetables. So we can see that some vegetables, they are having higher THQ value.
Ma'am.
Okay. Hanji.
Ma'am,
Okay,
please
okay,
sum
I'm
up the
trying to.
presentation as fast as you can.
Okay, okay. Okay, ma'am. So these are conclusion. Iron was the most prominent metal, followed by aluminium, manganese, and zinc. And cobalt was the least reported metal in the present study. Concentration of iron, cobalt, lead, nickel, cadmium, and zinc were above the permissible limit set by FAO WHO in the most of the vegetable samples. Statistical analysis I have already explained. Mustard consumption may pose a health risk due to high content of aluminum, chromium, iron, and lead, which was shown by the metal pollution index calculation. So THQ value was greater than 1 in most of the vegetables, which suggests that there can be health risk to specifically to the children by the consumption of these vegetables. Thank you. These
Good
are
work,
the
Jyoti.
hands.
Good work.
Okay, so
Sir,
question
thank you so
session
much.
is.
I am thankful to the organizer for giving me chance to present here. Thank you
Okay,
so much.
so question session is open for the audience. If anybody wants to ask any question, he or she can. No one? So now we have.
Thank you, sir. Thank you.
Okay, okay. Thank you so much, ma'am, for joining us. And the next abstract ID is IC 281 Yavate TP. He's not available now. And next abstract ID we have IC 161 Anita Meena. I repeat,
Yes,
abstract
ma'am.
ID 161 Anita Meena.
Yes,
Hello,
ma'am.
ma'am. Good morning.
Good morning, ma'am.
Anita Meena, try to have your video and your presentation.
Yeah, okay, sir. Okay, sir.
Okay, ma'am. Now you can start your presentation, and there is an instruction for you. Please sum up your presentation within 3 to 4 minutes because we have very shortage of time. Okay, it's my
Okay,
humble
ma'am.
request to you. Okay.
Okay.
So directly go to the research work.
Yes.
Myself, Anita Meena, and I am doing research work under the supervision of Professor Puran Kohli, Janardas University, Jodhpur.
Avoid
Solar
introduction. Go to research work.
Yes. Indiocarmine and ascorbic acid and NaOH were used in this cell, and all the solution was prepared by the direct weighing in double distilled water and kept in the kept in container to protect from the direct light. Role of reductant and dye sensitizer in photogalvanic cell was studied using S-shaped cell which contained known amount of solution of indiocarmine, ascorbic acid and NaOH distilled water and double distilled water, so to keep total volume of the mixture constant at 25 ml. And in this cell, platinum electrode and saturated calomel electrode were used. Platinum electrode were used as working electrode and saturated calomel electrode used as counter electrode. The terminals of electrodes connected to a digital pH meter. The entire system was first placed in dark until a stable potential is reached. Then sir, oh, sorry, sir.
Can you enlarge your slides?
Just wait. The entire system was first placed in dark until a stable potential is reached. Then the limb containing platinum electrode exposed to the light source and a micrometer connected through a key was used to close one circuit and open to other with resistance so as to measure the photocurrent of the solution on illumination. The photochemical bleaching of indiocarmine was studied potentiometrically. So this is the mechanism. This is in this system my topic is role of reductant. So reductant plays important role in generation of energy which reduce sensitizer species in the electrolyte. The quantity and quality of reductant affect the efficiency of photogalvanic cells. The electron exchange property of the reductant between sensitizer molecule and reductant molecule is governed by the relative redox potential of the sensitizer and reductant molecules. Reductant provide electrons to photosensitizers. For this system, in which ascorbic acid was used as reductant and indigo carmine was used as dye sensitizer is reported with electrical output, and potential was 580 microvolt and current was 160 microampere and power was 92.80 microwatt. For given reductant, there is an optimized quantity of the reductant at which the efficiency of cell is optimum. The electrical output of the cell is reported to be affected by the variation of reductants concentration.
Okay, so anybody wants to ask any question, he or she can. Question session is open for the audience. No one? So next abstract ID is IC 164 Kamal Kant Vyas. Hello sir, good morning.
Yes,
Share
ma'am.
your screen.
Good morning.
Please share your screen. Your presentation, I mean to say.
I am sharing.
Okay. And sir, there is an instruction for you. Please sum up your presentation within 3 to 4 minutes.
Okay,
Because
ma'am.
we have very shortage of time, so it's my humble request. Okay.
Enlarge your slides. Expand your slide.
Sir, visible है?
Yes, sir,
Visible, but
yes, it is visible, but make it full screen, sir.
Now?
It is not slide mode. It is not in the mode.
Yes,
Sir, please press
Sir,
F5.
click on
Press
slideshow.
F5.
F5, जी sir.
Yeah. Now it is fine, sir.
Yes, yes,
Now
okay.
we can start.
Welcome to all of you. My research work on synthesis of bioactive benzimidazole and research scholar, Department of JNU, Rajasthan University, JNU Jodhpur, and work in under supervision Dr. Sangeeta Rajpurohit ma'am, Associate Professor.
Better avoid introduction, go to research work.
Okay, sir. My slide is not large, sir. I completed in 5 minutes.
Yes.
Benzimidazole are a class of heterocyclic aromatic compounds, which is fundamental characteristics of 6-membered benzene fused to 5-membered imidazole moiety. Benzimidazole moiety have biological, clinical, pharmacological properties, which are anti-diabetic, anti-cancer, antimicrobial, anti-parasitic, anti-analgesic, antiviral, and antihistamine, as well as used in cardiovascular disease, ophthalmology, etc. Benzimidazole nucleus is one of the bioactive heterocyclic compounds that exhibit a range biological activities, specifically this nucleus is constituent of vitamin B12. The pharmacological activities of benzimidazole containing moiety have been well documented. Albendazole, mebendazole, and thiobinazole are widely used as anthelmintic drugs. Heterocyclic compound is a class of cyclic organic compounds, those having at least one heterocyclic ring system. The most common heteroatoms are nitrogen, oxygen, sulfur. Heterocyclic compounds are frequently abundant in the plants and the animal products, and they are the one of the important constituent of the almost 1/2 of the natural organic compounds. Next, overview of history. The first benzimidazole are prepared 1872 by Heubacher, who obtained 2,5-dimethyl benzimidazole by the reduction of 2,4-nitro-4-methyl acetanilide benzimidazole, which contain a hydrogen atom attached to nitrogen in one position shown in the figure, and it is the tautomeric form of the benzimidazole shown in the figure. Next, benzimidazole was synthesized by orthophenyl diamine 12 millimole and phenyl glycine 36 millimole were distilled in 4-NaCl 4 ml and refluxed 4R, then cooled at room temperature. The resulting brown solid was filtered and washed with water dried in vacuum and recrystallized from acetone. And this reaction is Mannich-base reaction. It is the preparation method. Pharmacological profile of benzimidazole. The pharmacological application of benzimidazole analogous found potent inhibitor of various enzymes involved and therapeutic uses including as anti-diabetic, anti-cancer, antimicrobial, antiviral drugs. There are some examples of benzimidazole based drugs: omeprazole, bendamustine, albuterol. Thanks to all.
Okay, so question session is open for the audience. If anybody wants to ask any question, he or she can. Nobody? Well, next abstract ID is IC249 Hansa Mathur. I repeat, IC249 Hansa Mathur. Okay, she's not with us. And the next abstract ID is IC189, sorry, IC183 Saloni Sahal. I repeat, IC183 Saloni Sahal. I think she's not also with us. And the next abstract ID we have IC162 Nashir. I repeat, IC162 Nashir. I repeat, IC162 Nashir. I think he's not also with us. And the next abstract ID we have IC144 Renu Joshi.
Yes, ma'am. I present here.
Hello, Renu ma'am. Good morning to you.
Renu, your video, Renu, your video is not on.
Yes, sir.
Your
Yes,
video
sir,
is
yes,
not
sir.
on. Video on karo or presentation on karo.
And please sum up your presentation within 3 to 4 minutes, okay? It's my humble request to you.
Okay, ma'am. Okay, ma'am.
Because we have very shortage of time, so. Ma'am, please share your screen and start your presentation. Renu ma'am, am I audible to you?
Yes, ma'am. Can you share me, ma'am?
Okay, please share your screen.
Ma'am, visible to my slide?
No.
Ma'am, can you see my slide?
Sorry, please repeat.
Ma'am, your screen is not visible to us. Hello, ma'am, your screen.
Yes, sir. Yes,
Your,
sir.
your screen is not visible to us.
Sir, I can't try.
Okay, ma'am, we will take you in last. And the next abstract ID we have IC140 Pooja. I repeat, IC140 Pooja.
Hello, ma'am. No, ma'am. I'm free. IC 183 Saloni Sahel.
Sorry?
IC 183. Actually, उस टाइम मेरा नेटवर्क इशू था तो हो नहीं पाया कनेक्ट.
Okay. So what's your name?
IC 183 Saloni Sahel.
Okay, ma'am, continue.
Let me check. IC183, right?
Yes, ma'am.
Okay, so you can start your presentation.
Okay, ma'am.
And please sum up it within 3 to 4 minutes, okay? We have very shortage of time.
Okay, ma'am.
You're not visible.
Wait, sir, I'm doing. Yes, sir. Sir, now I'm visible. My screen is visible.
But you're not visible.
Wait, sir. I'm doing. Okay. Good morning, sir. Myself, Saloni Sahal, and I'm doing my research work on the fissile and green synthesis of bioactive heterocycles from Modi University, Lakshmangarh, under the supervision of Dr. Sarita Katuria ma'am. Okay, sustainable chemistry. Green chemistry is also known as the sustainable chemistry, and there are 12 principles of sustainable chemistry. Paul Anastasis is the father of the green chemistry. Sustainable chemistry is a scientific concept that seeks to improve the efficiency with natural resources are used to meet human needs for chemical products and services. And it reduces the negative impacts of chemical products and processes on human health and the environment. Benefits of sustainable chemistry. Sustainable chemistry is also known as the green chemistry. Avoiding the use of persistent, bioaccumulative, toxic, and otherwise hazardous materials. Using renewable resources and decreasing consumption of non-renewable resources. Minimizing negative environment impact of chemical processing and manufacturing, providing technologies that are economically competitive for and advantageous to industry. So here they are the 12 principles of green chemistry. Waste prevention, atom economy, less hazardous chemical synthesis, designing safer chemicals, design for energy efficiency, safer solvents, and use of renewable feedstock, reduce derivatives, catalysis, design for degradation, real-time pollution prevention, and safer chemistry for accident prevention. So here the green chemistry. Green chemistry is design of chemical products and processes that reduce or eliminate the genus of hazardous substances. Now we come to the nanocatalyst. What are nanocatalysts? Nanocatalyst is a rapidly growing field which involves the use of nanomaterials as catalysts for a variety of homogeneous and heterogeneous catalysis applications. A catalyst composed of nanoparticles smaller than 100 nanometer is at least one-dimensional porous compounds having. So here are the properties of nanocatalysts. They are energy efficient, they are safer reagents, minimum chemical waste, it reduces global warming, high activity, improved economy. So the advantage of nanocatalysts. The higher activity and better selectivity of nanocatalysts over traditional catalysts are attributed to their large specific surface area, high percentage of sulfur atoms, and special crystal structures. Now, how we synthesize nanoparticles? Nanocatalyst. Okay, I have worked on this nanocatalyst and synthesized the many nanocatalysts. So we will take the fresh leaves of plants, then finally cut them, and after that we will heat on the hot plate. Then we will filtrate the extract, and then we will take the precursor solution, and then we will add the leaf extract and precursor solution. Then we will do the magnetic stirrer for the 2 to 3 hours, and then we will evaporate of nanoparticles, and then we will characterization of nanoparticles. Green solvents. Green solvents are environmentally friendly solvents or biosolvents which are derived from the processing of agriculture crops. The use of petrochemical solvents is the key to the majority of chemical processes, but not without severe implications on the environment. Green solvents were developed as a more environmentally friendly alternative to petrochemical solvents. For example, we will take the ethyl lactate. For example, is a green solvent. Ethyl lactate is a green solvent derived from processing corn. They are environmentally friendly solvents or biosolvents which are derived from the processing of agriculture crops. Lactic ester solvents are commonly used solvents in the paint and coating industries and having numerous attractive advantages, including being 100% biodegradably, easily to recycle, and they are non-carcinogenic. Now we come to the point green materials. Green materials are materials that are local and renewable. Local materials often are unique to the place and connect whatever people make within an area of region. Materials from the ground such as clay, sand, stone, and green materials are found underfoot. Humans also uses grasses, straw, wood, and bamboo for the building shelter objects and spaces. Manufacture of currently used materials is quite difficult as regards consumption of energy, raw materials, and cost. Therefore, there are the efforts for finding suitable alternative material sources, while local, easily renewable resources are to the advantages alternative to the condition of consequent processing with low energy requirements. So the green chemistry is about reducing waste, material, hazard risk, and energy, and it required less cost. Thank you.
Well, question session is open for the audience. If anybody wants to ask any question, he or she can. No one? Well, next abstract ID, we have IC 112, Saurabh Bhattacharya. And thank you, ma'am, for joining us. I repeat, abstract ID 112, Saurabh Bhattacharya. Sir, are you there?
Yes, yes, sir. Yeah. Yes.
Okay, good morning, sir.
Good morning.
You're not visible.
Sir, there is an instruction for you. Please sum up your presentation within 3 to 4 minutes, but just because of we have very shortage of time. Okay?
Oh, okay, okay, sure.
You're not visible.
So is it okay now?
Okay.
Sir, please make it full screen.
Okay, now is it on full screen now?
Yes, yes.
Okay. Thank you. Good morning, everyone. So my topic is fabrication and characterization of solar indoor air purifier system by interfacing lignin-based air filter. I quickly go to the research side and don't waste time on introduction. So let's objective is to design an air purifier which can purify contaminants without consuming any electricity, and to develop an also solar air purifier with bio air filters. Right. So this is the basic layout. So first, in my system, solar radiation, from solar radiation, solar panel will absorb heat energy and then transfer this heat to solar air purifier. The purifier I developed is of lignin-based bio air filters. There are basically conventional air filters available in the market, that is HEPA and non-oven filters. So what this will do, this will measure the indoor air pollutants, and this will minimize the pollutants as in the filter. This is a FTIR of lignin that is we have prepared in the laboratory. This is the FTIR of HEPA filter. These both are conventional and non-conventional air filters, and we can see there is a structures, chemical structure are ratherly same. So this is the TG of the air filters, both of HEPA and the lignin alkaline based air filters. These are the pollutants level measured from the air quality monitor. Then we have done some artificial machine learning. In this linear regression model was developed, and R square of around 0.23 was based, and then the result was that with solar air panel, so we can purify indoor air pollutants, and then chemical behavior of both lignin and non-conventional air filters are quite same. This is the design of solar air panel model. The first figure is of lignin, second one is of HEPA, and the third one is of non-oven filters. These are references. And lastly, I want to end my slide with a quote that a transition to clean energy is to making an investment in our future, by Gloria Ruben. Thank you.
Okay, so question session is open for the audience. If anybody wants to ask any question, he or she can. No one? So thank you so much, sir, for joining us. And the
Thank you.
next abstract ID we have IC 140 Pooja.
Hello, ma'am. Good morning.
Good morning, ma'am.
You're not visible, Pooja.
एक second.
Okay. So please share your screen, and there is an instruction for you. Please sum up your presentation within 3 to 4 minutes. Okay.
Okay, ma'am.
Okay. Please share your screen.
1 minute, ma'am, only. Ma'am, I'm trying.
Okay.
Now visible, ma'am?
Yes, it is visible.
But it is not the slide mode. Bring it to slide mode.
Yes.
Visible, ma'am?
Yes.
It is visible, but make it full screen, ma'am.
Ma'am, I'm using my Android phone, so here are no option of full.
Okay. Now you can start.
Good morning, everyone. I'm Pooja. I'm working under the supervision of Dr. Neeraj Dilbaghi. My presentation on studies on antimicrobial effects of eugenol nanoemulsion as sustainable biopesticide aiming pest control. I start with the introduction. Guar or cluster bean is a drought-tolerant annual legume crop that grown in arid and semi-arid regions. The world demand for guar increased, which leads to introduction of guar in other countries also. The major suppliers are India, Pakistan, the United States, Australia, and Africa. Guar gum have many industrial applications like in construction, textiles, cosmetic and pharmaceuticals, paper, oil field mining, and oil well drilling and fracturing. Guar gum also have some food applications in bakery product, in soup and beverages, in dairy products, in meat industry, and in condiments and packaged mixers. But guar suffers from many diseases like alternaria leaf spot, charcoal rot, bacterial blight. These diseases can be prevented by selecting disease-resistant varieties and high-quality seed, and can be controlled by using pesticide. But the problem with the pesticide, this increased dependency on this pesticide has generated serious issues like sustainability, environmental effect, and health hazards. Synthetic agrochemical use also shown adverse effect on soil structure, fertility, mineral cycles, soil and microbial flora, and pest resistance. So we used biopesticide and biofertilizer. All these adverse effects do demand for safe, variable, and eco-friendly biopesticide or biofertilizer to replace hazardous chemical pesticide. But these pesticides also have some major issues of poor shelf life, performance under alternating environmental conditions, most importantly, the high required dose for maximum coverage area. Modern farming is grasping the novel approach of nanotechnology to fight overall difficulties of crop yield production, sustainability, food preservation, and environmental effect. Nanoformulation usage increase efficiency towards pest controlled release, potential lower risk to environment, low pest resistant, and increase solubility of poorly water soluble drugs. Here are the preparation and optimization of eugenol nanoemulsion. First of all, we synthesize phytonano formulation. Then we go for characterization for particle size and zeta potential, and then we go for transmission electron microscopy. Here are the composition. We take eugenol 300 microliter, gum arabic 50 mg, drug 30 mg, fixed oil 300 microliter, lecithin 75 mg, STS sodium dodecyl sulfate 10 mg, and water 30 ml. Then we prepare nanoemulsion by using two methods, high energy method and low energy method. High energy method require high mechanical energy and low energy method require low mechanical energy. In high energy method, we use probe sonication, bath sonication, and in low energy method, we use steering. Here are the results of particle size by using dynamic light scattering. Particle size of my nanoemulsion was 164.1 nanometer and result was good. And second nanoemulsion 134.8 and result was also good. Then we go for zeta potential. Zeta potential of first nanoemulsion was minus 27.5 and second nanoemulsion was minus 32.6 and result was good. Then we go for transmission electron microscopy and achieved spherical shaped morphology of nanoemulsion. Then we go for bacterial isolation by collecting infected leaf sample and isolate bacterial strain. Then we form glycerol stock for further evaluation, and we identify bacteria by gram staining and photomicroscopic examination. Here are the results of bacterial isolation. These are the slants, and photomicroscopic examination reveals gram-negative bacteria, rod-shaped pink color. And then we go for antimicrobial activity test using agar well diffusion method. In vitro antibacterial activity, first of all, we prepare nutrient agar media, then we pour into petri plates. Then after solidifying, we add nanoemulsion based agrochemicals and microbial dilution. Then we swill the mixture and incubate at 32 degrees Celsius for 48 to 72 hours. And then we identify colonies growth on medium surface. Thank you so much, ma'am.
The question session is open for the audience. If anyone wants to ask any question, he or she can. No one? Okay, then next abstract ID is IC 299, Jyoti Yadav. And thank you so much, ma'am, for joining us. Okay, I repeat again, IC 299, Jyoti Yadav. I think she's not available now. And the next abstract ID we have IC 131, Inendra Singh.
Good morning, ma'am.
Good morning, sir. Okay, now you can start your presentation and please sum up it within 3 to 4 minutes, okay? Just because we have very shortage of time, so.
Okay, ma'am.
Okay.
Good morning, everyone. Myself, Anandra Singh from Botany Department, Government Dungar College, Bikaner. My research title is the...
You're not visible.
Oh. Okay, sir.
Okay.
My research title is the Cyanophycean diversity from Guardium, Jhunjhunu, Rajasthan. Okay, Cyanophyceae is the largest group of structurally complex and ecologically significant algae which flourish in lotic and lentic water bodies and play a major role in sustaining the fertility of ecosystem. Cyanobacterial taxonomy has diverse and great diagnostic importance in floristic analysis as well as basic applied aspect of the research. In the present study, Coat Dam, situated in Coat village, is Udaipurwati Tehsil, Jhunjhunu, selected. That dam lies across the Sakambri Hills in between 27 degree 39 north latitude and 75 degree to 25 minute east longitude. Critical study has been made on biodiversity studies of Cyanophycean in Coat Dam, Jhunjhunu during the period of July 2019 to June 2020. Algal samples were collected by the help of phytoplankton net and sample bottle at monthly intervals from different sites of dam during of investigations. Micrometric measurement with the help of stage and ocular micrometer has been taken and camera lucida diagrams were made for the morphotaxonomical identification with the help of standard monograph identification of 25 fresh algae Cyanophycean species belonging to 12 genera such as Crococcus, Gbsa, Gleothis, Ephenothes, Microcystis, Merismopodia, Oscillatoria, Arthrospira, Anabina.
Directly go to your research work.
Yes, sir. Okay. Basically, my research work related to algal diversity. Biodiversity is the measure of variety of organisms present in various ecosystems. The abundance and richness of biodiversity depend on climatic conditions and area of region. Algae and other phytoplanktons have important position in aquatic life and serve as a direct source of food to the other aquatic plants and animal. Algal analysis is a very useful for assessment of water quality in any type of water body and also contribute to understanding the basic nature of the aquatic systems. Micrometric measurement with the help of stage ocular and micrometer has been taken. Camera lucida diagrams. Morphotaxonomical identification with the help of standard monograph such as Prescott, Gonzalez, etc. My research work related to Cyanophyceans member belonging to 12 genera and 25 species in Coat Dam, Jhunjhunu. Out of these, Oscillatoria is the dominant species in Coat Dam, Jhunjhunu. Some plates show the different algal species that Spirulina, Anabina, Gloethisa, Pseudoanabina, that are references. Thank you, sir.
Thank you so much, sir.
Ma'am, IC 144 can share to my presentation.
Please repeat that.
Ma'am, IC 144 Renu Joshi.
Okay, you want to present your presentation, right?
Thank you, ma'am.
Ma'am, please may I know your name?
Renu Joshi.
Renu Joshi. Okay. Thank you, ma'am.
Ma'am, can you see my slide?
Yes, I am.
Hello.
Hello, ma'am.
या switch your window switch करो आपकी. हाँ, आप ऊपर वाली पे टैप. हाँ, now it is visible. Please continue. Please continue now.
Yes, sir. Sir, my name is Renu Joshi, under provision Array Frequency, Department of Chemistry, General and Vast, University, Jodhpur. My topic name is to synthesize newly cellulose-based resin, cellulose mandelic acid, and study on treatability of zinc metal ion or CMA resin.
Madam, show your PPT. You have switched the screen. Show your PPT.
Sir, I can show, but not it.
टास्क बार वाला बटन दबाओ आपके फोन पे, पीपीटी आ जाएगी, उसको टैप कर लो बस. हाँ
सर मैंने
हाँ नाउ हाँ या अब इसको मत हटाना, चलने दीजिए. ठीक है.
ओके. Okay, sir. Material and method: stock solution or synthetic wastewater preparation. Stock solution of zinc metal ion. The working solution of zinc second ion was prepared using zinc acetate. In a few ml of acetic acid, 3.35 gram of zinc acetate was dissolved in a volumetric flask. It was then produced up to 1000 ml. It produces zinc solution with a concentration of 1000 ppm. This stable absorbance of zinc metal ion, maximum absorbance of 0.5617 and 18 ppm, and lower absorbance is 0.09 is 4 ppm.
The slide is not visible.
Yes, sir. सर मैंने शो कर दी बट सर
स्लाइड नहीं आ रही है.
सर बट मैंने शो कर दी इसको यहाँ से.
No problem, ma'am. You can continue.
Okay, ma'am. Thank you, ma'am. Absorbance of zinc second, absorbance graph is absorbance and concentration. This is show calibration curve of absorbance. After converting cellulose derivative, produce of ion concentration from then was resined with water to eliminated excess acid and dried overnight at 55 to 60 degrees centigrade. Each flask received 0.1 gram of resin, which was placed in one of 7 flasks with a declining water amount of 1 NaCl solution and increasing amount of 0.1 NaOH. Finally, each flask was filled with deionized water to make the total capacity of each flask is 25 ml. All tightly closed flasks were equilibrated with the magnetic sphere until the solution hit the maximum pH value. A digital pH meter was used to determine the pH value of each ion. Next, synthesis of cellulose mandelic acid resin. This process is preparation of cellulose epoxy propyl ether and preparation of cellulose mandelic acid resin. This reaction showed the polysaccharide CMA resin. Distribution coefficient of different thick metal and newly synthesized resin Kd value is the following formula was used to compute the distribution coefficient. Kd equal to amount of metal ion resin phase per amount of dry resin in gram, total amount of metal ion solution phase and volume of solution in ml. Next, zinc second ion chelation of CMA resin. Appropriate amount of 0.2 m sodium acetate and 0.2 m acetic acid were introduced to several glass stoppered conical flasks to obtain buffer with the reached pH raised to 2 A suitable amount of 0.2 m ammonium hydroxide and 0.1 m ammonium chloride were also introduced to other glass stoppered conical flasks to achieve a pH 8. This graph is this graph shows Kd value of zinc metal ion CMA resin. Result in discussion: 11% moisture content for CMA resin and 3.45 ion exchange capacity of CMA resin. Heavy metal ion removal from aqueous solution and industrial influent is very selective with resin CMA. Based on the finding, it can be tested with pH rise to 8 pm. Acknowledgement: Dr. Arish Vikram Singh, Professor, Department of Chemistry, General Vast Visyadhyalay, Jodhpur. Thank you, sir.
Okay, so thank you so much, ma'am. And anybody wants to ask any question, he or she can. Question session is the open for the audience. No one? Well, next abstract ID is IC 167 Shilpa Yadav.
You should try to finish this by 10:30 because we have a lecture.
Yes, sir. Of course.
And then tell the other people to come at 1 o'clock.
Okay, okay. Well, next abstract ID is IC 174 Parmendra Kumar Chauhan. I repeat, IC 174 Parmendra Kumar Chauhan. So, well, next abstract ID is IC 175 Satpal. I repeat, IC 175 Satpal. I think he's not here. And the next abstract ID is IC 297 Yudhishthir Vaishnav.
Hello.
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 Hello. Yes, sir.
Can you hear me, ma'am?
Yes, I can. And what's your name, sir?
My name is Yudhishthir Vaishnav, and I'm sharing my PPT.
Yeah.
Sir, there is an instruction for you. Please sum up your presentation within 3 to 4 minutes. We have very shortage of time, okay?
Okay, ma'am. Can you see the PPT on your screen, ma'am?
Yeah, we can see.
Not yet.
Yeah, we can see. Continue,
Okay.
please.
Now it is.
Okay, sir. Okay.
Okay.
Myself, Yudhishthir Vaishnav. I am a research scholar under supervision of Dr. Sangeeta Rajpurohit, which is an associate professor in Lachu Memorial College and Department of Chemistry, Jain and Vyas, Jodhpur. And my recent topic is synthesis of bioactive thiazole. And the outline and my work is the introduction is out of all the heterocyclic compounds, thiazole has more importance in manifold pharmacological activities. Synthetic drug such acinitrazole, penicillin, valamycin, thiazafirin, ritonavir, nizatidine contain thiazole ring. Thiazole ring is a 5-membered unsaturated planar pipe.
Directly go to your research work.
Sir, actually, I have no much more slides, only 5 to 6 slides. So if you permit, then.
Okay.
Thiazole is a 5-membered unsaturated planar pi-excessive heterocyclic containing 1 sulfur atom and 1 pyridine type nitrogen atom at a position 3 of cyclic ring 1,3-thiazole. And the importance of this ring, this compound is in vitamin B1 possesses a thiazole ring linked with 2-methylpyrimidine 4-amine. And chemical stability and light absorption properties have stimulated the search for new dyes containing thiazole ring system. Thiazole nuclei having importance in development of a class of bioactive heterocyclic which exhibit wide range of the biological activities. And the methodology which is shown in our screen, a copper catalyzed 3+1,1 type condensation of oxime anhydride and potassium thiocyanate KSCN provide thiazole in very good yield under mild condition, which is given in this reaction we can see. And the second method which is applied in my experiment, which is copper catalyzed oxidative multiple sp3 hybridized hydrogen bond cleavage process achieve a synthesis of thiazole from simple aldehyde, amine, and element sulfur in the presence of molecular oxygen as a green oxidant. And antimicrobial activity, which is done, final product were tested for their in a vitro growth inhibitory activity against human pathogenic microorganism as gram-positive bacteria and as gram-negative bacteria, Escherichia coli. Amphenicol and ketoconazole were used as a control drug, and the result and conclusion is as follows. The thiazole, including compounds, were synthesized. All compounds were screened for their antimicrobial, antifungal, and anti-colonizasis activities. None of the compounds showed prominent anti-colonizasis activities. So thank you. This is my PPT presentation.
Okay, anybody wants to ask any question? No? Okay, thank
Can
you
I
so
present now? IC 249.
Ma'am, please tell your name. Yeah, ma'am, you can start your presentation now.
Ma'am, is it visible now? My screen?
No, ma'am.
You know, Dr. Das is waiting for a lecture.
Ma'am, is it visible now?
No, ma'am.
You can ask her to come at 1 o'clock.
Okay, so no problem, Hansa ma'am.
Hello?
Okay, now you can start, ma'am, but just please remind that you only have 2 to 3 minutes, okay?
Yes, ma'am. Within 3 minutes, I'll complete my presentation.
Okay.
Very good morning to all the
Anita और है, Anita भी है.
Very good morning to.
हंसा चल रही है अभी.
Yes, sir. Yes, sir. Very good
हंसा
morning
चल रही है,
to.
Anita बच्ची है.
Sir, can I present now?
चलो.
A very good morning to all the respected dignitaries and all the participants. My name is Hansa Mathur and I am doing PhD from Modi University of Science and Technology, and my abstract presentation is on the topic role of biotechnological approaches in sustainable environment development. Moving on, we all know that the biggest challenge the world is facing now is environmental pollution. So the environmental pollution is nothing but contamination of physical and biological components of earth or atmospheric system to such an extent that normal environmental processes are adversely affected. Globally, environmental pollution has increased due to intensive anthropogenic or human activities, along with the emergence of new materials and compounds that were previously not seen in nature. Moving on to my next slide, which is on microbes. We all know that microbes are used to clean up pollution treatment in the process, and microbes includes bacteria, fungi, actinomycetes, etc., which are very useful in cleaning up this process. Because of the time constraint, I am taking only one approach of this eco-friendly approach, which is bioremediation. Bioremediation is the use of biological system for reduction of pollution from air, aquatic or terrestrial system. As I have present this flow chart that how microorganisms are eco-friendly or effectively degrade the pollutant product completely, and if it is in incomplete process, which is through physical or chemical treatment, there is another hazards which is created, and one of the incomplete degraded product is vinyl chloride. So bioremediation is used to remove hazardous waste which has already polluted the atmosphere. These are certain contaminants which are potentially amenable to bioremediation. These are further categorized in 4 categories. I'll just give an example. The compound which is readily degradable are fuel, oils, or gasoline. These are easily degraded by bioremediation process. The compounds which are somewhat degraded are polyphenol, pentachlorophenol, and some of the compounds which are recalcitrant or which has been not degraded by biological approach. These are polychlorinated biophenols. To sum up my presentation, I would like to mention some advantages and disadvantages of bioremediation. First one is advantages, which is like it is less time consuming process, less efforts are there, cost effective, no use of dangerous chemicals is being used, positive public acceptance, because it is, physical and chemical treatment methods use certain hazardous chemicals as well. Now, disadvantages of bioremediation, it is restricted, toxicity of contaminants still there, potential production of unknown byproducts, extensive monitoring requirement, and site-specific requirement. In conclusion, I would like to conclude that it is an effective application, ecological acceptance, cost-effective. Bioremediation utilizes microbes such as bacteria, fungi, yeast, algae, and some plants, and last but not the least, minimal exposure of contamination to humans. Thank you.
Okay, thank you so much, ma'am, for being present here. Now, I would like to inform you all the participants that
I usually try to finish everything here.
Yes, sir. Yes, sir.
Try to finish.
Yes, sir. Next,
later on, you will not get time.
Yes, sir. Yes, sir. Remaining presentation we will take around 12 o'clock. Okay.
No. Take all now. Take all. Finish it.
Now.
I should take all and finish it.
Sir, only 4 or 5 participants are remaining. So
let them present.
Okay, sir.
Because then you will not get time.
Okay, sir. So now next I would like to invite abstract ID 177 Khushi Sharma. Okay, she's not there. So next we have Bhupendra Kumar Verma. I repeat, Bhupendra Kumar Verma. Okay, he is also not with us. So next we have the abstract ID IC 142 Renu Dayal. Okay, so next we have the abstract ID IC 173 Pradeep Kumar Rajput. He's also not present. So next we have the abstract ID IC 132 Garima Sharma. Okay, so now next abstract ID IC 177 Khushi Sharma. Okay, so next
Ma'am,
yes.
please allow me to present my paper.
Ma'am, first tell me your abstract ID and your name.
116 Savita Meena.
Okay, ma'am, you can start now. But just remind that you
Thank you,
only
ma'am.
have 2 minutes, okay?
Okay, ma'am. Okay, ma'am.
Okay, thank you. Ma'am, please share your screen.
1 minute.
Yeah.
It is visible?
Yes, you may start now.
Okay, ma'am. Good morning, all of you. Myself, Savita Meena, and my topic is efficient and rapid photocatalytic degradation of direct 23 and methylene blue dye with metal doped cadmium sulfide nanoparticle under visible light irradiation.
Ma'am,
This
please
is
show
the
your
introduction
full screen.
part.
Ma'am.
It is okay, ma'am?
Yes, no, it's okay. You can start.
This is the introduction part. Types of wastewater. There are 3 types of wastewater: industrial, domestic, and stormwater. Industrial from textile, cosmetic, pharmaceutical, agriculture industries, and domestic from bathroom, laundry, kitchen, and stormwater from rainwater, parking lots, roads, and buildings. Nowadays, textile industries are major source of the global economy, but unfortunately, these are also the major source of environmental pollution.
Gbsa, can you go
This is
directly
the
to research work?
Okay, sir. This is my research work. In laboratory, we have synthesized copper doped cadmium sulfide nanoparticle by using wet chemical method. In this method, at room temperature, 1 m solution of sodium sulfide and 1 m solution of cadmium sulfide was added drop by drop simultaneously into 200 ml of distilled water containing 0.1 m solution of EDTA. The above solution was vigorously stirred on magnetic stir. After stirring, nanoparticle of cadmium sulfide were prepared. The doping of copper has been done by adding 2% of copper sulfate beginning of the reaction. For the formation of copper doped cadmium sulfide nanoparticle, the precipitate was separated from the reaction mixture and dry was at the room temperature. And this method is based on green synthesis. Easily these catalysts are easily separable, reusable of the catalyst, and low cost this method. These are the characterization of prepared nanoparticle. This is the time image, UV spectrum, EDAX spectrum, FTI spectrum, histogram, and this is the recyclability of the nanoparticle after using in reaction. These are the characteristic of direct 23 dye. This is the structure of direct 23 dye. These dye has 2 diazo bond and properties. These are the properties of direct 23 dye. Color red in color, nature acidic in nature, soluble in water. This is the molecular weight and this is the wavelength. Application of this dye. This dye used in wood, cotton, silk, paper, and leather industry as a colorant. And this is the effect of direct 23 dye. Causes persistent toxicity, carcinogenic, teratogenic, and mutagenesis. This is the process of directed 23 dye degradation by using copper of cadmium sulfide nanoparticle. In empty beaker, we take 12 ml of dye solution and adding prepared nanoparticle, and this solution put on the magnetic stirrer and after some time this solution was colorless, and this reaction mixture centrifuge for the removal of nanoparticle, and this is the optimal condition of the reaction. The best result found in basic solution in basic medium pH is the 9, and the reaction degradation was completed within the 30 minutes. This is the possible mechanism, and there are active species such as superoxide radical anion, hydroxyl anion, and electron holes are responsible for the degradation of dye. This is the conclusion, and best result found in the basic media, and these catalysts are responsible for the dye degradation. Thank you.
Okay, thank you so much, ma'am. So now we have the next abstract ID, IC 177, Khushi Sharma.
There's what Anjali there?
Yes, sir.
There's Anjali there, Anjali.
Okay, sir, but Khushi Sharma is ready. Okay. Now, Anjali.
Oh, go ahead.
You can hear me, Anjali?
Hello, good morning, ma'am.
Good
Yes, ma'am, I
morning.
can hear you.
Yes, you can start your presentation, ma'am.
Okay, sure, ma'am.
Yeah.
What is the number?
Abstract ID number, sir, IC 247.
Okay,
Yes, sir.
go ahead.
Yes, sir. I'm sharing my screen now.
You are not visible.
Sir, 1 second.
Bring it slide mode. It is not. Yeah, okay.
Sir, is it visible full screen now?
Yes.
Okay,
Yes,
sir.
it's visible, and you are not visible.
Sir, I'm not visible. Sir, 1 second.
Go ahead.
Good morning to all. Myself, Anjali, PhD research scholar in the Department of Biosciences at Modi University of Science and Technology, Lakshmangarh. Today, I'm here to present my abstract on the topic entitled as the miraculous antimicrobial potential of medicinal plants as herbal antibiotics. So starting with the introductory slide, now the problem root cause, I'll be discussing about the antimicrobial resistance. So it generally refers to the ability of the microorganisms such as bacteria, viruses, and protozoa.
Anjali, can you directly go to your research work?
Sir, actually it's the basic, and these are some of the basic slides and I have not updated my results here.
Okay.
Yes, sir. So I'll be continuing with these only.
Okay, go ahead.
Yes, sir. So these persist in the body or the environment after the exposure to an antimicrobial agent, and it naturally occurs as a result of the constant microbial genetic mutations, and exposure to these drugs, especially due to the inappropriate use of such drugs, these raise the risk that existing therapies will be rendered ineffective by exerting selective pressure that eliminate the microbes that are sensitive to the drugs and allow those that are resistant to survive and potentially thrive. So it's all. So it is a matter of concern.
Mukesh.
Yes, sir. Resistant organisms leads to treatment. Increased mortality, resistant bacteria may spread in community, low level resistant can go undetected, and added burden on healthcare costs. So reminding these points of concern. So now we should focus on some of the plant-based, some medicinal plants we can use so that these points can be taken in to concern. So we all know that India is blessed with a fashionable wealth of medicinal plants, and these have created smart contribution to the event of ancient Indian system of medicinal drugs. And about 60 to 80% of world population rely on plant-based extracts,
Excuse
and
me,
that
ma'am.
is why it is. Yes, ma'am.
Sorry to interrupt you, but your time is over.
Ma'am, it's just now the conclusion part is only there.
Okay, please.
Ma'am, just 1 minute I need. Yes, ma'am. So it is growing with great economic importance, and obviously in contrast to synthetic modern medicine, these plants as medicine being living in organic, these constitutes various balancing ingredients, and these do not show any allergic reactions or the side effects, and these are eco-friendly and naturally available. And in respect to synthetic modern medicine, these are non-living, inorganic, not eco-friendly, and mostly expensive, and also do not constitute any balancing ingredients, so hence shows the side effects. So we should focus on the plants as medicine to come upon this problem of antimicrobial resistance. Because of these phytochemicals, bioactive compounds, these are known as the secondary metabolites. Because of these presence of these, they are showing various effects on the this field. So that is why we need to focus on this medicinal plants. So this is the short conclusion, that it is a problem that continues the challenge the healthcare sector in the large part of the world, and the emergence and spread of these multi-drug resistant pathogens have threatened the current antibacterial therapy, and this has necessitated the search of few source of antimicrobial resistance, such as plants, as they produce various variety of bioactive compounds known of therapeutic properties. And moreover, the current cost of these drugs is unbearable to the public, especially in developing countries. Therefore, attempts must be directed towards the development of effective natural non-toxic drug for the treatment. Thank you.
Okay, thank you so much, ma'am.
Thank you, ma'am.
Okay, now remaining participants, we will take your presentation around 1 o'clock. Okay, if we will have a time. Okay, so now
I should stop all the presentation and start Das.
yes, sir, yes, sir. Yes, sir. Okay, so now
and tell the presenter that come at 2 o'clock.
Okay, sir. So now, glad welcome. It's a glad welcome we bring to you this morning, filled with the desires, hopes, dreams we all share. So now, the person whom I'm going to invite, he is a former professor, head on renewable energy chairman, professor, department biotechnology. Yes, the person whom I'm talking about is a Professor V. Das. So I request to sir. Am I audible to you, sir?
Yes, you're audible.
Okay.
Can you hear me?
Yes, we can hear you.
अरे भाई इतना लेट क्यों भाई?
I'm so sorry, sir, but there are some emergencies. Sorry.
You are saying it is an international conference and time नहीं maintain करता है तो that the standard goes down, you know.
Okay. I'm so sorry, sir.
No, it doesn't matter, but you know that time matters, you know. Professor Jain know that, you know, that our time matters. Am I right, Professor Jain?
Yes, sir. We're really sorry for that.
No problem. Absolutely fine. So I am glad to see my friend.
Thank you, Professor Das. You are so nice to us. I'm sorry that you have to wait for some time because lot of people were there.
Only I want some kind of information in advance that, you know, it will be delayed for.
Yes.
That's fine actually. Anyhow, it is fine that because Professor Jain is there. I am seeing my friend. I am very happy.
Okay. Go ahead.
Okay. So should I give my presentation now?
Yes.
I can share my slide, no? Is it visible or?
Yes, visible, but it should be in slide mode.
This is okay?
Let us come with the slide mode.
But it is slide mode has come.
Present your full screen.
It's not coming.
It is presentation is there, but slide mode is not there.
I don't know how to do that.
Sir,
Okay,
please,
no problem,
please
no problem.
press
Go ahead.
press F5, sir. Please press F5.
Go ahead. Go ahead.
F5. Okay.
Yeah.
Okay.
No, it's not working.
But I press F5.
No. So just click on slideshow menu, sir. There is a slideshow menu on the at the top. Slideshow. Just click over there.
Just a minute. Just a minute.
Slideshow.
I could not find anything like that.
Slideshow. Just click on slideshow.
On the top.
No, on the top, I could not find like that.
Sir, just give me the remote control. Just give me the remote access, sir. I can do that. I can do that for you. Just give me the remote access. Say yes.
Remote control. Okay, that's fine. So how I can give you?
Sir, just give me the access. I can do that for you. Do yes. Yeah. Slideshow. Resume slideshow. Sir, do one thing. Disable. Stop your sharing, then share again. Then.
Stop my sharing.
Yeah, I'm just stopping your sharing, then share again.
Okay.
Now share again, sir. Share again your PPT. Now press F5, sir.
This is okay or this is not okay?
नहीं हो रहा सर फुल स्क्रीन. चलिए सर आप कंटिन्यू कर लिए, कोई दिक्कत नहीं.
Why it is not coming? Because some problem. Anyhow, it doesn't matter. But you know, my slide are visible, no? Hello.
Yes.
My slide is visible or not?
Yes, visible.
Oh, that is great. You know, that is what exactly I want. Okay, that you know that I am thankful to the organizer to give me an opportunity to share our research experiences on this biohydrogen production process in particular. And but today I am talking. I'm going to give a talk on biohydrogen and which is the fuel for the future. Before I start my presentation, let me share the thought of Albert Einstein. What he says that imagination is more important than knowledge, for knowledge is limited to all we now know and understand, while imagination embraces the entire world and all there ever will be to know and understand. So you know that umbrella will be much bigger as compared to that knowledge. So imagination is very important, and just I want to tell that my website is www.bioh2iitkgp.in. Anybody interested to know our research work, they can visit our site. Okay. So you know that first let me tell you that what is biofuel, because I was observing that yesterday some lectures and other things. So you covered different areas. It's very nice. But what biofuel is, any fuel is produced from organic matter, because most of the organic matter is produced from the living system, because all organic matter produced from the living system. And if anything, any fuel produced from the organic matter, we call it biofuel. And the question comes, why do you need biofuels? The reason is that it is sustainable, because it will be with us for all through our existence. So we can use these as again and again for the generation of the energy. So I have given you some kind of sketch in the right hand side. So if you just look into that, you understand what is the importance of the biofuel. Now, the question comes that what is the renewable energy sources? Renewable energy sources, man, that means that the energy that will be available with us all through our life. That that life. So this has different type of renewable energy sources. We have solar energy, and then wind energy, geothermal energy, hydro energy, tidal energy, nuclear energy, and bioenergy. So I will be concentrating on bioenergy today. And before I go for that, just I want to highlight that what is the importance of this this energy. That solar energy, I can give you the information that that is with us about 23,000 terawatt. That world consumption is about 16 terawatts. That means a tiny fraction of the solar energy, if we can use for our benefit, the whole energy demand can be fulfilled. And if you look at the energy source that we are using nowadays, mostly oil, and then coal, then natural gas, all will be exhausted very soon because all had been that limited resource. So so naturally that that we look for some kind of alternative energy sources, and this gives you some kind of information what is the present status of the different type of energy sources. And mostly you find this fossil fuel we use for to meet our that energy demand, and biofuel that occupy only 10%. But some of the underdeveloping countries, they are using more than 50% this biofuel to meet their energy demand.
So Das, go on changing slide. This first slide now.
First slide.
Yeah, this is first slide. Go to other slide. Only first slide is, you are showing first slide.
Oh, it is not going.
Not going.
Why
first,
it is like this?
Only first slide.
I don't know why.
Sir, you can see your slides or not? You are changing.
I can see.
You can see now. Sir, do one thing. Stop sharing and then start sharing. Then you can see two slides over there. So which is full screen and changed. Please share this slide. Do one, sir. Share. Do share again. In share dialog box, you will see. No, sir. No. This is. You can share your entire computer, sir. Please share screen.
Enter computer. Again, I shall go out. Huh?
No, sir. Do one thing.
Okay, now enter computer and I can see it. Then?
Yeah, you can share screen. Share screen. Now just click on, sir, slideshow button. Slideshow.
Okay.
Yes, this one.
Yeah. Now
yes.
it is fine. Now it is fine,
coming.
sir.
Yes, coming.
Now continue, sir, please.
So should I start from the beginning or from the in between? Okay, because there are a lot of things to tell. So anyhow, that if you look at the worldwide energy demand is like this. The China that since China and India is the mostly vastly populated country, so our energy demand will be more in the years to come. So you will be just this slide. You can find out that by 2035, the energy demand will be keep on rising, much higher than that of India, and other country like other developing Asian country will be comparatively quite less. So that main important thing that we have, that energy source that we will be looking for, that should be renewable, sustainable, and environmental friendly. Now, current scenario is that fossil fuel provides 80% of the world energy supply, as I mentioned before, out of which oil provide 40% of the global energy need, and fuel 90% of the out of this 90% goes to the transportation sector. Now, at the current rate of consumption, we'll running the petroleum within running out of petroleum within 50 years, natural gas 65 years, and coal in about 200 years. So, so renewable energy is very much important. Biofuel. The reason is that it is biodegradable. It is stability is there, environmental acceptability, and then reduced dependence on the petroleum fuel. So this gives a typical that presentation that biofuel, biogas, biotransport, and biosynthesis, how they correlated with each other. So if you look at the biofuel, it can be divided into three different categories. One is gaseous fuel, another is liquid fuel, another is the green fuel. Now, gaseous fuel, we have biohydrogen and biomethane. Liquid fuel, we have biobutanol, biodiesel, and bioethanol. And the green fuel is the microbial fuel cell. And microbial fuel cell is a unique device where the waste material is directly converted into electricity. So we consider this as a green fuel. Now, our question comes, why we are looking for hydrogen? The reason is that if you see the our civilization, that generation of the human civilization, we start with wood as a source of energy source, then animal fat, then coal, then petroleum, then propane, then natural gas, hydrogen, and fuel. Now, why I am showing this slide, the reason is that as we go ahead, then we slowly we slowly march to hydrogen and fuel cell. The reason is that this is 100% environmental friendly, because hydrogen, when it burns, it produces only water. Now, what are the question comes, what is the organic waste that is available in India? So whatever organic waste we have in India, that can be classified into two different types. One is called solid waste and another is liquid waste. Now, solid waste, we have municipal waste, we have agricultural waste, we have industrial solid waste. The municipal solid waste, we have organic litters, household waste, and the waste. And the agricultural waste, we have algal biomass, energy crops, food crops, and cellulosic biomass. Industrial solid waste, we have food processing, industrial waste, dairy, industrial waste, and agro-industrial waste. The liquid waste, we have industrial wastewater and domestic wastewater. There are several industrial wastewater we have distillery effluent, paper mill effluent, starchy wastewater, pharmaceutical wastewater. Domestic wastewater, we have canteen waste, we have household waste water, and the starchy wastewater. Now waste to energy, the technology apprehended, that technology available in three different types. One is biofuel production, as I mentioned before. Biofuel can be biohydrogen, biohydrogen, bioethanol, biobutanol, biodiesel, bio-oil by pyrolysis. Lot of researchers doing research work on that, and liquid fuel from hydrothermal liquefaction, that also a lot of research work is doing. Then we have gasification technology that can be done from this organic waste, hydrothermal gasification, syngas from plasma pyrolysis, syngas from production pyrolysis. Incineration technology, augmentation with thermal power station, heat generation for household users. Now, hydrogen economy is that we have a lot of pollution. You can see we have air pollution, we have global warming, we have environmental destruction, and economic dependence. All this is the fossil fuel economic. That solution comes only. This is the hydrogen economy, because hydrogen, you can see that in the fuel cell, we can through the electrolysis process, we can photoelectrolysis process, we can convert into the hydrogen and oxygen, and this hydrogen can be used in the transportation sector. Then again, combustion, this energy used for several purposes, and we have water, and water again pass through the electrolysis process that can be reused. Now, why hydrogen? The reason is that it has the highest calorific value as with zero pollution and potential production from variety of renewable sources. Now, hydrogen can be produced in two types of processes. One is non-biological and another is biological. Now, this non-biological process, we have several. We have thermal and thermochemical methods. We have photolysis and photochemical methods. We have electrolysis. We have steam reforming and partial oxidation and photoelectric chemical system. Now, biohydrogen, the biohydrogen is defined as the hydrogen produced biological, mostly commonly by bacteria, algae, and the archaea. Now, this is the processes that we have, and broadly this can be classified into two different types. One is called photofermentation process, and there is the dark fermentation process. Another, we have what we call microbial electrolysis process, what I mentioned at the beginning. Now here I want to point out that that we have been doing this research work for last more than 20 years, and we have a project with Oslo University and Uppsala University, Oslo University Norway and Uppsala University Sweden, just to find out. This is under the Norwegian Foreign Ministry. Then this project we try to establish how algae is suitable for the hydrogen production, because if you look at the history behind the biohydrogen production process, because scientists just thought that algae has the capability to hydrolyze the water and produce hydrogen, but as soon as they started hydrolyzing water, it produces molecular oxygen, and that molecular oxygen gives the inhibition effect to the enzyme which is responsible for the hydrogen production. So whole research work that diverted that how we can develop the oxygen tolerant mutant. So this research still going on. Another process we have photofermentation process. Here this process that the unique feature, the reason is that different organic material can be converted into hydrogen. But problem is that you can see at the bottom the red pigmentation that takes place during the growth of the photofermentative bacteria, and that causes the reduction of the light penetration problem. And since the light penetration problem is reduced, we find the drastic reduction of that hydrogen production. So we established that that I had a long discussion with Jun Mike, and who is the pioneer of the photofermentation process. And we came to the conclusion that photofermentation process is no good for hydrogen production. The process that left with us is the dark fermentation and the microbial electrolysis cell. Now, microbial electrolysis cell, I told you, this has the unique feature. The reason is that the wastewater is directly converted to the electricity. So this is considered as the green fuel. But the problem is that the scaling up problem, because small scale operation, we don't have any problem. But in a bigger scale operation, Bruce Lignin, that he has been doing some work, but he facing also a lot of problem with the scale up operation. So up to pilot scale level, it is okay, but in the commercial level, it is very difficult. The process that remains with us is the dark fermentation process, which is very easy to operate. And this process we have, as I discussed in details for your kind information. The advantage of this dark fermentation process is that it operates at ambient temperature and atmospheric pressure, and thus less energy intensive environmentally can utilize the renewable energy source which are inexhaustible. And if you look at the stoichiometry of the process is very simple, that in a light dependence process, we have biophotolysis, which is taking place in presence of the algae, microalgae, and the stoichiometry is very good. The problem is that this molecular oxygen that gives the inhibition effect on the enzymes, which is responsible for the production of hydrogen. So whole research work has under stagnation, that how to recover this problem. This research was still going on. And photofermentation process also stoichiometry is quite attractive, because 1 mole of glucose can produce 12 mole of hydrogen. But problem is that at the beginning we will get good hydrogen production. As the time proceeds, there will be some kind of setting effect, and due to setting effect, that hydrogen production reduced drastically. But dark fermentation, we don't have any problem. The problem is that it has it produces mixed volatile fatty acid fermentation process, and if it follows the acetic acid pathway, it produces 4 moles of hydrogen from 1 mole of glucose. And microbial electrolysis cells also quite attractive. 1 mole of glucose can produce 4 mole of hydrogen, but problem is the scaling up. But we don't have any problem on scaling up of the dark fermentation process. The dark fermentation process is basically the fermentation which is carried out in the absence of light. And this is the stoichiometry I have already discussed. This is the metabolic pathways, how the hydrogen takes place. Now, if you look at the glucose is converted to different metabolites. We have lactate, we have acetic acid, butyrate, ethanol. Now, I want to mention that if it produces the lactic acid and ethanol, it doesn't produce any kind of hydrogen. But it consumes a lot of NADH. You can see this the NADH consumption is there, and the NADH is a good currency for the hydrogen production. I have shown you this in presence of the pyridoxine, reduced pyridoxine, it can be produce this produce hydrogen. So what we have done, we have just we developed the mutant, and through this mutation process we stop the formation of acetic acid and ethanol, so that the NADH which we save and that we can redirect for the hydrogen production. So our hydrogen production increases. But when it produces acetic acid, we get 4 moles of hydrogen, and when we produce butyric acid, it produces 2 moles of hydrogen. Now, two type of microorganisms they involved in this biohydrogen production process. One is called mesophilic dark fermentation process and thermophilic dark fermentation process. Mesophilic dark fermentation process is very much important. The reason is that because since we are living in a tropical country, our temperature is close to 30-35 degrees centigrade. So this you can easily grow this organism like Clostridium, Butyrium, Escherichia coli, Enterobacter species, Klebsiella, and Citobacter. These are the potential bacterial species which are responsible for the hydrogen production. But here I want to point out that anaerobic digestion process is largely used for the methane generation, and during the anaerobic digestion process, two group of microflora that is used for this process. One is called acidogens and another is methanogens. Little emphasis has been given on the acidogenic organism. Since we develop our expertise on the high biohydrogen production process, we try to explore the acidogenic organism present in the anaerobic digester, how it can nurture for the production of hydrogen. We find it is very, very promising as compared to this pure organism. And since this is the mixed microbial flora that can be easily used for the hydrogen generation. The thermophilic organism plays very important role. The reason is that it works at very high temperature, more than 60 degrees centigrade. We know at 60 degrees centigrade, most of the pathogens they kill. So there is a less possibility of contamination, and this contamination may be there prevalent in case of mesophilic fermentation process or thermophilic fermentation process. We don't have any contamination problems. So your hydrogen production kinetics is much better as compared to mesophilic fermentation process. So these organisms are thermoanodobacterium species, the Clostridium species, and all these organisms can be easily used for the production of hydrogen. Now, mesophile is also classified into two types. One is called obligate and the facultative. Facultative organisms, they are very easy to use because it can tolerate little oxygen concentration in the fermentation broth. But obligate anaerobe, they cannot tolerate the oxygen concentration in the fermentation broth. So that is the major limitations we have. So we in our lab we develop a organism what we call acidobacter, that Acinetobacter aerogenes, and this organism has the capability to produce hydrogen at the ambient temperature. Now this is the Enterobacter clocky that you can see. This particular organism IITBT08 we isolated from the leaf of a particular flower plant, and we find it has very good potentiality for the hydrogen production. So, and then we also isolated the Citobacter friendly IITBTL 135. This we isolated from the high oil containing soil, the high fat containing soil. We collected from this Holdia refinery where we have high oil containing soil. And this also has the capability to produce a good amount of hydrogen. Bacillus coagulant IITBT S1, this was isolated from the Swiss sludge that also can produce hydrogen. So different type of organism can be used for the hydrogen generation process. Now, what is the advantage and limitations of this dark fermentation process? As I mentioned, it occurs at the ambient temperature and atmospheric pressure. A varieties of substrate can be used for hydrogen production, and no requirement of the light energy. Rate of hydrogen production is high. Limitation is the less gaseous energy recovery. I shall discuss in details later on. and theoretical only 33% of the substrate energy recovered can be obtained through the dark permutation and less economically feasible. So need of integration of dark permutation with the biomethanation process. The reason is that after the hydrogen production, the metabolites that remain in the fermentation broth, this is mostly the volatile fatty acid, and this volatile fatty acid can be easily converted to methane and carbon dioxide by the methanogens. So that our suggestion is that wastewater, if we pass the dark permutation process, which can produce hydrogen and carbon dioxide, and volatile fatty acid, what we get after this hydrogen production, this we pass through the methanation process that can produce methane and carbon dioxide. So this is called biohydrogen. The reason is that high come from the hydrogen and than comes from methane. Now, why hydrogen plays important role? The reason is that we know the CNG, that is the compressed natural gas, which comprises of methane, and the fuel characteristics of the methane is improved if 7% hydrogen is mixed with 7% hydrogen mixed with the methane. The fuel characteristic increases to a great extent. So hydrogen is recommended for using fuel for different purposes. So this is the biohazard concept that we have developed, and this is how it can be produced. That you can see that complex polymer, it can be degraded to monomer and oligomer, the sugar, that amino acid and long chain fatty acid, and this ultimately produces the volatile fatty acid and ethanol by the atogenic bacteria. And second stage, this is converted to methane and carbon dioxide by methanogenic bacteria. Now, if you look at the energy recovery is very interesting. If you go for the biomethanation process, energy recovery is 85%. And if you go for the biohydrogen production process, it is 34.2%. And if you combine this biohydrogen, it is 91%. So we recommend strongly that we should go for biohydrogen process there in the years to come. And I think most of the scientists agree with me, because I presented this concept throughout the world, and I am glad to report to you that I wrote a book on this biohydrogen process, and this is the first book that has been published in the world. And if you go through that, and I'm glad to report to you that one industry, Dhampur Sugar Mills, they came forward and they have taken our technology for the commercialization. And this is the hydrogen fuel cell bus. Tata, the last year they produced it, and they have already several buses they are marketed. But here they mostly use the hydrogen fuel cell for the operation of this buses. So this hydrogen, and not only that, hydrogen can be used. Now it is Mahindra and Mahindra, they have used two-wheeler, three-wheeler, and four-wheeler. That technology is different. They are directly use hydrogen for the operation of this vehicle. But there is two type of things that we have. And this is the advantage of using the dark permutation process. The reason is that different waste material which causes the environmental nuisance that contains the high COD and BOD value, low dissolved oxygen of the stream, and affect the aquatic life. This can be, if we pass through the biohydrogen process, we can drastically reduce BOD and COD, facilitate the safe disposal of wastewater, and reduce the risk of eutrophication. This is the roadmap for our hydrogen research, biohydrogen research that we've been carried out in IIT Kharagpur. And I'm glad to report you that we started this research work in the year 1999. First paper we published in 2000. This published in the process biochemistry, and this interbacterial clocky IIT 08 that we find it has great potentiality for the hydrogen production. We published this review paper on this biohydrogen production by biological processes, survey of literature. The citation number is about 2,442. That is this is the highest citation that we have on the biohydrogen production process so far. And later on, we develop the process in different papers has been published. So that ultimate goal is to go. Recently, we published this paper that biological hydrogen production via dark fermentation, a holistic approach from the lab scale to pilot scale, because we operated 10,000 liter reactor, and we find at the bottom in the left hand side you find 10,000 liter reactor. This we established at IIT Kharagpur, and we successfully operated, and this technology has been transferred to the Dhampur sugar mills.
So that's 5 minutes.
Okay, and this is the biohydrogen process that I told you. We published the book on biohydrogen, that will for the future, published by Pan Stanford Publishing Company, that is Singapore, and we published several papers on the biohydrogen process. And this is the lab scale to pilot scale operation. You can see how small bottle we have we use for the hydrogen generation, then column, then control fermenter, then we use this custom made reactor, and finally we switch over to the 10,000 liter reactor, and this is our pilot plant at IIT Kharagpur. And this is the detailed analysis that we have. Total heating value of the fermentation media is this, and we find that energy recovery by substrate removal is 37.9%. So what we have concluded that that if we scale it up from 0.5 liters, 2 liters, 50 liters, and 10,000 liters, our cumulative hydrogen production, you see, drastically increases. I'm glad to report you that 10 cubic meter reactor will produce about 76 liter or 76,000 liter, that is 76 cubic meter of hydrogen, and which we pass, and this gas doesn't contain any kind of oxygen or sulfur dioxide or H2S, so carbon dioxide, so it can be directly used in the fuel cell for the generation of electricity. This is the transfer of the technology that has been done with the Dhampur sugar mills, and this is the some of the research work that we conducted, how this spent was that we get from the dark fermentation process, how it best it can be utilized in the methanation process. You see that gaseous energy recovery is increases, and this is the distillery effluent. We produce the distillery dry again solid and tryptone as a nutrient supplement, and we find that when you combine with hydrogen and methane, then our total energy recovery increases. So this is the overall process that we have. That hydrogen stage, we have 2.2 megajoules per kg of COD that we remove, produce, then 10.7 megajoule per kg of kg of BOD we remove, and total to sum, we add these two figures, and we get 12.7 megajoules per kg of CO2 removed. So in conclusion, I must say that pilot plant demonstration shows the significant enhancement of biohydrogen production. DOIL cake that I have not shown you is very promising, because which is a byproduct of the agriculture industry as the nutrient supplements, because we know when we utilize any kind of waste material, it has lack of nutritional property. So you have to add some kind of nutrient just to so that your bacteria can grow properly. To just continuous the biohydrogen production process significantly improve the gaseous as compared to dark fermentation. I'm glad to report you that Dhampur sugar mills now they are using 7 cubic meter reactor for the methane generation and 1 cubic meter reactor for hydrogen generation, and it has been successful. And now we are thinking for commercialization. I am thankful to my that sponsor, Department of Biotechnology, MNRE, then DRDO, then DST, National Science Foundation. I have a project, and we have that, we have project. I have the collaboration of the different in the foreign university as well as the Indian Institute. And this is my group. We can see that girls, that population is very higher than as compared to boys, because both boys and girls, they work together to make our process successful. So this is the book that we published in the year 2014, published by CRC Press. This is the Biohydrogen Production Fundamentals and Technology Advances. Then I told you that we published the first book in the world, that is Biohydrogen, the fuel for the future. And recently we published in 2019 the fundamentals of biofuel production processes, that published by CRC. Thank you very much.
Thank you, Professor Das, for your very good lecture. And I want to tell the young people that you are listening to the world's best scientist in the biohydrogen production. And he has a vast experience, and I congratulate him for his citation 2442, which is unique in the world. And I think he has introduced the high-chain is his mind. So anybody who wants to ask questions, please go ahead and ask. He's a very brilliant scientist. Go ahead. Young people, anything you want, even if you think it is not good to ask that thing.
It doesn't matter. If you have a police question, that also I can ask. Because my professor always says that, you should have the habit of asking questions. It doesn't matter whether it is good or bad, but you should have the habit of asking questions.
Yes.
Okay, so thank you so much, sir. I really appreciate the details you shared with us, and I thank you from the bottom of my heart for taking time from your busy schedule to be present here. Once again, thank you so much, sir.
Thank you. Anybody have any question, they can contact with me in the mail. It doesn't matter, because I will be very happy to answer. Okay.
Thank you.
I am very happy to see my friend. Again,
I'm very happy.
So, namaste ji. Namaste.
Thank you.
Okay, bye.
Bye.
Next, proceed ahead and.
Ayushi, listen to me.
Yes,
if
sir.
Possible, ask Ravindra Jangir 20 minutes. Give 20 minutes to Ravindra Jangir.
Okay, sir.
RRCat Indore.
Okay.
Ask him he's there. Ask him if he's there.
I am here. Okay.
Thank you.
Yeah. Never change your originality for the sake of others, because no one can play your ride better than you. So be yourself, you are the best. And we feel honorable and privileged to have with us today in this function a person who is from Raja Raman Center for Advanced Technology Indore. Yes, I'm talking about Dr. Ravindra Jangir, and I would like to call him as invited talk. Please give big hands to Ravindra sir.
And I tell you, young people, that is one of the best lab in the world, which he is the working guy.
Yes, sir.
Yes, sir.
Sir, I am also old student of Rajasthan University. Maybe you may not know.
No, I know. Yes.
That's great, sir.
I know RRK right from the beginning. But we have only 20 minutes.
Okay, sir. I will try to finish. Can the slides are visible too?
Yes.
Okay. My name is Ravindra Jangir. I am from RRCat Indore, and today topic of today's talk of my talk is E-type transparent conducting oxide. Mainly, I am working on alpha gallium chromium oxide, nickel doped, and which is a P-type wide band gap semiconductor oxide. And in this type, I will cover 4 points. Introduction. In this part, I will discuss about some basic about the transparent conducting oxides. And in second topic, I will discuss the property of alpha gallium chromium oxide material. And in the third part, I will discuss doping of nickel in alpha gallium chromium oxide. And in fourth part, I summarize my work. What are transparent conducting oxide materials? These materials have a very fascinating property. They have optical transparency in visible region. They are transparent, and they have also high electrical conductivity, and they are have good thermal chemical stability and high temperature operation. Because of that property, they have various application in different fields, like low emissive windows, security circuits, transparent top electrodes in solar cell, flat panel display, and many other area like water splitting, and work as a whole transport or electrode transport layer in perovskite or organic solar cells. But in general, both the property, optical transparency and high electrical conductivity, are mutually exclusive in a single material. Then how this both the property is possible in transparent conducting oxide? We will discuss in brief. So generally, visible region is falls between 400 nanometer to 700 nanometer. In the energy terms, it is 1.77 eV to 3.1 eV. If we want a material to be transparent in visible spectrum, so its band gap should be larger than 3.1 eV. But if we take the large band gap material, this is a conduction band and this is a valence band, then because of large band gap, it is very hard to excite thermally the electron from valence band to conduction band. So these large band gap materials are generally insulators. So how can we can make them conducting? So we generally dope these material with donor and acceptor materials. And the electrical conductivity of these material generally represented by Ne mu. N is a carrier concentration of that electrons or charge carriers, and mu is mobility. And mobility depend on the effective mass of the charge carriers. These two quantity, carrier concentration and effective mass, are important in these materials. So generally, for the high carrier mobility, we take highly dispersive bands. So generally S or P orbital are very dispersive. So in the oxide material, we choose such type of material which have highly dispersive bands. And second one is the doping. So it is dopability should be very high in these materials. So these are the two conditions we choose for transparent conducting materials. So if we increase the N, so conductivity will increases, but there is a limit. Up to that, after that, we cannot conductivity. After that, the usability, the transparency of this conductors reduces, because there is a one phenomena happens when a charge carrier's density increases, which is a plasma frequency. Because of a free charge carriers in the bands, and in this case the conduction band, there is a plasma frequency which reflect that the material which has a particular plasma frequency, the light incident on this material which have lower energy than omega h omega p, this energy, plasma frequency energy, so it will totally reflect that light. So the material is opaque for up to h omega p energy, this plasma frequency energy. So generally in metals, if we see the metals, the M star for metal is very less, and so this is very less, and the carrier concentration is around 10 to the power 22 to 10 to the power 23. So if we put all these value and we calculate, then this energy falls in the ultraviolet region. So because of this plasma frequency, all the metals present on the earth are generally opaque in the visible region. They reflect all the visible light energies. So they are generally opaque. So that's why in the ITO films, we can dope up to 10 to the power 21, because for this concentration, the energy for plasma frequency falls in 1.61 eV. So it is nearly in the infrared spectral region, which ensure the high optical transparency in the visible region. So if we take a, suppose we take indium ITO, and it has a band gap of 3.1 eV, and we can dope up to 10 to the power 21. So the carrier concentration and the optical transparency are there is a trade-off between these properties. So we cannot dope in infinitely these oxide materials. So there is a limit because of plasma frequency. So so if we talk about N-type materials, in the N-type transparent TCOs, we generally take indium oxide, zinc oxide, tin oxide, and barium stenate. In these materials, the conduction band mainly form from the S band or P bands. So S and P band are very these are very dispersive in nature, and their special spread is very large. So the carriers can easily move throughout the crystal. So they are beneficial in this term. So the effective mass is very less in these materials, and because of their special distribution, the conductivity is also resistance is also very less. So when we take these these are taking as a host material. When we dope these material with a suitable dopant, dopant. So because of the S and P band, the energy levels, acceptor energy levels falls near to the particular band. So they are easily excited to the conduction band at the room temperature. So they act as a free carriers. So the conductivity of these N-type materials are very high. And by this route, people have developed a series of high performance N-type TCOs, such as ITO, tin doped indium oxide, aluminium doped zinc oxide, and FTO, fluorine doped tin oxide, lanthanum doped Gbsa. If we talk about P-type material, so it is because in the oxide material, conduction band is formed by s orbitals or p orbitals, but the valence band is formed by two orbitals, which are very less dispersive. So that the effective mass of the charge carriers in the whole are very large. So it is impossible to make a p-type TCO because of oxygen 2 orbitals. So people are searching that how can we make a good p-type materials similar to n-type materials. So one possibility is that we can engineer the valence band. We change the dispersive nature of oxygen 2 orbitals by interacting it with other materials or other bands. So in 1997, where one lab has proposed that concept of chemical modulation of valence band, CMVB. It suggests that if we modify the valence band through the hybridization of oxygen 2 orbitals by another metals, D and S orbital of other metals, then we can increase the dispersion of valence band. So the conductivity and property of p-type materials. So in this case, they use D10 and D10 filled transition metals and this D10S2 type materials. So under these conditions, the metal D and S states hybridize with the oxygen 2 orbitals and make them a valence band hybrid which have both the oxygen 2p nature and 3d nature. So the property of valence band changes. And in another case, if we take tin or these in the tin bismuth or antimony, then the s orbital hybridize with oxygen 2 orbital and make the valence band more dispersive. So following this CMBB strategy, various type of p-type oxide, mainly copper or silver based delphosides are reported, and some chalconides and tin oxide materials have been developed. There is people have reported another formalism for the change in the property of valence band by hybridizing it with d orbitals. In the many transition metal oxide which are partially filled with d electrons. So by the band theory, it was proposed that they are in metallic nature, but in the experimental, the people have found that they are not metal. They are generally insulators. And after some research, they have found that there is a Coulomb interaction between the electrons, which separate the d orbitals by energy u. This is Coulomb interaction energy, and the into two bands, lower Hubbard band and upper Hubbard, and the difference between these two bands are u. This is equal to band gap of these in these materials. So by changing or by modifying the u, we can hybridize d orbital by these oxygen 2 orbitals. So various type of materials have been developed by using this formalism. Similarly, nickel oxide. Nickel oxide is a very important material, and it is generally used in solar cells, p-type material as in solar cells and various other transparent electronics devices. And chromium oxide, lanthanum chromium oxide, vanadium, lanthanum vanadium oxide. Various materials have been proposed. We take one example, lanthanum chromium oxide. In the lanthanum chromium oxide, d orbital are separated by u, and this is the band gap, and it hybridizes with oxygen 2p. When we dope it with strontium, it creates a hole near to the valence band. So this acts as a p-type dopant, and this is this material has a very good p-type property, and it has reported various papers have been reported on this material system. And this is for nickel oxide. This is a nickel lower Hubbard and upper Hubbard. Now, our interest in my interest is mainly on chromium oxide based materials, and chromium oxide has a band gap of 3.4 eV, and their conduction band and valence band, they are mainly formed by chromium d levels. This is upper Hubbard and this is a lower Hubbard band. Both are in d type d level, formed by d levels. So, and its band gap is 3.4 eV. So we can use at a host matrix for p-type tissues. And people have reported p-type conductivity in this material by doping of Mg and nickel. And they have also found that nickel levels falls in the valence band, due to which it also contribute in the lowering the effective mass of these holes. People have also suggested that if we dope with sulfur in place of oxygen, then the property of this valence band can be changed, or the effective mass of holes can be changed. So various formalism have been applied for this chromium to increase the conductivity in chromium oxide-based p-type materials. The performance of a TCO can be increased by widening of band gap, doping with suitable p-type dopant, and enhancement of p demixing. Because the FOM figure of merit of the transparent calcium oxide depend mainly on its transmittance and sheet resistance. it is proportional to the transmittance and inversely proportional to RS. If we decrease the series resistance, this figure of merit increases. This RS can be decreased by p-type dopant, suitable p-type dopant, and either we enhance the PD mixing. By increasing the PD mixing, the dispersive nature increases because of this PD mixing. And transmittance, to increase the transmittance, we can enhance the band gap of this material. So people have studied in this direction also. They have doped gallium in place of chromium in copper gallium chromium oxide, and they tune the band gap from 3.9 to 3.56 eV. And it has been shown that the transparency in the visible region increases up to 80% with the increased band gap. And similarly, in silver-based delphosides, they increase energy from 3.4 to 3.6 eV. And by nickel doping, band gap of chromium increased from 3.4 to 3.6 eV. We note that gallium oxide is a wide band gap material which have a band gap of 5 eV. To given importance this material system, we have studied in detail this material system, gallium chromium oxide. And we will discuss the structural and optical property of this material system. This material is synthesized by solid state reaction method, and these materials are calcined at 450 degrees centigrade and sintered at 600 degrees centigrade. These are the XRD measurements taken on this material system. The measurements are done on X-ray diffraction beamline installed at Indus 2 at a wavelength of 0.6318 Armstrong, which is equal to around 20 keV. And we can see from this graph that material is single phase up to 45% of gallium substitution, and after that we can see small peaks in the spectrum, which are mainly due to gallium oxide, which is out diffused from the chromium oxide matrix. So this is the peaks, 006 peak and 300 peaks. From that we can directly see the variation of A and C. C is decreases and A is increases from these formulas. And we fit the spectrum, these XRD spectrum by Rietveld method using foolproof software to calculate the precise lattice parameters. The parameters are plotted as a gallium composition, and we found that there is a bowing in the lattice parameter. Lattice parameter does not vary linearly, so there is a bowing, and this bowing is mainly related to the local structure variation in the material. And the local structure of a particular material can be proved by exhaust measurements, which can be done in the synchrotron beamlines, exhaust beamlines. So we have carried out exhaust measurements on chromium edge and gallium. And this is the structure of gallium chromium oxide. These are two types of bonds, oxygen 1 and oxygen 2. They have different bond lengths. It is a so in the first peak, we fit both the cells for oxygen 1 and oxygen 2, and we get the bond length for chromium gallium oxygen 1 and gallium chromium oxygen 2. From the bond length, we see that the bond length of gallium oxygen are larger with respect to their parent material. So, and the thermal parameter also increases with the gallium substitution. So because of both these parameters, disorder increases, and the bond length also increases with the gallium substitution. So both these parameters are responsible for the bowing and the immiscibility of gallium in the chromium lattice, which is mainly up to 45%. So mainly the local variation in the local level in the structure are mainly responsible for bowing and the immiscibility in a particular material. The optical property of these material are characterized by diffuse reflectance spectroscopy. And from the diffuse reflectance spectroscopy, we get the absorption spectrum. In absorption spectrum, we get several peaks. These are the correspond to many transition. Our interest is mainly in these two peaks. This is chromium T2 to Eg transition, which is a band gap of chromium oxide, and this is a oxygen 2p to chromium 3d transition. And if we compare the material with 5% and 45% gallium substitution, we can see that the band gap of this material increases around 0.5 eV. But this
जागीर 5 मिनट है
yes. अच्छा 5 मिनट है okay sir, I will summarize. So that we can, from the optical measurement, we see that the chromium levels with the gallium substitution shifted towards the oxygen orbital. So this is this so that there is a increase in the hybridization because of gallium substitution. So, and this can be also proved by pH measurements. In the pH measurement, we can see that this is a B is because of oxygen 2p states, and this is a chromium states. So that both the levels comes closer, so which we observe in optical measurement. So by gallium substitution, we not only increase the band gap, but we also increase the hybridization of chromium 3d and oxygen 2p levels, so which will be helpful to increase in the conductivity of this chromium oxide material. And after that, we dope with nickel p-type materials, and we found that we can dope up to 0.1, x is equal to 0.1, and 1% up to 1%. And the electrical characterization was done by complex impedance spectroscopy. And in the complex spectroscopy, we find that the resistance of the material reduces around 10 to the power 4 times by nickel doping. So the nickel doping reduce the resistance or increase the conductivity of material by 10 to the power 4 times in the gallium chromium oxide. And we compare the result with the chromium oxide. And this is the comparison of resistance in the temperature range of 300 to 400 Kelvin. In the gallium chromium oxide, because with the nickel doping, the resistance is one order smaller than chromium oxide, which is again approve our previous result that chromium 3d and oxygen 2p levels hybridize more in gallium chromium oxide. And we have done this Seebeck measurements. In the Seebeck measurements, we find that the Seebeck coefficient is positive in both cases, which can prove that the charge carriers in our material are p-type. So these are holes in the valence band which are responsible for this conductivity. And the variation of resistance follow the negative temperature coefficient. So it is a semiconducting material. And this is the summary. We have synthesized alpha gallium chromium oxide. Optical absorption and pH measurements confirm the blue shift of band gap around 0.5 eV as compared to chromium oxide, and there is also improvement in D and oxygen 2p levels. And we have also studied the doping of nickel in both chromium oxide and gallium chromium oxide, and sample correspond to 1%, so that 10 to the power 4 times reduction in the resistance. We suggest that a further increase of delocalization because of nickel doping. And negative temperature coefficient of resistance behavior confirm it as a semiconducting material. And Seebeck measurement, by Seebeck measurement, we confirm that the charge carriers are mainly a p-type in p-type nature. So by alloying with gallium chromium oxide, we can enhance both the transmittance and the conductivity of the material. So we can increase the figure of merit by gallium substitution in chromium oxide. This is work, and we are further study further improving this property of this material system. This is the reference. Thank you, sir.
Thank you. So you have done a lot of work on this, and interesting to see that lot of band gap difference from some level to another level. And here, photoelectron spectroscopy is also interesting. What is the resolution of photoelectron spectroscopy?
Sir, it is in. You can see, sir, some MeV resolution in sir, 1 to 2 electron volt, I think.
Okay.
Less than.
Okay.
And we have also developed one ARPS beamline in Indus 2, which go up to some milli electron volt resolution.
Are you collaborating with synchrotron Trieste also?
Synchrotron?
Trieste.
Okay. Italy, no, sir, I am not collaborating because we already have one synchrotron machine in our center.
Lot of work similar to synchrotron Trieste. I was seeing this your work because I work there also, and I work with Chi Sigma also. So,
okay, it is nice. If you introduce me to that people, then it will be very helpful for me.
It's a good work going on. Congratulations, good work. Okay.
Thank you, sir.
Thank you. We could not give you more time.
Okay, no problem, sir.
Okay, thank you. If anybody wants to ask any question, then Ayushi?
Yes, sir.
Just take over and say something.
Yes. Okay. Thank you so much, sir, to be with us. Your presentation were really informative and indeed motivative. I feel that the information which you share with us will be beneficial for the audience as well as for students of science. Thank you very much again.
Thank you.
So okay. I don't regret the things
now,
I did.
Ayushi, now you can call Dr. Yogendra Kumar.
Yes, sir. So I don't regret the things I have done. I regret the things I did not do when I had the chance to do. But indeed, never fear to start again, because this time you're not starting from the scratch, right? But from the experience. So now I am profusely elated to take an opportunity to introduce our today's invitee, Professor Yogendra Kumar Mishra, who is a Professor WSR, the Max Clausen Institute Professor WSR, SDU Nano SYD University of Southern Denmark. So now I would like to call Sir to give their words to our lovely audience.
Hello, Yogendra Kumar.
Very good morning from Denmark.
Good morning.
Am I audible?
Nice to see you again. And I'm
same here. I'm very happy to see you.
I'm telling you, the young participants, if you want to see how a world-class scientist looks like, just see Professor Yogendra Kumar.
Well, so shall I start my talk?
Yes.
Yeah, good morning, colleagues. Very good morning from Denmark, and I'm going to give you a little bit different flavor in the material science, how to start from the scratch and how to go ahead. And the title of the talk today is about tetrapode-based smart materials for advanced technologies. If you want, you can interrupt me in between. If you want, you can ask the questions afterwards. I'm very flexible. And I'm working as Professor MSO. WSR means with the special responsibilities in nanomaterials at University of Southern Denmark here. And the image at the bottom you see is our beautiful Sønderborg campus. It's the city which is divided by the sea, more or less in the summertime. I can see now the water from my window, and basically in the summertime, there are a lot of activities going on related to the water. So you are more than welcome to come over here, but let me tell you where you are exactly and who we are. University of Southern Denmark is not very old, it's a fairly very young university, just crossed the teenage recently, few years back, but it has grown up. It was constructed by merging different engineering colleges in entire Southern Denmark. I don't know if you have seen the map, Google map, the geography of Denmark. This side is Sweden and this side here is Germany, and these are more or less the cities where we are having our campus, and we are even having more campuses. Denmark has recently introduced a policy to kind of move students away from the big cities to smaller cities, and that is really working very, very well. We are located here at the border called Sonderborg city, so where we would really happy to see you after the corona time. Whenever there is a chance, you are cordially invited, most welcome. Well, at Metz Claus Institute, we are mainly focusing the cutting state of art research in the material science. We have a lot of companies around. Few are even world renowned, like Danfoss and other. They are really contributing to the science and technology and real developments a lot. We have a large Indian community here also and around. At Danfoss at our university, we are representing more than 90 nationalities. And we have here the clean room, is an state of art advanced clean room with advanced facilities like electron microscope, helium ion microscopes, and standard facilities, X-ray topography. So if you are looking for a collaboration and other activities, MOUs, we will be happy to talk about. Also, we have a lot of exchange programs, more or less. So that was a little bit overview of the.
What is particular about helium ion microscope? What is particular about?
Yes, you can even put a cell or a bacteria or a virus, even the biological object, and you can image it directly without depositing any metal on the top of it. So biological objects can be nicely imaged. Imagine you get a SEM image directly from a bacteria. Often what you do, you deposit a metal on the top to reduce the charging effect. Here we don't need to care about, we have another beam which can suppress the charging effects, more or less. So this
what is the role of helium here? What is the role of helium here?
Yeah, I mean, this is just the name. Basically, we are using helium ions rather than normal electron beam, more or less, in this. And we can also use other ions simply to neutralize the charging effect. So this is a very good world-class facility we have here, more or less. And if you are thinking to measure something, polymers, even insulators, we can measure very nicely, and we can see the surface, and we can go down even up to say 3 to 4 nanometer scale. So this is somehow in between the kind of TEM and SEM, advanced SEM. So that's what we are happy about that. Yeah, well, so but anyway, that was a little advertisement to our university, who we are. But I would like to jump to the topic where what are we working on, especially in our group at Smart Materials. Yeah, you have been hearing since last 30-40 years about nanotechnology in a quite a detailed way, and we are at the stage now where we are able to grow different nanostructures, spherical nanowires, nanotubes. So we are able to change their size by different methods. So we have learned quite a lot, and also we have understood their detailed properties, size dependent properties, nice properties by advanced techniques, microscopy, structure, surface, and fundamental properties. And we are in a stage that stage to conclude that yes, we do understand more or less kind of things about nanomaterials in a very good way. Even we are nowadays we have the possibility to see atom by atom into the advanced electron microscope. So we have really developed ourselves in terms of detailed structural characterizations of nanomaterials, developing characterizations and understanding the properties. But the question is, can we go to the market and buy a product which is built out of the nanoscale materials? For example, if you are going to the market and buy a CO2 sensor, normal, still there is a no straightforward answer. And the reason is that these small sizes which are introducing nice properties into the nanomaterial, they are at the same time limitation, because in order to use them, we need nanoscale contacts more or less. And that's why often when we want to make a device, we go to the clean room and we do integration aspects, and we try there. We have a lot of complicated stuffs, and we got a challenge there in a way that how to bridge those nanoscale nice properties in a way, in a material form which is offering us a very simple and easy utilization into the real world. And that's how we came up with the idea directly from our kitchen, from the sponge in our kitchen, that if we could arrange basically the nanoscale material in such a way like a sponge in our kitchen, then we could really harvest the nanoscale properties on the large scale without going into the clean room. We can make a device, we can make the composite materials in a very good way. And on the top of that, you see the advantage that sponges, such a polymer sponge is probably 1/100th of the material, but it is made out of one-dimensional interconnects, the porous architecture. And here you see that the architecture is also able to introduce nice properties into the material system. And you can squeeze it, you can stretch it, you can bend it, you can hold the water, you can change its properties, and still you have access to the surface. They are the good example how you kind of tune the scattering mean for free path length in a real time, just by applying the pressure into these material, which could be good a kind of approach in advanced quantum mechanics or advanced lightning systems, advanced scattering systems. So this gave us a motivation how to design these sponge-like materials. For example, it is very easy to make out of the polymer, but how to make out of ceramics or other materials is not very easy. And that gave us motivation to go in this direction, to develop spongy materials kind of from other materials in a very simpler way. Well, one can talk in the same way like we were talking about nanoscale materials, top down and the bottom up approach, but both are not really feasible in the sense that we are more or less try to kind of either we take a bulk piece and selectively try to etch it using chemically, are focused on beam milling more or less, but they are complicated kind of processes too. At the same time, if we develop a material which involves a lot of steps, means this is involving high cost. And then again, we have the problem other way around. We could make the nanowire interconnects and we could more or less try to put them together, but that is also a challenging task. And where comes our role here? The smart materials group. While you are walking and the beachside in Mumbai, you can easily see that these ceramic building blocks, which are four-legged building blocks called tetrapods, they are lying around, and they are lying around there because of certain purpose, not because just by mistake. When we put them together, they have the ability, because of the complex structure and the shape, they are able to assemble themselves in a form where you have the random degree of porosity. The water waves can go and can reduce the drag of the water very easily. And this forms a self-assembled architecture with very efficient geometry, which can efficiently reduce the pressure of the water wave rather than a solid concrete wall. And this gave us a motivation that if we could develop micro and nanoscale tetrapod elements from a material, then I could construct a three-dimensional material with a random degree of porosity, even high porosity, and that can give us a very high surface area accessibility, which is something which is the most important activity in our group. We are developing these micro and nanoscale tetrapods from zinc oxide, and then we are using them in a lot of applications. That's what our focus is: designing the new materials, functionalizing them, and using them in many applications. And this is our small team which was developed during the Corona time, and we are going forward. So making the story short, I developed a process which is called a flame transport synthesis process, and this is a single step conversion process of zinc metallic particles microscale diameters into directly into the tetrapod. The process works like this. Again, this is an inspiration of kitchen. If you forget something into the oven, and if the food burns, then it goes up, and then afterwards in the oven you see a lot of black particles are falling around at the ground. Basically a housewife or a house person says that this is the garbage I am going to throw out. But if a nanotechnology person will say, no, I will take this to the SEM and will characterize this is probably some kind of nanocarbon. Somehow the same motivation, it worked out that in a single step, if we mix a precursor material zinc and polyvinyl butyrol into a ceramic crucible and burn it at high temperature, this is going to be converted into zinc atomic vapor, and with the help of oxygen we can have a growth of micro and nano structure. It is a solid vapor solid process, and initially first we have the normal clustering, and afterwards we have several possibilities. If we apply a substrate on the top, then we can grow 1D wires. Zinc oxide has hexagonal Woodside crystal structure with kind of non-centrosymmetric structure. So it is the fastest growth along the C-axis. But if we do not apply any catcher substrate, then you could go ahead and first what happens that we have a growth of octahedral nuclei, and then we have growth of C-axis growth along 4 facets. And in this way,
Professor, what is this flame transport system? What is flame transport?
This is a message because the flame is carrying those metallic particles into the inside to the top, and it is converting directly these metallic particles into the zinc atomic vapor. So it's a version of solid vapor solid process, but this is kind of performed by the flame. So in the same way, like you say, vapor transport process, it is kind of, we named it as a flame transport synthesis process. Yeah. And it simply works like this, that we fill the precursor material into the ceramic crucible, which is a black because of zinc particles, and then simply heat it. This is how the crucible looks like when the process is going on, and afterwards the crucible is filled with white snowflake like material, which is completely built out of the zinc oxide tetrapod like micro and nano structures. And here you see a simple view that these are micro nanoscopic tetrapods, and when we put together, they are able to form this self-assembled network, three-dimensional network, sponge-like network with very high degree of porosity. High porosity means the material is able to offer the high surface area accessibility, and the nanoscale material is simply, it's the surface which is the most important thing, and its accessibility is the second aspect. How to design a material with very high surface, and how to enable the material so that the high surface is accessible. These are the two most important aspects into the nanotechnology, where we have optimized, and in a way, by changing this process, we have the possibility even to change it more. We could even tune the arm ratio from micro to nano to really high, very high aspect ratio this way. When you see this kind of tetrapod, then you might imagine that this is a kind of conical structure and a smooth structure going from bottom to top. However, it is not the case. Let me run this movie, that you see that when we go from bottom to top, we have a lot of kind of staircase structure, and every restructuring at the surface is going to generate additional surfaces, and you know very well that the surface is the key thing in the nanotechnology, leading to new properties. So this has been a kind of key aspect, growing different tetrapods, engineering the surface and restructuring it in a form of to optimize the surface, and that has been really working pretty well since last 12 years. I have been working on this topic. I initiated in Kiel. And how we design the three-dimensional material. This is another fantastic story. Like I told at the beginning, if you put these tetrapods together, they form a self-assembled network, but as a loose powder, how it is just sticking in form of a ceramic material or a tablet, more or less. What we do, we fill the ceramic, we fill the tetrapods into the ceramic molds with well-defined volume and the amount we can decide, and then we heat up to high temperature of 1150 degrees centigrade, and this leads to the formation of these white tablet-like, maybe sugar tablet-like material, but they are made out of the zinc oxide. And the advantage is, one second. Sorry, there was something. So the advantage of these tablets is that they are very highly porous, and we have the possibility to tune their porosity from very low to very high. So all these tablets are around 95% porous. They are inflammable, high temperature stable, lightweight, and highly porous, flexible as well. They have the flexibility of like rubber, like Young's modulus in the range of few hundred, ranging from few megapascals to few hundred megapascals. And we have the possibility to tailor the Young's modulus depending upon the requirement. Well, and that is about actually the core activity in designing this new class of three-dimensional materials, functionalizing them, and using them several applications. You might wonder what are the possible applications one can use, and first applications in this material is the zinc oxide, which is n-type, inherent n-type semiconductor with wide band gap. So it's often anybody is designing new nanomaterial from zinc oxide going directly to the sensor, UV sensor, more or less in the same way we proceed. And think of designing a sensor out of the thin film of a nanowire. We often have the problem, first we have to make a thin film, but then we have the limited surface area accessibility, only the top surface is accessible. In the nanowire, we have a lot of challenges how to make the device, and still nanowires full surface is not accessible. In this way, these tetrapods offer really a kind of nice opportunity that we can design a bridge, a porous bridge, and mount directly onto the electrode, or we can even design a self-supported bridge and directly connect it to the outside voltage supply and everything to make a device. In this way, universal sensors can be designed, and we have done quite a lot in this direction: UV sensing, gas sensing, including hydrogen sensing, and we have understood the mechanism, how the width, how kind of the width of conduction channel increases or decreases, leading to the sensitivity of these materials with respect to the different gases. This has been nearly established more or less, and we are somewhere here. Actually, something what is rather unique when we want to sense a large molecule, for example, biological molecule with nanowires, we often have the problem how much surface area is intact. Here, these networks with high porosity, they offer that even cells, viruses, bacteria, they can move inside, and they could really contribute to the high sensitivity. So in fact, there are a large number of sensing opportunities which can be designed, and we have been working with this. What is something rather, maybe those who are working with zinc oxide, this is network is flexible, so we can make a kind of flexible sensors. And the zinc oxide is a very robust material, since a kind of mechanically very stable, physically very stable up to high temperature. So this can be used for high temperature sensing as well. And as I told, it has a non-centrosymmetric crystal structure with C-axis orientation, hexagonal both side. That means that if you bend a rod, then you are going to develop opposite potential, which is going to give you a piezo potential. And if carefully connected, we are able to power the device itself. So this opens opportunity to design self-powered sensors, for example. And but this is the positive thing what I told. We do have a lot of kind of challenges. For example, selectivity in the laboratory, we nicely put in the chamber which gas, methane, ethanol, or whatever, then we know what are we sensing, and we are very happy with the sensing response. But what about if we take our sensors to the crossroad and next to the university, and then if the sensor is able to tell which gas it is sensing, that is another aspect. So selectivity with respect to the gases. And think about zinc oxide is chemically unstable, so it behaves like sodium chloride. If you put it to the lower pH values in the solutions, more or less it starts melting. So one has to think about, and there are a lot of other compatibilities which are needed. First we really go to the kind of sensing, but this we could solve it by designing kind of selectivity. We could engineer by designing kind of hybrid tetrapods which are functionalized with appropriate nanostructures or markers selectivity with respect to particular gases. So this can be done, and even we could design new materials also. So we have been working quite a lot. If you are interested, please see our papers. And we recently wrote a nice review about kind of gas sensing materials, gas sensing plus and minus, what material one should choose, which gas we want to sense. So please have a look. And since the development 2 years, 3 years, we have been on the situation of shutdown due to the virus, you know already, and that increase the demand to go more into the biosensing, and if possible the treatment. And zinc oxide is also a good material, so we are more moving into the kind of tetrapods and 1D zinc oxide based biosensing, diagnosis, and the treatment. These simultaneous platforms are going to be very helpful if developed carefully. So please have a look. This is a field opening article we have been trying to do. Another field where we are trying, please let me know how much time we have, then I will speed up accordingly.
7 minutes more.
Oh, okay. Yeah. Another field where we have been working on, often the designing the composite materials. We starting from our kitchen to airplane wings, we are using polymer-based materials. And they are often composite materials, something filled in because we want to improve the properties, mechanical, electrical, optical, and different properties of these composite materials. And often we struggle with nanoparticles and other wires, basically, that if they agglomerate into the composite material, then we have the problem. We do not want agglomeration, rather we want their homogeneous distribution. And here these tetrapods, because of their complex shape, it is a very unique opportunity that does not matter how we place them inside the material. They behave like kind of an element which can self-assemble themselves into homogeneous into the entire specimen. In this way, we have been working with polymer engineering in terms of smart composites since a really long time. We have been able to change the electrical, optical, mechanical, thermal, and dielectric and wettability and many other properties of polymeric materials, more or less in the composite form. Even we have been able to design advanced composite materials which are able to tell reflect a color change via using a marker. We took the tetrapods, decorated them with this pyropyran molecule, which is having a chemical structure like this, and under the pressure or under the impact, it changes its color. So imagine that design a composite material into the PTU matrix, that if it is changing its color under the impact of heat, light, and sound, that could be really an advantage of something. For example, identifying a damage on the surface, it is fine, but identifying internal damages into the composite materials is a big challenge. We have to damage the material to identify the damage, but this could be a way to more or less get the information about the damage directly as a visible color change. So that's another field we have been working on quite a lot, and this still is going on. So if you are interested, please let me know. And then another field which came all of kind of on the way, but since out of sudden, but it has been very long. We have been working with that. Often when you develop a new material, you have the opportunity to talk with interdisciplinary community and that to explore different material applications in different directions. The same way we started with colleagues from University of Illinois at Chicago. And usually, viruses which are at the big hype at the moment. So usually what happens that kind of our aim was to investigate if these nanomaterials could act against viruses which go into the cell, damage the cell, and then multiply the viruses. So what we did, we took the battery disk and we put the cells and the viruses, and we put our nanomaterials and monitors the virus multiplication. So the simple mechanism is here how the virus goes into the cell. It first interacts with the surface, which are some chemical bonds, receptors we call them, and then it goes and it damages the cell and multiply. But if we put our tetrapods and nanoversions, then these viruses are blocked by our structure. They do not, at least up to certain extent. And this was confirmed further because of the structure of the zinc oxide tetrapod arms, and also the oxygen vacancies are helping a lot. They are positively charged, and the viruses are having envelope which is made out of heparan sulfate, which is negatively charged. So this way it works like we can catch the viruses out of liquid, more or less this material can catch. And this we went in this direction quite a long way. We have checked for many viruses: herpes simplex virus 1, type 2, human papilloma virus, monkey virus, zoster virus, adenovirus, several viruses. And this has been developed really a long field, something which we must ask ourselves when we develop a new material: what about its cytotoxicity? Because if material is killing the normal cells as well, then there is a problem. But we did a detailed study in this direction, and we found that our tetrapods are quite less cytotoxic, and that motivated us to go deep into the direction to do even animal studies. So we infected mice with genital herpes, which is a very recurring and severe disease, and people really want to get rid of, and then treated the mice with zinc oxide tetrapods. You see the response here, that basically the mice survived quite long. And the best answer is shown here. And the tetrapods are able to bind the viruses, and they are also able to trigger the cell signal to the WBCs. Then WBCs, they know where to go and where to grab the virus. And also there is a certain amount of release of zinc ions around, so that was leading to a better kind of improved kind of wound care in those directions. Something which is very important probably to mention, that we did animal studies and human trials. We got very good results, and a company, our startup company in Kiel, is nearly going to launch a product in this direction. Maybe some of you know already, zinc is a very important element for our human body. It controls the metabolic functions, enzymatic reactions, and it is given as an immune booster in corona time. Probably some of you have taken several zinc tablets already, so you know it. And if it goes into the body, it is dissolved into the acidic medium. So this is a very important material, biomaterial so far.
You have 3 minutes.
Yeah,
you have 3 minutes.
Yeah, then I'm going to be quick. So basically, then we have been working quite a lot in this direction. We could input this material into the fibers to design membranes which are able to kind of stop basically the bacterial growth at the root canals, more or less. And we could put into the fibers which are used for wound healing, more or less, into this kind of stitching fibers, and we could improve their kind of properties like antibacterial, antimicrobial, and antifungal. And recently we have shown that these fibers are even able to bind and neutralize the viruses. So a lot of things are happening into the biomedical direction. We are able to design kind of these bandits which are able to release the drug under controlled manner just by shining the light. So this is a separate field which is going on quite a lot. And then, of course, a few glimpses I would like to give that tetrapods, what I have told here, it's just 5% what we have been working on. I could keep on talking days, hours, and months about tetrapods, so that you see the importance of the field. And then the question automatically comes, why can't we develop tetrapod from other material? And the answer is no, because this is the material which decides how it wants to grow, its crystal structure and the experimental condition. But we found a way, because they are chemically unstable, we decided to use them as template. We can deposit any new material on the top, and then we can remove the underneath backbone, and then we can design new materials which are exactly in the tetrapodal form. So this is how the process works. Like, we can take any solution, for example, and we can drop on the 3D networks. There is a homogeneous coating, and then if we need, we can have a composite material. If we need, we can remove underneath backbone, and then we have a new carbon material exactly in the same form with very high surface, more or less. So there are a large number of possibilities for the material engineering. We can almost design any material in this 3D highly porous interconnected network form, and which can be used for different kind of applications. It could be graphene, it could be whatever material one is willing to, one can design. And we can tailor the properties, electrical, mechanical, thermal, and other properties in a very nice way. And on the top of that, we could also mount a different kind of external nanostructures to functionalize them. Then we have access to the both zinc oxide and the external function. For example, we put this activated carbon, which was able to help us in remove the chromium kind of ions from dirty water, or even the magnetic nanorods together with zinc oxide. It was able to separate the diesel from the water, more or less, so removing the oil separation from water, and putting the copper oxide and the zinc oxide to have the photocatalysis and heavy metal ion removal as a single platform. So basically, when we talk about nanomaterial, we usually say that this kind of something nanomaterial, we take the effect, but where the nanomaterial is going later on, we are not able to care very nicely. But in this form, we know that we have the effect, but we are also keeping the future history of the material in a very good way. We are not further contaminating the material, kind of, for example, liquids, which is very good. So, I mean, more or less, I'm at the last slide already, that we are able to, this is a new field based on tetrapods, and we are able to design different types of new three-dimensional materials from carbon. Even the hard materials like gallium nitride and boron nitride can be designed, and we are working in the direction of energy catalysis, composite materials, biomedical, and a lot of other fields, advanced dielectrics. So I'm sorry for a little bit faster enough. As I start with the talk, usually that please do not work with zinc oxide, because there are more than probably 1 million papers available. It is hard to find a motivation, because this is so simple material. But I started around 12 years before, and then I came up with this tetrapod kind of idea, which now gave us very nice opportunities. And I now say that I don't know anything about zinc oxide. Please have a look on this invited kind of review in materials today. We learned that if you combine the material properties together with a kind of complex shape and the structure, then there are a lot of new avenues are available. So please have a look on this. It is going to give you the open scopes into the zinc oxide and the materials engineering and open applications. Recently, we made more or less a kind of a defect in zinc oxide, which is another important topic. Often we take defects as bad thing, no, but we should take defect as good thing, because they are going to give even much nice properties, and we could even design a three-dimensional neural circuits and many other kind of. So with this, I would like to end up my talk. I would like to thank Professor Adelung. I worked at Keele University under in his group as around 11-12 years, and then I moved to Denmark just before Corona. And basically, we are developing new class of materials and functionalizing them, and then we are collaborating with different groups worldwide. So I thanks to them, our collaborators. They have been very good lessons. And I would like to thank our collaborators and the colleagues at here SDU Denmark, who are really supporting, and the funding agencies here in mainly in Denmark, in European Union, and India as well. And there are many other activities. So I hope, sorry for the kind of little bit fast talk, I hope that I could give an impression about that, how the structure of the material, how the shape of the nanomaterial could play an important role into the nanotechnology, nanoengineering, and could give rise to many opportunities into materials engineering and accordingly applications in different directions. So with this, I would like to end up my talk, and if there are any questions, I will be very happy to answer.
Thank you, Mr. For very interesting work. Thank you for you. Thank you very much for very interesting work.
Thank you, sir. Thank you very much for taking the time to talk to us. I very much appreciate the time you spent discussing all these things with us. Once again, thank you so much, sir. Well, now I would feel really, really grateful if we could have Dr. Parvatalu with us, and who is domain expert ONGC Energy Center ex-project manager. I think he's not with us, and now I would like to invite Dr. Dinesh Goyal for invited talk, who is Director PIET India.
Good afternoon, everyone.
Good afternoon, sir.
Just a minute, please. Hello.
Hello, sir.
कहाँ पहुंचा है बेटा? जल्दी पहुंच बेटा, बच्चे वेट कर रहे हैं बहुत ज्यादा, है ना? अंदर जाना पड़ेगा बच्चों को लेने ना, अंदर है अंदर. Good afternoon, everyone.
Good afternoon.
Good afternoon, sir.
Just a minute, my screen is sharing.
Okay.
Is my screen visible to all of you?
Yes, sir. But go to slide mode.
Sir, yeah, audio is quite low, sir.
Audio is okay. Go to slide mode.
Sir?
Show slide mode. Presentation is visible, but slide is not in slide mode.
Sir, kindly make it full screen, sir, using F5 key.
Okay.
Please click on.
I'm not able to understand, sir. Your audio is quite low.
Okay,
Sir.
well, sir, please click on slideshow.
Go to slideshow.
So I've done a slideshow only. This is slideshow only, sir.
In the down, you have a slideshow. One cup type. There's a cup type. You click the cup.
So I'm not able to understand your request.
In the your presentation, you go to down and you will find a slide mode.
So I'm in a slide mode only, PPT mode only. Slide. You want to mean slide mode this way?
Sir, press F5.
So I'm doing that only, sir. This is slideshow only.
Please, sir, reshare your PPT.
Just a minute, sir. Just a minute, sir.
Yeah. I'm just stopping your sharing. Now share again. Sir.
Is it visible now?
It's taking time, sir.
Now it's okay.
It's fine, sir. Now you can continue.
Okay, it was some issue with the Zoom, I think. So thank you, Vedanta PG Girls College and Dr. Prashant Madan for inviting me to deliver a talk on National Education Policy 2020. I take this privilege to share a few of my thoughts so that everybody is enlightened how National Education Policy will be changing the education paradigm in country in coming few years. So friends and colleagues and senior professors and academicians, if I am supposed to explain NEP in 3 lines, I'll be explaining it in Hindi in 3 ways. जो पढ़ना है पढ़ो, जब पढ़ना है पढ़ो और जहां पढ़ना है पढ़ो. This is the crux of NEP. If you want to complete your degree from one institution to another, you want to jump it from one institution to another, nobody will stop you. If you want to change your discipline from sciences to commerce, commerce to management, management to arts, or arts back to sciences, you can. And if you want to take a break of 2 years and then do job or some family responsibility, and then you want to come back for education, you can come back. So this is the crux of NEP. Now, in my presentation, I'll be sharing all such things to give you an idea how it is doing this thing. So, Union Cabinet of India approved the National Education Policy on 29 July 2020. It replaces the previous policy, which was a National Policy of Education (NPE), dated 1996. Policy aims to transform engineering education by 2040. It has certain goals and sets, with goals being set for it, and for that, it is aiming to have by 2040 the goals will be achieved. So, Ministry of Human Resources is now a Ministry of Education, as being notified in last 1.5 years, it has been changed. Has set few goals at school level and college levels under NEP. So first one is at schools, it will be, instead of having 10+2 structure, which we have all gone through, our kids and our younger brothers and sisters will be following pattern of 5+3+3+4, which focuses more on foundation studies. As I said, multi-stream, you can choose commerce with science, you can choose science with arts, there can be multiple streams. Diluted board exams will be already have started in 2 phases. Multilingual, instead of having, if you have seen notification of CUET, it has already said that a CUET entrance exam will be held in 14 languages. Then, of course, they assume that 1 or 2 days in a week will be backless days in all schools. For colleges, set like college test exam, CUET exam has been announced, will be held across country with syllabus of CBSE class 12. Across country, all central universities will take admissions through this only. IIT, JEE is conducting engineering exams, central university exams are happening. So all of things are clubbing together. The bachelor's degree, which you all are going through, will be now optional for 3 years or 4 years. If you do it for 4 years, you have liberty to expand your UG directly to PhD program. That I'll come in later. No affiliation for institutions. So today, any institution like your institution or mine one are affiliated to certain university. In future, they will not be affiliated to any university. They will be self-autonomous colleges. Government wants to regulate fees also. That high fees should not be charged for the students, and going local means with Indian ethos being going across the globe so that everybody follows this thing. So key principles of NEP as per Ministry of Education are respect for diversity and local context. In all curriculum and pedagogy and policy, government wants to plan, and it's a very good thing that every culture should be taught to students. Ramayana, Mahabharata, and Gita, and also should be part of academics, and this is already started across country. Equity and inclusion. Objective is to ensure everybody gets education, and at low cost, everybody participates in education. That will come into detail. Community participation, encourage and facilitation for philanthropic, asking more groups like Vedanta to join and participate in education, so that people which are good at funds, good at do this activity at CSR level. There will be education institutes in PPP mode. Objective is to bring private players more towards, not as a business model, more towards a social service model in education. Pandemic has already taught us how to deal education in technology with technology. Government wants to continue this technology in education, so that people across country use 25% of their academics and assessment models in technology, conducting technology only. Then emphasize conceptual understanding. Rather than rote learning, more practical based learning, more focus on hands-on learning will be there. Unique capabilities. They have a mission to recognize capabilities of each and every student by organizing, funding various activities. They have funded right now 55 lakh rupees to my institution for establishing an idea lab where students can work with their own hand and they can participate in critical thinking. Especially in technical education, what is happening is that is high weightage of end-term assessment. So government wants to reduce it to less on high-end assessment, and they want to focus more on what you call continuous assessment, so that students are studying regularly and fail होने के chances कम रहेंगे उस केस में. So 4 focus areas of NEP are school education, higher education, other key areas of focus, making it happen. So when you talk about school education, they first want early childhood care and education. So I'll show this thing how the government has aimed to create this model. Earlier, we used to study in a model where first 5 years were not mandatory for us to go to school. Being in city in Rajasthan, this was in Jaipur, I would have gone to school, my kids. But in rural areas, government schools, there was not mandatory. Classes used to start from class 1 only. Now the model is changing towards foundation stage of 5 years, where 3 years from age 3 to 6, Anganwadis will be mandatory for all students, and class 1 and 2 from 6 to 8 will be there for 2 years. Then there will be class 3 to 8, that is preparatory stage, where students will be more play, activity-based learning, interactive classroom learning, that will be more focused on. Then middle class of 3 years, 6 to 8 will be focused on experimental learning, hands-on learning, doing by your own. That is the focus. Then class 4, then multidisciplinary. You can choose, as I said, you can choose science with arts. Models are being created where you can take subjects of science and arts. For 11th, you would have taken science, and 12th, you say, I'm not liking science. You can switch to 12 arts. Presently, board doesn't allow you. CBSE or ISM board both doesn't allow you. So, but in future, they will also allow you. So, sorry. Is it visible?
Not in slide mode.
Just a minute, sir.
Make it full screen, sir.
Again, I think it's visible now.
Yes.
Fine. So,
yes, fine.
Fine. Then focus on foundation literacy and numeracy. Government is focusing on urgent necessary requirement of everybody should participate in education. And foundation should be cleared by, because today also India has almost 70% of the population educated, 30% education. Of course, there are states like what you call Karnataka where 99% population is educated, but there are states like Rajasthan or many other states where I have 70-75% population being educated. So literacy and numeracy is the main focus, where numerical knowledge of this numbers should be there with every individual, and basic literacy of read and write should be there with everybody. Then curtailing dropout rates. What is happening is that if you see every year around 1 million students go for higher studies. But that number, that is 10 lakh students roughly. But that number is only 30% of the total students who do 12th. So 70% students don't go to higher studies after class 12. And this is happening at all levels. At middle level also, at higher education level also, at pre-primary level also, kids go to school for first 3 years for midday meal, or 5 years, then they stop going. They do 8th and start doing handling shops. So the objective is to exploit access to education to everybody, so that everybody can get an idea about learning. And then curriculum pedagogy in school should be more holistic, integrated, enjoyable, and engaging. The major focus, of course, school education has been already privileged with teachers training, but still more focus has to be taken on teachers training in recent changing in paradigm, the recent changes in education which is happening right now. Learning for all, then efficient resourcing and effective governance through complex cluster making. And now government is bringing a new more concept, is the accreditation of schools. Right now, schools are not accredited. Higher education institutes are accredited. Just a minute, please, sir. Hi, Manshu. अंदर जा ऑफिस में अंदर जा अब बोलना नहीं फोन नहीं है बेटा उनके पास दिक्कत ये है तभी तो परेशानी है अंदर जा उनको बोल गार्ड को बोल आदित्य को अंदर होगा बच्चा so then standard setting in education, as I said, right now higher education institutes are like colleges and are NAAC accredited or NB accredited or any other accreditations are there, but schools they are not. So they will also be accredited now. Then coming to higher education, lot of changes happening in higher education. First of all, there will be only 3 or 4 categories of institutions only. Right now there are 5 to 6 categories. I'll be discussing them. There will be a restructuring. The governance of the institutions also will be changing. The regulatory bodies are changing. Holistic and multidisciplinary education, we are starting engineering in regional language now. Effective governance and leadership for higher education. Then motivated, energized and capable faculty. Teachers education, again, it is again part of it. Just a minute again. Fine. So holistic and multidisciplinary approach, optimal learning environment, so that students are classroom engaged more, they are more into field, they are more into practical learning. As I said, governance model of higher education is going to change. I'll be discussing everything, and they are focusing on training the teachers also, so that more focus is given on training the teachers, so that and that today distance learning and for last apart from last 2 years, that distance learning and vocational education was not taken so seriously in country. Now government is trying to say that that is also a model of education and we should accept it also. So as I said, the structure of universities or institutions will be changing. The first change which is happening is there will be only 4 categories of institutions. There will be no affiliated college, no deemed to be universities, either research universities, teaching universities, autonomous universities, autonomous colleges, and Meru. The research universities will be focusing more on research. Teaching universities will be focusing more on more number of students focusing on classroom teaching. Autonomous college will not take, they will be only giving the degrees by themselves. Then Meru, institutes like IITs, IIMs, which will be doing this thing. Fine. A future structure of governance of higher education will be like this. There will be a council called as HECI, which will be replacing UGC and AIC and all everybody's. It will be having 4 sections: GEC, General Education Council, will be setting standards; NHERC, which will be taking care of regulations; NAC will be NAC, and HEGC will be taking care of fundings. The programs which are going to change is now MPhil is no more a program in India. PhD program will be 3 years. It will be 4 years for the people who are interested to do a PhD after your bachelor's degree. Bachelor's degree will be 3 years and will be having an exit option for the students. Certificate after completing 1 year, diploma after 2 years, so you can exit anytime. Bachelor's degree after 3 years, multidisciplinary bachelor's degree after 4 years. And master's program will be of 2 years after 3 years of bachelor degree, and 1 year after your 4 years of bachelor degree. Then integrated program will be of 5 years, which will be bachelor and master's combined together, with exit option will be there with all of you. Now, these are basic principles of new education policy. Flexibility, as I said, no hard separations. You can choose multiple disciplines. More focus on our ethos, more focus on regional language, higher education, school education, sorry. Grade 3 education mandatory for all of the people in country, and class 3 classes se padha hua hoga har koi India mein. Then emphasis on conceptual understanding, creating critical thinking, ye apan discuss kar chuke sara. Then synergy in curriculum across the levels of education, so that aap ek institution dusre institution switch kar sakte hain. Teachers and faculty are as the heart of the learning process, so that they are trained more, they are more facilitated. Outstanding research, they will be for research, there will be awards also. For research, they will be giving you what you call a lot more recognitions. They'll part of accreditation also. Then substantial investment in strong, vibrant public and education. President said that philanthropists will be invited to participate in education. We will always be taking pride of India first, and education system will be more light but tight. The vision is to have Bharat first as the first vision says that they should be, everybody should talk about Bharat first, not about global world, this thing. First talk about India, then constitution values, then of course skill, everything matters for every citizen. So as I said, universities will be changing now. Quality universities, colleges will be there. There will be, if there are less than 3,000 students, school colleges will be merged together also. So every college has to, by 2035, every college has to have 3,000 students at least. Then when you have 3,000 students, you will have quality faculty, your scientific temper should be there, creativity should be there. These all should be the minimum criteria for being part of the education institutions. And the research funding body, right now we have SERB, DST, and many more funding bodies. They are all coming under NRF, that is NHEGC, which is National Higher Education Grant Council. Again, sorry for 1 minute. हिमांशु ले लिया बच्चों को? आधी साथ करा मेरी। अंकल के फोन से चाचा को बात कर लो, है ना, और बोलो कि हम निकल गए, कार को छोड़ेंगे पहले, है ना। चलिए, so my one problem is resolved. The policy envisions key changes in the moving towards multidisciplinary universities, as I said, moving towards a more disciplinary undergraduate education, moving towards faculty and institution बेटा बच्चों का फोन आ रहा है तेरे पास, मेरा सेशन चल रहा है बेटा, मेरा बच्चों का फोन आ रहा है, मेरा सेशन चल रहा है। हाँ आदि कॉल कर रहा है, आदि कॉल कर रहा है, बोल दिया मैंने उसको। Moving towards more multidisciplinary undergraduate education, moving towards faculty and institutional autonomy, revamping curriculum, reaffirming the integrity of faculty and institutions, establishment of NRF. So as I said, by 2040, no institution will be having less than 3,000 students, and they will be either autonomous institutions or universities only. Aim of government is today the enrollment in higher education is 26.3%, which will be aim is to have it around 50%. Growth will be in both public and private institutions. Objective is to increase more private institutions also. Apart from that, you have seen a lot of medical colleges being announced by Government of Rajasthan and Government of India both. Healthcare is now focused, education is focused. Then autonomous degree granting colleges. So we all can become a degree granting colleges instead of being a university. The definition of university will thus allow a spectrum of institutions that range from those that place emphasis on research intensive or teaching incentive universities. Of course, they have to declare that first. We are what? The government has already notified that thing. Then holistic multidisciplinary education would aim to develop human values, ethics, aesthetics in the student. Even emerging institutions such as IITs will be needed. This thing. Departments in languages, literature will be part of even technical institutions, non-technical institutions also. This is towards a more holistic and multidisciplinary education than a 3 to 4 years degree program. Academic bank, so that what this ABC academic bank will do is that हाँ अभी तो फोन आएगा मेरे पास, तेरे फोन पे कॉल कर रहे हैं, उनको कॉल कर रहे तू, और मेरे को मेरी क्लास चल रही है बेटा, मेरे को मेरी क्लास की बात करें डायरेक्टली, है ना। So ABC will help us, all of us, to change institutions. Let's say you are studying with Purnima Institute and you want to change to Vedanta College. So your all credits will be stored on a DigiLocker. And tomorrow, after 2 years, you want to study or immediately want to study to at Vedanta PG College, you can immediately switch to that place without any restrictions. Nobody will be. Only thing is you have to have minimum 40 credits per year, and after having 40 credits that year, you can easily switch to that place. The 4-year program may also lead to a degree with research, as already notified that after 3 years of UG, if you take 1 year as a PG program, 1 year research program, then you can apply for PhD program for 5 years. So your duration will be reduced. You can directly do PhD, no need of doing PG program. Then there will be model institutes, which will be called as Meru. They will function at national vision and mission like IITs and IIMs or such institutes. HEIs will focus on research and innovation by setting up startup incubation centers, technology development centers, center in frontier area of research, greater industry academic linkages. They are already starting to pressurize all of us for this. Optimal learning environment and support for students. Institution and faculty will have the autonomy to innovate and change the teaching pedagogy. They will not be limiting kaise padhana hai. The CBCS model will be revised. HEI shall move to a criteria-based grading system that assesses students' achievement on learning goals for each year. HEI shall also move away from high-stake examinations towards more comprehensive. As I said, there will be more continuous assessment. Then optimal, each institution will integrate in academic plans. IDPs will be shared. Like जैसे स्कूल में डायरी मिलती थी ना, वैसे इंस्टीट्यूशन को अपनी डायरी बना रही है, हमारा प्लान क्या है फॉर नेक्स्ट 5 years. They have to show it to UGC also and to students. So that will be called as IDPs. Government is more focused on open and distance learning. Already started giving approvals to many institutions to do ODL learning, so that distance education and enrollment can be increased. All HIs will be equipped with the basic infrastructure facilities. If not, they will fund them also. Every classroom will have latest education technology tools. Faculty will be given freedom to design their own curriculum. Syllabus fixed नहीं होगा कि राजस्थान यूनिवर्सिटी ने ये बोला है या XYZ यूनिवर्सिटी ने बोला है, वही रहेगा syllabus, है ना? Vocational education will be integrated into all schools and higher education system. Government is focusing on, so if you are doing distance education or you want to have focus on skill development, you can go for vocational education. Establishment of NRF for research funding. They fund will be peer reviewed. There will be competitive scaling system, how you are performing. If you're performing well, your funding will increase. If you're not performing well, your funding will decrease. Then your seed money will be given. And if you're doing well, your act liaison between research and decision, and there will be a performance metric of every research. Government is ensured that there will be a fee cap for every this thing. Let's say for engineering or sciences or management, if there some institutions are in practice of charging very high fee, so NHRC, NHERC, and NAC will ensure that no student is charged fee more than what is the upper cap of the fee in any part of the country. Then promotion of Indian languages, arts and culture. Government is focusing on like we have in my institution, we have started BTech in regional language. You can have BTech. You will be seeing many programs happening in regional language. अभी तो आप लोग सिर्फ science, arts ही पढ़ रहे थे, science भी ज़्यादा नहीं पढ़ रहे. अब technical education, professional education भी regional language होने लग गई है. Then human values पे बहुत सारा focus आने लग गया है. Then we are government establishing Indian Institute of Translation and Interpretation, जहाँ पे कि सारी चीजें एक दूसरे लैंग्वेज ट्रांसफर होते हैं, so that you can study in language you prefer. Sanskrit will be mandatory now in all schools. The major other part of NEP which are not that important, that professional education is one focus which government is trying to add. Then many people have left education, they are now in doing mazduri या labor कर रहे हैं वो. They will be focusing on education, adult learning, promotion of Indian languages, arts and culture, technology use in integration, online and digital education, and then strategy of this thing. So if you ask me what is the NEP in nutshell, the NEP in nutshell is there are 16 points which NEP can be justified. New structure with 5 + 3 + 4, NR National Research Foundation, formative assessment more, जहाँ पे कि classroom summative assessment यानी end term exam कम होंगे. Multiple entry exit यानी कभी भी आप छोड़ सकते हैं, कभी भी आप join कर सकते हैं. Then life skills, focus on training students on all part of NAC, accreditation council. Multidisciplinary learning where you can go and study anything, anywhere, anytime. Holistic education, talk about your ethos, talk about your religion, talk about your history, everything. Multilingualism, you can learn in multiple languages. Technology integration, focus on vocational education, conceptual understanding, where concepts are more clear. Experimental learning, critical thinking, teacher education, focus on NITTT, 4 years teacher, and HEIKI, the governing body finally. This is from Ministry of Education website only. This is the timeline. Already the work has started on this direction. NPST is in making, and by 2040, all institutions across country will be adhering to NEP. Teachers training, higher increase of enrollment, grade 3 education for all in country. Everything is part of NEP. Thank you, everybody, and thank you for patiently listening.
Ayushi.
Hello.
Jal sir, do you want to say something? Well,
Professor Jain Sahab. Dinesh ji, am I audible?
Yes.
Yes, sir.
Dinesh ji, I just want to ask, एक vocational
be a bit louder थोड़ा सा बस.
हम जब वोकेशनल की बात करते हैं तो एक वोकेशनल का एक ट्रेंड चला, पहले वोकेशनल पे बात हो रही थी, फिर बीच में डाउनफॉल आया. तो ये वोकेशनल जब हम बात करते हैं तो बच्चे थोड़ा सा दूर हो जाते हैं इस चीज से.
हाँ सर.
हम जो एक स्किल डेवलपमेंट की बात करते हैं, ये कहीं ना कहीं पे बच्चे दूर हो जाते हैं. मेरी ये बहुत बड़ी समस्या है. हम स्किल डेवलपमेंट करना चाहते हैं, हम एज अ ऑर्गेनाइजेशन इसको बहुत अच्छे स्केल पे डेवलप करना चाहते हैं, बट द स्टूडेंट्स दे जस्ट ड्रिफ्ट अवे. नाउ हाउ वी कुड,
बेसिकली हमारे मन में एक वहम है. हम इंडियंस में एक बहुत एक छोटे सी चीज से हम एक्सपेरिमेंट से डरते हैं हमेशा, है ना. वोकेशनल एजुकेशन या BVOC जब आया, या BVOC या उसके अंदर मल्टी एग्जिट ऑप्शन आया, तो उसके अंदर एक प्रॉब्लम भी साथ में आई कि लोगों को एक कॉन्फिडेंस था कि इससे हमारी जॉब लग जाएगी। विल समबडी रिकॉग्नाइज आवर डिग्री? ये हमारे लिए बहुत बड़ा कंसर्न रहता है। हम जब एडमिशन भी लेते हैं तो हम ये पहले देखते हैं कि ये इंस्टीट्यूशन कहीं से एफिलिएटेड है क्या। डरते हैं हम आज भी ऑटोनोमस इंस्टीट्यूशन, प्राइवेट इंस्टीट्यूशन में एडमिशन लेने में। ये फैक्ट ऑफ लाइफ है। आप और हम कितना भी बोल रहे हैं कि हम बहुत अच्छा ऐसा कर रहे हैं, तो बी वॉक के साथ भी यही हुआ सर कि आपने अभी तक बीटेक, बीए, बीएससी, बीकॉम तो सुना था। जब बी वॉक आया वो भी फिर आया मल्टीपल एग्जिट ऑप्शन। तो आपको सबको एज ए इंडिविजुअली आपको सबको लगा कि यार ऐसा तो नहीं होगा कि मैंने बी वॉक कर लिया, मेरे को मेरी नौकरी नहीं लगी, मेरे 4 साल खराब हो जाएंगे मेरे। तो ये फियर हमें से जब तभी निकलेगा जब हमारे में से 1000 लोगों में से 10 लोग इसको करेंगे और उनकी कोई सरकारी नौकरी लग जाएगी जिस दिन। उस दिन आपको ध्यान हो, जब राजस्थान में प्राइवेट यूनिवर्सिटीज आई थी 2008 में, तो लोग आप बहुत सारे सवाल करते थे ऐसे कि सर ये प्राइवेट यूनिवर्सिटीज में एडमिशन लेने के हमारी नौकरी तो लगेगी ना। फिर हम प्रूफ देते थे लोगों को कि बैठ के सर देखो ये प्राइवेट यूनिवर्सिटी है, यहाँ से देखो हमारे बच्चे की इसमें नौकरी लग गई। तो ट्रस्ट वैल्यू हमारे लिए बहुत बड़ी चीज है इंडिया में। So BWOC was started very well in 2014-15. It crashed like anything in 18. Then it became part of NEP again. I don't know what is going to happen because now एक राइडर ये भी है कि अब गवर्नमेंट ने क्या कर दिया है कि आपके जो बाकी बीए, बीएससी, बीकॉम है उसमें भी मल्टीपल एग्जिट ऑप्शन दे दिया है। तो ये भी हो सकता है कि आगे आपको BWOC की जरूरत ना पड़े। That is also a challenge which government has to mitigate, that how to have a gap between these two, that BWOC has some other rationale. Of course, they are doing one good thing. I didn't mention my PPT that they are, आप लोगों के पास मेल आया होगा बकायदा यूजीसी से कि जिसमें कि आप 6 महीने बच्चों को क्लासरूम में पढ़ाएं और 6 महीने बच्चों को इंडस्ट्री में भेजें आप। That is also happening. That can be coming under BWOC in future. That is one part. Thank you, sir.
एक और मेरे को हेल्प आपसे चाहिए।
बिल्कुल सर।
हम इन स्टूडेंट्स के लिए, गर्ल स्टूडेंट्स के लिए इस जगह पे कौन कौन से स्किल डेवलप करें? व्हाट स्किल्स यू कैन सजेस्ट?
सर आपके स्टूडेंट्स के प्रोग्राम से क्या चल रहे हैं सर यहाँ पर?
बीए, बीकॉम, बीएससी, एमए, एमकॉम, एमएससी।
Okay, so you are more focusing on commerce and arts, है ना सर? आपके पास स्किल डेवलपमेंट के लिए सबसे पहले तो आज की तारीख में आईटी एक बहुत बड़ा डोमेन है। और किसी टाइम में कहते थे कि इंजीनियरिंग करके आईटी इंडस्ट्री में नौकरी लगती है। आज आईटी इंडस्ट्री सर परेशान है कि उनको एम्प्लॉयज नहीं मिल रहे। इफ यू कैन डाइवर्ट इवन 10% ऑफ योर स्टूडेंट्स इनटू आईटी डोमेन एंड खासकर कॉमर्स के अच्छे सर, फाइनेंशियल सेक्टर में जितनी डिमांड है कॉमर्स और आईटी की नॉलेज की, दैट इज बियॉन्ड पार।
Because as a family, Vedanta Foundation is really interested in developing the skills.
हाँ,
तो हमें अब ये आ रहा था कि हम कुछ एक स्किल डेवलपमेंट इनके लिए करना चाह रहे हैं, एंड दैट इज वेयर वी वांट टू स्टार्ट कि ठीक है आईटी में हम जाना चाह रहे हैं, सर्टेन कोर्सेज, सर्टेन एफिलिएशंस, फ्यू थिंग्स वी वांटेड टू स्टार्ट, बट समवेयर हमें वो एक डायरेक्शन नहीं मिल पाती। तो समवेयर वी वुड लाइक यू टू बी समवेयर मेंटर आवर स्टूडेंट्स।
Sure, sir. Anytime. Anytime. I'll be available anytime. If you invite me, I'll be there in person also. You can I can have one more session, so we can discuss it anytime.
Definitely. Rather, that is what I was looking forward.
Surely help into taking the students into finance sector a lot.
अब ये आईटी हो गया है, लेकिन जब भी आप आके यहाँ पे इन बच्चों से बात करेंगे तभी कुछ मजा आएगा।
बिल्कुल सर, I'll be there anytime. I'll be surely there. After 10th, I can come anytime over there. Actually, my mother's knee replacement is scheduled on day after tomorrow. After 10th, I can come anytime there.
Done. Thank you.
Thank you, sir.
Okay. So thank you so much, sir, for your inspiring address and valuable message. It was really informative. Thank you so much again.
Thank you, everybody. Have a nice time.
Okay, so
Thank you,
now,
sir.
yes, sir. Okay, so now we are going to start our remaining oral session. So first we have abstract ID IC 177 Khushi Sharma from Vedanta College. Please give big hands to Khushi. Start. Good morning, everyone. Myself, Khushi Sharma. I am pursuing MSc Pre-Chemistry from Vedanta PG Girls College, Ringas. Today, I am here to present my PPT presentation on the hydrogen, the future fuel. Why everyone say that hydrogen will be the future of the fuel? Now we discuss this. These are the topics that we discuss in the further presentation. By this, we will get that why everyone say here that hydrogen will be the future of the fuel. First, introduction. Now we know we should have to knowledge about the what is the hydrogen. Hydrogen is the first element of the periodic table, and it is also popular as the joker of the periodic table because its position is not fixed, and it is lightest element of the periodic table, and its weight is less than air, and that's why it always rises in the atmosphere. But hydrogen rarely found in its hydrogen rarely found in its pure form, which is H2O. And STP, hydrogen is non-toxic, non-metallic, colorless, tasteless, and it's highly combustible fuel. Hydrogen fuel hydrogen fuel will be the future of the fuel because it is a zero emission or zero carbon fuel burned with oxygen, and it can be used in the fuel cells, internal combustion engines, and we also can use it as a spacecraft propulsion. Now we come to our next point, that will the silent feature of the hydrogen energy. When hydrogen is burned with air or it is electrochemically oxidized, then it produces heat or the electricity, and it never produces any pollutant gas or greenhouse gases that will increase the pollution, and the byproduct of this is only water. And it is that we discussed before that hydrogen is the lightest element of the periodic table. That's why it is also lightest fuel, and it is the richest energy per unit mass. And in the future, we not face any deficiency for the hydrogen because it's the most abundant. It is the abundant in nature. It is utilized in the, we can utilize hydrogen in many parts of the economy, such as the automotive fuel, generating electricity, or transporting many ways. Its flame speed is much greater than the natural air, and its initiating combustion is less than air or natural air, CFC, or any other fuels. Its energy density is higher than CFC, diesel, as we can see in the slide that there is a difference between the hydrogen fuel and the diesel. Next, we come to the history of the hydrogen. Hydrogen is discovered in 1766 by Henry, and its name hydrogen is given by Antoine in 1783. The first fuel cell is discovered by or invented by the Sir Williamson Robert in 1839, as we can see in figure. In 1959, the first practical hydrogen fuel cell is built by Francis T. Bacon, and on the conventional commercial application, development of the hydrogen is begun in 1973. In 1980, the first maiden flight take by for the last 21 minutes. And now we come to our next topic, hydrogen as a clean energy. This is the biggest reason, that's why we see hydrogen as the future fuel. Being a zero emission carbon fuel, it is considered as the key source of the clean hydrogen, clean energy, and it's the one of the cleanest fuel burned in the air, which produce only water as a byproduct. It never produce any, as we discussed before, it never produce any greenhouse gases or any type of pollutant that will pollute our environment. Hydrogen can be produced by many type of resources that we can see in this image. Hydrogen and source of material can be natural gas, propane, biomass, coal, methane, wind, solar, hydro, uranium, and currently we use natural gas, propane, biomass, coal, methane by electrolysis. And we can see here carbon sequestration is a step in which if any type of carbon dioxide or any type of carbon compound is formed, that will be used in any type or any other works in the industrial areas or other fields. And in the last we got hydrogen. That's why there is no any type of pollutant we create. through the wind or solar. By only electrolysis we can get hydrogen, or by the uranium by electrolysis. If there are any natural nuclear waste disposal that we can use in our nuclear जो fields है वहां पर हम इसको use कर सकते हैं, and then we get in the last hydrogen. In these all the steps, all the reactions that we take here, no any type of pollutant are produced. And we can see here hydrogen can use in the we can use hydrogen as the transformation for example here by reacting with N2 it give our green ammonia, or with reacting with CO2 it give other type of compounds that we can use. And it is help in transportation like shipping, trucks, pipelines, storage, and its end use we in the different fields in industry. In industry we can use it in steel industry, chemical industry, refineries, and other field is transportation. In transport we can use it in shipping, aviation, cars, rails, trucks, buses as a fuel. And in the heating we can use it to produce heat or electricity. Now we come to the hydrogen as an automotive fuel. In automotive vehicles we can use the hydrogen as a fuel cell, or initiating combustible engines. Or the combustible engines are a simply modified version of the traditional gasoline powered internal combustion engine, and the power plant of the such vehicles convert chemical energy of the hydrogen to the mechanical energy that we can use in our vehicles. And here is an image in which a fuel cell is connected, and they take air or oxygen from the environment, and there is a only byproduct in we can see water or heat. What is the worldwide scenario in the world? That's why we see that that's why we call hydrogen is a future fuel. In the starting there is a big problem of hydrogen is that how could we store it? So now it gained momentum in worldwide. The countries like USA, Germany, Japan, South Korea, China are already developed hydrogen fueled cars or buses in their respective countries. China is leading. China is leading in hydrogen energy because it consume or produce more than any other countries. Its current annual uses is more than 24 million ton. And the next country is France. France goal is to achieve industrial process or transportation, and its plan for the worth 7 billion euros, and European Union invest $4.56 billion for annual funding into their project 21 to 30, in which their aim is to become industrial leader in clean hydrogen. And Airbus is revealing his concept for the zero emission commission aircraft powered by hydrogen, which is its plan to enter the market by the 2035. In 2017, we see in the Japan, Tokyo Olympic is organized, in which many buses and the cars are fueled with the hydrogen. And we can see here is a graph in which the number of countries, we can see there are the 15 cars passenger in the 15 countries, vehicles fuel cells in the 10 countries, buses, electrolytes, trucks. As we can see there are already many countries that are adopted this technique. Initiatives taken by the India. What our government take initiatives to make our country hydrogen fuel, hydrogen. Our government announced in budget that government proposed to launch a hydrogen energy mission in 2021 to 2021, in which its goal is 175 gigawatt by 2022, and it allocate rupees 1,500 crore for the renewable energy development and H&M. And India tycoon Mukesh Ambani invest $10.1 billion into clean energy. And in October 2020, Delhi became the first city in the India to operate buses with hydrogen enriched CNG. And today 50 buses in Delhi are being fueled with the HCNG. On 17 March 2022, Toto Kirloser motor claimed that the Toto Mirai is powered by a hydrogen fuel cell battery pack and capable of providing a range of 650 km in a single range with fueling time of 5 minutes. Now we come to the India S2 alliances, where the India Hydrogen Alliances, the global energy and the industrial measures have joined to make India S2 alliances. India S2 alliance mainly focused on the commercial hydrogen technology that includes 5 areas to develop national hydrogen policy and roadmap 2021 to 2030 to create national S2 task force and mission in PPP model. Third, to identify national large S2 demonstration stage projects to create national India S2 funds or to create a good hydrogen linked capacity. Now, what challenges we face in a hydrogen fuel cell? The fuel cell system are efficient than the internal combustion engine, and they require development in terms of infrastructures. And the storage and the transport is the main problem with this hydrogen. Huge investments is required in many fields such as delivery network, storage, transport system, or refueling station. Chances of leakage are here more, and the currently production of hydrogen fuel from renewable energy is costlier than the fossil fuels. Thank you. So question session is open for the audience. If anybody wants to ask any question, he or she can.
Ayushi, very interesting to see. She knows so much about hydrogen. This is fantastic.
Yes, sir. Actually, sir, she is student of.
I can't imagine. Vedanta
MSc chemistry. Yes, yes. Okay, thank you so much, Khushi. And I'm just thinking that it will be beneficial in future time. So, next abstract ID we have IC132 Garima Sharma. I repeat, abstract ID IC132 Garima Sharma. She is not with us, and the next abstract ID is IC127 Suman Dayal. I repeat, IC127 Suman Dayal.
कुछ नहीं न्यूज छाप लिया जो
I think she is also not with us, and the next abstract ID is IC124 Narendra Kumar. I repeat, IC124 Narendra Kumar. He is also not with us, and the next abstract ID is IC292 Dr. Vikas Parekh. He is not with us, and the next abstract ID is IC293 Dr. Naresh Nayak. He is also not with us. Okay, so last participant is IC147 Sudeep Bhattacharya. I repeat, IC147 Sudeep Bhattacharya. Sir, are you there? He's also not with us. Well, now it's time to close oral presentation.
Good afternoon, ma'am.
Good afternoon, sir.
Ma'am, can I present my poster presentation? I am waiting from morning.
Okay. So what's your abstract ID, sir?
IC185.
Please repeat IC185. 1 second, sir. And your name? Okay, sir. Now you can start your presentation. Okay, and please sum up it within 3 to 4 minutes, okay?
Fine.
Okay.
Is it visible?
But go to slide mode.
Sir, this is a poster.
Okay.
Sir, is it visible?
Okay, yes, visible.
Yes. Hello, good afternoon. My name is Arush Shafi and I am doing Masters in Energy Management from SMVDU, Sri Mata Vaishno Devi University, J&K. This
But you are not
presentation...
visible. You are not visible.
Sir, I think there is some connectivity issues.
Okay.
Hello?
Okay.
Sir, am I audible?
Yes.
Sir, I'm doing Masters in Energy Management from Sri Mata Vaishno Devi University. This presentation, this topic is part of my master research, that is demand side management and its application in rural electrification. As we know, there are various issues with rural electrification. The grid is many times down. The grid resorts to shut down due to load, excessive loads or poor transmission capacity. This is on the fact of sparingly distributed households, so poor revenue generation, unreliable power supply, and that all can be overcome with the help of demand side management that can mitigate the peak loads that are there. According to the data from Council of Energy, Environment and Water, we around 95.7% of rural households have been electrified, but that data is based on some parameters. According to Deen Dayal Upadhyay Gram Jyoti Yojana, if around 10% of households are electrified in a village, that whole village can be said to be electrified. Also, if panchayat house or some school, public schools have been electrified in that village, the whole village has to be taken as electrified, but that data is somewhat flawed. So there is still scope of electrification in those rural areas. So those issues that are there can be mitigated with the help of demand side management. The possible solution that I am showing here can be swarm electrification. We can connect the local households together to form a mini grid, or we can use smart meters to obtain the load profile of houses so that we can accordingly formulate some load, so we can supply the areas with a better electricity. The mini grids, load limiters, we can use individual load limiters at houses so that some houses cannot draw excessive loads to disintegrate the stability of the grid. That is the most common thing. Whenever the load increases, the local grids resort to shutdowns. And there should be proper revenue generation. We should give priority to commercial loads so that the grid becomes sustainable due to revenue generation. There should be billing and theft deterrence that can be done with the help of smart meters and load limiters. This is the graph showing the electrification rates across various states, but this is from 2017. According to the latest data, around 95.7% of households in India are electrified, rural households. So that is my conclusion. Reliability of power infrastructure can be enhanced with the help of these methods that I am showing here. Thank you. Sir, any questions?
Aruj, can you tell me how you know the need of the village energy?
Sir, village energy, there are irrigation loads that are there, lighting. Government is providing energy efficient lights like LEDs with the help of energy efficiency limited. That around a 9-watt LED bulb is provided at 25 rupees, whereas its commercial cost is around 150 to 200. There are various schemes like government is providing solar pumping setups. PM Kusum Yojana is there to help these problems.
ये तुमने पोस्टर बनाया या खाली देख के भी आए हो गांव के अंदर?
No sir, this is according to the data. मतलब अभी मैंने मतलब इस पे काम हो रहा है. ये डेटा मैंने कलेक्ट नहीं किया खुद से. This is from some reports.
पर गांव नहीं गए तुम?
No sir.
फिर कैसे पता पड़ेगा?
Sir, reports में mentioned है that the various loads that are there, the difficulties that they are facing.
report
regarding that. The power reliability isn't as such. Power में fluctuation होती है. There is voltage, current voltage isn't sufficiently supplied at 220 volt, so that often leads to disruptions.
Okay, okay, thank you.
Thanks, sir. Thank you.
Okay, thank you so much, sir. And if any participant from oral and poster presentation is remaining, he or she can tell me his name or abstract ID. I repeat, if any participant from oral and poster presentation is remaining, he or she can tell me his or her abstract ID and name. Okay, so
announce once more announce if anybody there.
Okay, so anyone remaining participants due to any technical problems, they can tell their ID or their name.
This is Yasser Iqbal, C193.
Okay, so now I'm inviting the abstract ID 193, Yasser Iqbal.
Yasser, आओ कहाँ पर हो?
I repeat, abstract ID IC 193, Yasser Iqbal. Okay, so okay, so now I would like to call Professor IP Jain to share his experience about this conference.
हाँ, आयुषी क्या बोलना है मेरे को?
Sir, first, I'm Tanya Shekhawat here. And now we were requested to you that you share your experience about this conference.
Okay. First of all, I was not knowing कि मेरे कुछ बोलना पड़ेगा, पर ठीक है, मैं कुछ बोलता हूँ, देखता हूँ. मेरे को ये अच्छा लगा मेरे को चीफ पैटर्न सुमन दीवाना का. She took quite good interest in the conference. और सबसे बड़ी बात तो ये है कि जो पैटर्न्स थे, सुजीत रॉय, नेहा दीवान एंड प्रशांत मदान, इनने भी अच्छा काम किया. पर इन सब में मेरे को लगता है कि प्रशांत मदान साहब ने तो दिन रात लगा रख दिया इसमें. तो इनका काफी बड़ा रोल है इस कॉन्फ्रेंस के सक्सेसफुल होने को. मैं आप लोगों के लिए बाद में आऊंगा. पहले ये कहना चाहता हूँ, संजय कुमार का लेक्चर अच्छा था, काफी अच्छा लेक्चर था. और मुझे जान के बड़ा खुशी है. आई एम वेरी हैप्पी टू सी दैट वी हैव ए very important world renowned scientist, Professor John William Sheffield, बहुत बड़े साइंटिस्ट हैं यूएसए में. जॉन लुइस बॉपेट, यूनिवर्सिटी ऑफ ब्रॉडक्ट फ्रांस. प्रोफेसर संजय कुमार शर्मा, जीआरसी जयपुर. प्रोफेसर बालाचंद्रा, नेशनल लेबोरेटरी यूएसए. प्रोफेसर शरीफ फ्रॉम फ्लोरिडा. डॉक्टर वाईके विजय फ्रॉम जयपुर. मुत्थु कुमार फ्रॉम आईआईटी गुवाहाटी. डेनियल मेराबाले फ्रॉम इटली. ताकाउची इशावा फ्रॉम हरियाणा यूनिवर्सिटी. डी दास फ्रॉम कानपुर IIT Kharagpur. They're such a good speakers and then such a renowned scientists in their field. Their contribution is enormous. And I'm happy that Dr. Mukesh Kumari, the credit goes to Mukesh Kumari that once he was telling me that I want to have a conference. So I was never know कि रिंगस में कॉन्फ्रेंस कैसे करेगी. ये छोटा सा रिंग गांव सा लगता है मेरे को. But when I visited Ringas and Vedanta College, मेरे को लगा कि ये सही जगह है. तो I appreciate मुकेश that फ्रांस में और इटली में और कनाडा में नहीं जाने के बदले वो वेदांता में आ गई. I don't understand मुकेश why she is in Mukesh in Vedanta. people try to go abroad, but she is in Vedanta. I'm happy that she's doing good work, and this conference she's doing from Vedanta is another good thing. So young people will get one thing I miss by listening that आपके बच्चों ने कभी ऐसा नहीं होने दिया कि उनकी प्रेजेंस से बहुत अच्छा लगा कि इन बच्चों को भी इंटरेस्ट आ रहा है. मेरे को पता नहीं इनको क्या समझ में आया होगा. यदि उनको 1-2% भी समझ में आ गया होगा तो एक बड़ा काम होगा उनके कैरियर के लिए. तो इस ऑब्जेक्टिव हमारे कॉन्फ्रेंस के थे कि हर केस को इंटेलेक्चुअल फोरम बनाना हमारे को, ताकि लोगों को नॉलेज गेन हो सके. So I'm glad there's an excellent response of the conference from around the world, from scientists, academicians, industries, research scholars, students, administrators, policymakers, economics. A large number of papers are there, and I'm very happy. These two girls have done wonderful work in organizing this work and asking oral presentation, poster presentation. And I'm happy that I got the opportunity to listen to all posters and all oral presentation. They're all good quality presentation. And this is a unique thing that I congratulate this Vedanta College that they have done wonderful work, and there's a lot of opportunity. A lot of people are working good thing. A lot of girls and faculty members have done wonderful work for the successful conference. And it is all because of Mr. Prashanta, who has given total freedom to the people. I can't imagine this. A private college principal giving freedom to the faculty. This is a unique thing. This is one of the unique things I found, that Mr. Prashanta behaved like a university person. In university, you see a lot of facilities there, a lot of freedom there. But for the first time, I saw that Vedanta principal Prashanta gives enormous freedom to faculty, students for the development of energy and science and technology. In the end, I'll say that this conference is very successful, and I'm very happy these two girls are anchors, Priyanka, I don't know name of Ayushi, and the one I do Sonia, and who is this, and Pankaj. They are doing wonderful work. So thank you so much, everybody, and I'm very happy to have this conference. And I got the opportunity of coming to there and see all those things. I'm sorry that I could not come second time, because on the second day I got tired. I could not go to travel so much. So but I'm seeing all the time today, from tomorrow and yesterday and today. I'm all the time there, and I enjoyed all of things, everything. Thank you very much.
Thank you so much, sir. And now I would like to invite mentor and principal of Vedanta PG Girls College, Dr. Prashant Madan, to share his experience about the conference. Please, sir.
All of them, please give 3 cheers to Prashanta, sir.
Sir,
3 cheers.
Sir, I was looking forward that under your able guidance and leadership.
Let us say hip hip hooray, hip hip hooray, hip hip hooray.
Hip hip hooray for Jain Saab, hip hip hooray for Jain Saab. Sir, it was your direction and motivation that kept us motivated. सर मैं एक चीज बड़ा ऑनेस्टली सबके सामने पूछना चाहूंगा, क्योंकि कहीं ना कहीं मुझे ऐसा लग रहा था कि कुछ चीजों में शायद हम लैक कर रहे हैं, वी माइट बी मिसिंग समथिंग. एक होता है ना कि सर कुछ एक्स फैक्टर, यदि आपको ऐसा लग रहा हो, या वो कोई एनीथिंग व्हिच यू सजेस्ट फॉर जो हमें नेक्स्ट टाइम टेक केयर करना हो, एनीथिंग.
नहीं, मेरे को लगता नहीं कुछ मिस कर रहे हैं, सब ठीक हो गया है.
सर हमारे साथ बस मुझे लग रहा है कि एक दिक्कत आई, मैं ऑनेस्टली शेयर कर लेता हूँ. हमारे पास सर नंबर ऑफ पार्टिसिपेंट्स इतने ज्यादा हुए कि मतलब हम शायद सबको अकोमोडेट नहीं कर पाए सर.
नहीं, मुकेश ने और ये लड़कियों ने सबको बार बार बुला के करा है.
सर वो हुआ यूं कि हमें कल शाम को 8 बजे तक आप भी मौजूद रहे, सेशन एक्सटेंड करना पड़ा, और आज सुबह 8:30. तो मुझे नहीं पता कि ये क्या है, बट आई फील दैट कि दिस इज व्हाट इज आवर बिग अचीवमेंट. Out of 730 participants, we have got 280 participants who are from outside.
Yes.
So 280 is a very, I think, fabulous number.
नहीं, बताओ सर, मेरे को बिलीव नहीं था कि ये सब होगा. बहुत बढ़िया हो गया है.
सर 280 में भी खासियत ये है कि approximately 125, 130, they are from outside Rajasthan. अब सर यहाँ आके ना मैं सुबह से चिंतित हो गया हूँ, क्योंकि हमारी अगली कॉन्फ्रेंस के लिए मेरी टेंशन शुरू हो गई है कि अब की बार हमने यदि 280 कर लिया तो अगली बार हमें अपना रिकॉर्ड तोड़ना पड़ेगा। तो मुकेश जी पे प्रेशर बढ़ गया है।
नहीं, मैं मजाक नहीं कर रहा हूँ, मेरे को पहले लग रहा था कि हो नहीं है, पर मुकेश ने कर डाला।
नहीं सर, आई थिंक शी डिजर्व्स अ वेरी बिग राउंड ऑफ अप्लॉज फ्रॉम ऑल ऑफ अस।
मेरे बताऊं आपको, इतने बड़े साइंटिस्ट इतनी कॉन्फ्रेंस में आ गए, बहुत बड़ी बात है। हर साइंटिस्ट अपने फील्ड में बहुत टॉप का है, आप गूगल करके देखिए, एनी साइंटिस्ट कॉन्फ्रेंस का, एनी साइंटिस्ट गूगल कर देखिए, आपको बहुत मजा आएगा आपको।
That is, I just wanted to share among the students कि कुछ चीज ऐसी होती है जो सर बच्चों को ये लगता है कि हम यहाँ से कह रहे हैं तो शायद हम अतिशोक्ति है या हम कुछ बड़ा चढ़ा के कह रहे हैं, बट वाकई हम आपसे शेयर करना चाहेंगे। कई साइंटिस्ट जो हैं वो ऐसे जुड़े हैं जो वर्ल्ड लेवल पे एक उनकी सेंटेंस एक अपने आप में किताब के बराबर है। वो अपने फील्ड का ओपिनियन रखते हैं। पीछे से 2 मिनट चुप रहो और यू स्पीक साइलेंटली, इशारों में बात करो।
2-4 तो एज ए इंस्टीट्यूट हैं, जॉन विलियमसन इंस्टीट्यूट सेल।
So that is where we were able to get the things well on time. सर एक रिपोर्ट हम पढ़ना चाह रहे थे, आपकी परमिशन हो तो। With your due permission, shall I read the report?
Whatever you do, it will be nice to everybody.
Yes, sir. So I just wanted to proceed as a concluding remarks, because now we have got another last 45 minutes और हैं हमारे पास, then we'll close the session. So for the report, I'd like to present the report that the 3 days international conference which was organized at the Vedanta PG Girls College in association with MRSI chapter from 29 to 31st for 3 days, the first international conference. The topic was on the emerging trends in science and technology. The inaugural session was complete with the gracious presence of Professor Bhagirath Singh Ji, Vice Chancellor of Pandit Deen Dayal Upadhyay Shekhawati University, Sikar, eminent educationalist Professor I.P. Jain Sahab, who is the founder director of CNCER and honorable chairman for the ICE TST 2022, Professor Sanjay Sharma Ji, Dean Research from JECRC University, Jaipur. The program started with the lighting of the lamp, where the chief guest of the conference, Professor Bhagirath Singh Ji, he was including all dignitaries. They offered candles and flowers to Goddess Saraswati. All the guests, they were honored with garlands, shawls, and mementos. They were delivered a Dr. Prashant Madan, myself, have delivered a heart-warming speech. I don't know how heart-warming it was, and express his gratitude to them for their presence. Our patron, our president, Mrs. Sumanji Didwania, the trustee of Vedanta Foundation, and chief patron of the conference, welcomed the guests with the gracious and knowledgeable words. She really has got a vision, जहाँ पे वो आप बच्चियों के लिए skill development की बात करती हैं. अच्छा, for students, we have got one more good announcement. We are trying कि next session से सुमन जी बड़ा चाह रही हैं कि आप लोग की यूनिफॉर्म का कलर भी चेंज हो जाए. So we are going to change the color. So it will be changed from the next session. हमारे लोगो थीम से मिलता हुआ होगा. जैसे बाहर बेंचेस लगी ना खूबसूरत ब्लू और ग्रीन कलर की. We'll go with something good bright color. Okay? यस में थक गए बेचारे. यस भी नहीं निकल पा रहा, गले में आवाज अटक रही है. If I talk about the patron and our head of Vedanta Foundation, Mr. Surjit Roy, a man who is Surjit Roy साहब से मुझे ना हल्का सा मैं ये सोचता था कि जैसा आप मेरे बारे में सोचते हैं ना कि सुबह सुबह मैसेज आ जाता है, तो मिस्टर रॉय इज ऑफ माय सेम फ्रीक्वेंसी. सुबह 5-5:30 बजे ही इज अ अर्ली गेटर. तो सुबह 5-5:30 बजे ही स्टार्ट सेंडिंग द मेल. 6-6:30 बजे तक मेल व्हाट्सएप सब निपटा लेते हैं. उन्होंने मुझे सुबह आज 5:45 बजे मैसेज किया, गिव मी द रिपोर्ट. 6:15 बजे प्लीज कॉल वेन एवर कन्वीनियंट. मैंने कहा मैं 6 बजे ही फोन कर लेता हूं. तो मैंने 6:15 बजे उनको फोन कर दिया. तो 15-20 मिनट मेरी सुबह ही ब्रीफिंग हो गई उनसे. So that is what is a kind of thing that at this age he has got this kind of energy स्किल डेवलपमेंट पे हम बात करेंगे, स्किल डेवलपमेंट में हम आगे ग्रो करेंगे. Professor Bhagirath Singh ji, it was very kind enough that he was having a meeting on that very particular day, but he took out time to come here for gave the presidential speech and explaining the pros and cons of the technology. And technology doesn't rule over human being. अच्छा, एक बहुत बढ़िया चीज है, आप में से जो बच्चे कंप्यूटर यूज करते हैं, आजकल बड़ी अजीब चीज हो गई है. ऑनलाइन हमसे पूछता है, इफ यू आर नॉट अ रोबोट टिक हेयर. कंप्यूटर हमसे पूछ रहा है, आप रोबोट तो नहीं हो. इंस्टेड ऑफ वी आस्किंग द कंप्यूटर, कंप्यूटर इज आस्किंग अस कि आप रोबोट तो नहीं हो. जमाना बदल रहा है. Our chairperson of the conference, IP Jain Saab, he shared his ideas about research methodology, its benefit for students. Professor Sanjay Sharma ji, who was a special guest of the conference, shared his views on research and various open scopes for the research scholars. The conference, in totality, a dream, a vision of Dr. Mukesh Kumari, the convener for ICE TST 2022. She told about the importance of conference, purpose, implications, national and international scientists, researchers, authors, practitioners, professors, associate professors, and they were all, it was her idea, her sheer persuasion. मेरे से बहुत बार गुस्सा भी हुई. जो आदमी काम करेगा गुस्सा भी वही करेगा. See, my philosophy is very clear. क्योंकि बाकी लोगों की वो जिंदगी तो कमियां निकालने में निकल जाती है, जो खुद काम नहीं करता है. जो काम करेगा वो गुस्सा करेगा, झुंझलाएगा भी. तो she had lot of time, she was angry with me, कभी वैसे कभी लड़के. But at the end of the day, she has really done a commendable job. 3 दिन से day and night, रात को 1:30 बजे 2 बजे. See, if you want to be successful, that kind of passion is required. On the first day of the session was summed up by Ms. Jyoti Rajawat from the Botany Department, who thanked all the keynote speakers. First day we have got Professor John W. Sheffield from the Polytechnic Institute, USA, Professor Louis Bobet from the University of Bordeaux, France, Professor Sanjay Kumar Sharma from JECIC University, Professor U. Balachandran, who is in National Lab USA and is a keynote speaker. And then we have got Professor P.C. Mali from the University of Rajasthan and Dr. Ravindra Jangir from RRCAT Indore. They were invited talks. The keynote speaker one was the Professor John W. Sheffield. He presented on the greening of mining fleets, a race to zero. Keynote speaker two, Professor Jean-Louis Bobet. He told about the RETMMG alloys for hydrogen energy and use of hydrogen generators. There's something great. He also discussed about the electrically assisted bikes by MG Power hydrogen and about the hydrogen production by oils. Keynote speaker 3, Professor Sanjay Kumar Sharma, told about the green chemistry and sustainable development goals. He shared his views on the global warming, industrial pollution, fluorosis problems, which all were the biggest, highest challenges of our ecosystem. And they also aware to us by the control. He also shared how to control the pollution. The keynote speaker 4, Professor U. Balachandran, told about the nanotechnology to overcome material challenges for sustainable energy system. Then we have got Professor Dr. Murgesh Chaturvedi. He shared about the plastic effect on human life and the environment. He said that we should reduce the use of plastic containers and other plastic products. It will the very big contribution to our environment and ecosystem maintenance. Then we have got Dr. Anurag Sungda. He shared his views on energy resources and the ways of energy production. He also told us that how we can consume the energy for our environmental balancing. This is something which is required, balance. हमारे पूर्वज, हमारे पुरखे हमेशा एक ही बात पे करते थे, प्रकृति से जितना लीजिए उतना उसको वापस दीजिए. हमने सिर्फ वक्त बदल दिया, हमने लेना सीख लिया, प्रकृति को वापस देना बंद कर दिया है. The moment since we are only the takers, लास्ट में हम लोग लेने लायक भी नहीं बचेंगे. क्यों? क्योंकि हम लोग सब खत्म हो जाएंगे, समाप्त हो जाएंगे, सभ्यता खत्म हो जाएगी. Session day 1 ended with the energetic dance performance. That was awesome. हम सबने dance performance देखी. And it was a big, अरे आपने ये भी mention कर दिया इसमें, the big prize money for encouraging and avoiding them was the further. अच्छा, students की prize money में थोड़ा सा और change हो गया है. डांस वाले students हैं present यहाँ पे कुछ? अच्छा, डांस वाले स्टूडेंट्स में चेंज ये हो गया है कि उस दिन जो प्राइज मनी 11,000 थी वो बढ़ के 14,500 रुपए हो गई है. अरे हमें गड़बड़ ये हो रही थी कि हमने जब उसको भाग किया तो 400 कुछ रुपए आ रहे थे. हमने कहा ये लड़ ले नहीं ले, तो हमने सबका राउंड फिगर में 500 रुपीज कर दिया. तो 11,000 से अब डांस वालों की प्राइस मनी हो गई है 14,500. अच्छा करेंगे तो हमारा भी मन करता है, एज अ गार्जियन, एज अ पेरेंट, एज अ individual, really we should appreciate something good. On the second day, Professor Sharif, University of Florida, USA, Professor Ankur Jain from Suresh Gyanvihar University, Professor YK Vijay Sahab, Director MRIC Chapter, Professor Muthu Kumar from IIT Guwahati, Dr. Daniel Gattia from Italy, Professor Ichikawa from Hiroshima University, Japan were the keynote speakers. Professor GP Singh from University of Rajasthan, Dr. Anurag Sunda from JC Bose University, India, Dr. Shweta Rani from Dayal Singh College. They were invited as a keynote speaker. Keynote speaker was Professor Sharif. Professor YK Vijay told about the quantum science in the visible range and explained the application of quantum in different fields due to its different and specific purposes. Keynote speaker 7th was Professor Muthu Kumar. He told about the energy efficient and eco-friendly porous radiant burner for cooking and industrial applications. यार बहुत तगड़े काम हो रहे हैं भारत में, भविष्य बदलेगा वाकई. He told us about the developed PRB cook stoves at Guwahati, which are eco-friendly cook stoves. Dr. Gatkia told about the energy storage using magnesium-based materials. He explained the different strategies for improving thermal conductivity. Professor Ichikawa presented his presentation on development of ammonia utilization and energy and hydrogen carrier. He told about the lithium-ion batteries and use of ammonia as a hydrogen carrier on energy carrier. There was an invited talk from Dr. Ankur Jain, who presented on the applications of, how you spell it, chalcogenides for energy storage techniques. He told about the solution of renewable energy. He shared his student Ms. Khushbu Sharma's research work on electrolyte LiBH4. He told that solid-state batteries will be the future generation batteries. Professor GP Singh shared his views on perspective of algae in present era and discussed about phytoplankton. Dr. Shweta Rani shared her thoughts on green material and sustainability in Delhi metropolitan region. On third day, we have got Dr. D. Das from IIT Kharagpur, who was the keynote speaker, and Dr. Ravindra Jangir from RRCAT Indore, Professor Yogendra Kumar Mishra from University of Southern Denmark, Dr. Damaraju, ONGC India, and Dr. Dinesh Goyal, Director PIET, they were the invited talks. Professor D. Das presented on biohazard fuel for the future. Dr. Jangir told about the P-type transport conducting oxide alpha. Professor Mishra presented his research experiences through the topic tetrapods-based smart materials for advanced technologies. Dr. Damaraju told about energy transition leading to hydrogen world. Dr. Dinesh presented on national education policy. Professor P.C. Mali shared his thoughts on the application of herbal nanoparticles in alternative and complementary medicines. Among other session co-chairs and other guests, they were presented by Dr. Rajesh Kumar Yadav from Subodh College, Dr. Murugesh Chaturvedi, and Dr. R.J. Verma. In all, we have got, including our own students, we have got 730 participants with 10 keynote speakers, 10 invited talks. So out of 450 are our students, and 280 we have got the registrations from outside, including presentations and posters. And out of them, almost 40% they are out of Rajasthan. So it means in the very first conference, आपने इतना बढ़िया बेंचमार्क क्रिएट कर लिया कि अगली कॉन्फ्रेंस के लिए आपको बहुत ज्यादा जी तोड़ मेहनत करनी पड़ेगी. Here comes a problem. So big round of applause to everyone. In 3 days, We could have managed only 143 oral presentations approximately online across the world, 27 from students of Vedanta College. In poster presentations, we have got 56 who are from the outside online, and 48 are students. There were 48 na Jyoti yesterday. 48 they were from our own students. And now it calls to close this ICE-TST. We have got some few guests who will be coming in some time. But meanwhile, we can go for small things. What's the time?
प्रशांत जी, ये अभी जो बच्चों ने कॉन्फ्रेंस करी है, ये प्रियंका है, आयुषी है, सोनिया है, पंकज है, मुकेश है, ये जो ऑर्गेनाइजर में बच्चे लगे, सब लोग फैकल्टी ये लोग लगे, इनके लिए एक आउटसाइड डिनर हो जाए और कुछ मोटिवेशन मिल जाए, इन लोगों को छुट्टी मिल जाए 1-2 दिन की। आपसे कुछ ये इच्छा रखती नहीं है लोग, पर हमारा कुछ राइट बनता है कि इनको ये कुछ किया जाए।
सर मेरी टीम इतनी डेडिकेटेड है वो कि गीता के सिद्धांत पे चलते हैं कि कर्म किए जा, फल की चिंता मत कर। तो कहते हैं कर्म किए जाओ, भोजन की चिंता मत करो। डेफिनेटली सर, डेफिनेटली सर।
इनका कुछ भी इच्छा नहीं है ऐसे कुछ। मैंने पूछा भी था इनसे, इनकी कोई इच्छा नहीं। इनका ये कि हमें अपॉर्चुनिटी मिली काम करने को, बहुत अच्छा है, हमारे लिए काफी है ये। पर मेरा ऐसा कुछ देखना था कि इनका कुछ होना चाहिए, थके माने हैं सब लोग।
नहीं, definitely sir, your suggestion will be very well taken care and we'll do everything what you have suggested. It will be there on the card sir, definitely yes.
पूछा था प्रियंका से, आयुषी से, सोनिया से, पंकज से कि हमको ये चांस मिल गया, ये बड़ी बात है हमारे लिए।
नहीं, definitely sir, we'll incorporate your suggestion. Definitely sir, 101% everything will be implemented what you have suggested.
Thank you. नो, बच्चे कभी एक्सेप्ट नहीं करते, बच्चों को दिया जाता है, बस यही बात है।
बिल्कुल सर, वी स्टैंड फॉर दैट। और तभी मैंने जैसा आपसे शेयर किया कि दैट डे जो हमारा डांस का प्राइज मनी था वो 11,000 था, लेकिन मुझे लगा कि थोड़ा सा कम है, तो मैंने इसलिए उसको और बढ़ा के अलग कर दिया, बिकॉज दैट इज समवेयर वी हैव टू मोटिवेट। एंड एट द एंड ऑफ द डे आई बिलीव दैट आई एम अ गार्जियन टू ऑल दीज किड्स, ऑल दीज गर्ल्स, ऑल दीज स्टूडेंट्स।
मेरा ये कहना है कि आप if you work for the Nobel Prize, you will never get.
Yes sir.
If you work for the Nobel Prize, you will never get. But if you work, you will get.
Yes sir. We'll work only. We'll get the Nobel Prize.
ऐसे ही बच्चे हैं ये काम करके, इनको कुछ मतलब नहीं है क्या मिलेगा क्या नहीं मिलेगा, पर
बस सर, यही सर खूबसूरती है इन बच्चों की, इन बच्चियों की। They are really working day and night. Somewhat we also feel that yes, and तभी मैं सर कई बात होती है तो I equally share that कि I am blessed one to have so many daughters with me. वो कहते हैं कि वो कन्या तो धन होती है, तो मैं पहले जहाँ था वहाँ कम बच्चियां थी, मैं यहाँ आ गया तो I become more richer in terms of number of students. I got more Lakshmi with me now.
Thank you.
And that is where we equally believe कि माता रानी ऐसे ही झोली भरती रहे हमारी बच्चियों से। Let us have more number of students where, and this is what is the philosophy we believe. जब हम बात करते हैं आपके एजुकेशन की सब चीजें, अच्छी बात ये है कि एक ट्रांसपेरेंट सिस्टम है, एक अच्छा सिस्टम है where we can share equally.
ये भी टाइम हो तो एक यासर इकबाल प्रेजेंट करना चाहता है, यदि टाइम हो तो।
Yes sir.
एक यासर इकबाल प्रेजेंट करना चाहता है 5 मिनट के लिए।
Yes, we can have sir, we can have.
यासर अराफत कम C193, आयुषी, प्रियंका, all Yasser Arafat C193.
C193 Mr. Yasser कर रहे हैं हमारे आईटी वाले।
Yasser, where are you? Yasser. Yasser, are you listening to me? Ayushi, call Yasser. He's requesting.
Yes, sir. So I would like to invite abstract ID IC193 Yashir Iqbal. Sir, am I audible to you? Yashir sir, am I audible to you?
Yes, still he's there. He's there, yes.
Okay. Okay, sir. Now you can start your presentation and please sum up it within 5 minutes, okay? Sorry, in 2 minutes, okay? Yashir, sir, am I audible to you?
Yeah, sure.
Okay, so please sum up your presentation within 2 minutes, okay? Due to time limit.
या सर कहाँ पर हो? अभी कह रहे थे प्रेजेंट करूंगा, कहाँ चले गए?
Excuse me, sir. Sir.
Yes.
Sir, this is Aruj. He's trying to connect, but उसकी आवाज नहीं आ रही है. He has shared his screen too.
So you start speaking on behalf of him.
Sir, can I put my laptop there? He will present his on this device. Is it okay?
Yes, you do as you like. Do as. Yes.
Okay. Yes, sir. वहां पे प्रेजेंट करते तो तूने शेयर कर दिया ना स्क्रीन. हाँ, अब यहीं से पढ़िए and share it. So my topic is analysis of incidence angle effect of PV module with PV system. Introduction. We are trying to increase its efficiency in order to have maximum performance of PV system. The tilt of solar panel must be optimized. And hence the efficiency of plants directly depend on the angle of incidence and also tilt angle. Next, PV design in PVSys software. PVSys is a software engineers used this software for designing of plants. All the designs are made on this software. It gives meteorological data and design of better design. And next and result, so all works done in this software. Result, the reliable model to describe the incidence angle dependency of photovoltaic module is necessary to accurate energy yield simulation. The method of collecting location and system specific incidence angle, modifier parameter and context of PV system has been described and seen graph. And June and July, the temperature is very high because of temperature high, efficiency goes decrease because of temperature. So that's all.
Thank you very much.
So thank you so much, sir, for joining us. And now I'm going to tell about the participants who gave best oral presentation in these 3 days. I repeat. Now I'm going to tell about the participants who gave best oral presentation in these 3 days in online mode.
Okay.
So first is Professor Brijesh Meena, IIT Guwahati. Please give big round of applause. Sorry. And second is Dr. Biswajit Paik, West Bengal. And the third one is Ms. Poonam Sharma, IIS University, Jaipur. Okay, and now I'm going to tell about the participants who gave best poster presentation in these 3 days in online mode. So, Mr. Akash Garg, Suresh Gyan Vihar University. and Dr. Daniel Mirabal Gatia, Inea, Italy. Thank you.
आयुषी, इनका क्या नाम है? इनका तेरे साथ जो खड़ी हैं?
Tanya
Tanya.
Shekhawat.
Tanya Shekhawat. Be in touch with me.
Okay. Yes, sir.
कहाँ चले गए सोनिया?
Yes, sir.
कहाँ चले गए तुम लोग? अब क्या करेंगे आगे?
Sorry, sir, I didn't get your words.
आगे का प्रोग्राम क्या है? What is the program?
Okay, sir, there is a prize distribution ceremony we have next.
Okay.
Yes, sir.
Hello, Ayushi. Hello. Hello, Ayushi, Priyanka. Ayushi, Priyanka, is it over or something no more?
Actually, sir, there is a break of 10 minutes.
Okay. Thank you.
Okay. After that, we are going to start. Okay.
Thank you.
Okay, sir. Thank you.
Just want a break है कोई आने वाले होंगे
Good. Good picture. खुश हो जाओ अभी तो सो ही रहे हैं सब शांति ओम शांति शांति
करना है। ओके, अब हम आपके और खाने के बीच में सिर्फ एक ही आदमी है, वो मैं हूं। तो मैं जब तक खड़ा हूं खाना नहीं मिलेगा। नो इश्यूज, वी आर जस्ट ऑन द क्लोजिंग नोड। इट्स अ गुड पार्ट कि हम बच्चों से थोड़ा सा हंसी मजाक भी कर लेना चाहिए। एंड डेफिनेटली द स्टूडेंट्स, आफ्टर so much of hard work, now we are going to close this program. Few people who have really contributed, कुछ लोग ऐसे हैं जो हमारी कॉन्फ्रेंस के लिए नींव का पत्थर रहे। नींव का पत्थर वो पत्थर रहता है जो नहीं दिखता है, लेकिन इमारत उसी पे टिकी होती है। So I'll announce the name one by one. I do not know whether they know or not. रख दीजिए, कोई बात नहीं, कोई बात नहीं, लीव इट, ऐसे बिछा दीजिए ऊपर खाली, चलेगा चलेगा चलेगा। अरे छोड़ दीजिए, लीव इट। गुलाब के साथ ही ऊपर चला दीजिए एक लंबी सी, बस खत्म कर दीजिए। सो देर आर फ्यू पीपल, कुछ लोग ऐसे हैं जिनकी वजह से प्रोग्राम सक्सेसफुल हुआ, मैं उनको बुलाना चाहूंगा। सबसे पहले हमारे अपने श्याम जी। श्याम जी, आप कैमरा छोड़ के आ जाओ।
बहुत अच्छा काम कर रहे हैं, बहुत।
श्याम जी हमारे फोटोग्राफर हैं जो इंस्टीट्यूट से काफी सालों से जुड़े हुए हैं।
एक व्यक्ति जो दिन रात हमारे साथ जुड़े रहे, पंकज जी, मैं आपको बुलाना चाहूंगा, प्लीज प्लीज कम।
बहुत बहुत अच्छा काम किया पंकज जी ने।
पंकज जी अपनी टेक्निकल टीम जिन्होंने कॉन्फ्रेंस 3 दिन तक संभाली है, बहुत अच्छे से मैनेज किया है।
ये टिक लगाना जरूरी हो गया, पता चले किसी को 2 चले गए।
प्रियंका जी, सोनिया जी, आयुषी जी, बहुत काम किया है। ये इतनी खड़ी रही, सुबह से शाम तक खड़ी रही, पता नहीं कैसे खड़ी रही, पता नहीं।
Sir, they are the, let us not go look at them. They are internally very strong. सर मेरी बच्चियां बहुत मजबूत हैं।
पता नहीं दिमाग में, पता नहीं ब्लड का सर्कुलेशन कैसे हुआ होगा, खड़ी रही, बस खड़ी रही।
I'll request Pawan ji to come on the stage. Please, Pawan ji.
पवन जी कॉलेज के लिए जो स्वीट वेंडर हैं, कॉलेज के सामने इनका शॉप है और सारा जो खाने का अरेंजमेंट है पवन जी के यहाँ से ही हो रहा है कॉन्फ्रेंस का।
पवन जी की ऑनेस्टी है, और मेरे दूसरे पवन बाबू के बिना तो कार्य अधूरा रहेगा। आओ पवन बाबू। कम।
पवन जी हमारे कॉलेज के क्लरिकल स्टाफ से हैं, लेकिन क्लरिकल से ज्यादा डिजाइनिंग का जितना कॉन्फ्रेंस का काम है इन्होंने ही संभाला है।
अच्छा, दिस वन मोर पर्सन, एक व्यक्ति है जो कॉलेज टाइम के अलावा भी सबसे ज्यादा मेरे से, मैं डांट नहीं कहूंगा, मैं स्नेह के साथ बोल देता हूँ कभी कुछ, फिर वो गुस्से में तमतमा जाते हैं, अच्छा मैं छोड़ के जा रहा हूँ। हर 15-20 दिन में आलोक जी हमारे, आओ आलोक जी, कम, नाराज हो जाते हैं कई बार।
आलोक जी कॉलेज का सारा मैनेजमेंट देखते हैं।
I would like to invite Miss Jyoti Rajawat. Come.
मिस ज्योति राजावत हमारे कॉलेज की बॉटनी डिपार्टमेंट की हेड हैं, और साथ में ही स्काउट एंड रेंजर गाइड की जो टीम है वो यहाँ चलाती है।
See, this doesn't mean कि it is something different for others. It doesn't mean, but somewhere what we feel कि this was something over and above. इसमें किसी भी चीज को माइंड मत करिएगा, because I know my staff, I know my team. किसी का भी एफर्ट्स कम नहीं है, ज्यादा नहीं है। And we got Miss Priyanka, definitely come. Now I got a confusion. That few people, they really worked hard, they really done something. जैसे मैं आलोक की बात करूं, he got this renovated in a very short span of time. मेरे से बहुत लड़ाई हुई अलग तरह से, सब कुछ रहा। अच्छा, बिना अर्थ के व्यवस्था नहीं चल पाती है। तो हमारे अकाउंटेंट साहब आइए, क्योंकि है क्या, कॉन्फ्रेंस के बाद की सारी लड़ाई पेमेंट की इन्होंने लड़नी है।
सुनील सर, जिन्होंने एब्स्ट्रैक्ट और जितना भी रिटर्न से रिलेटेड काम है कॉन्फ्रेंस का वो सारा देखा है।
छोड़ गया। अच्छा, अच्छी बात यह कि गिफ्ट्स रोटेट नहीं होते। Now, all these things, let us give a round of applause to the person who was really working hard day and night, who had really worked thoroughly. So I would like to call Dr. Mukesh. Dr. साहब आइए.
हमको भी दिखना चाहिए ना क्या हो रहा है. हमको दिखाओ ना क्या हो रहा है.
इनको तो आप सब जानते ही हैं, इंट्रोडक्शन देने की मुझे जरूरत नहीं है.
हमको दिखाओ क्या हो रहा है.
I would like to invite Dr. Mukesh and Miss Priyanka Jyoti. Dr. Archana Sharma को बढ़िया सी माला पहनाइए. मानसी कहाँ है? कम प्लीज. कम ऑल ऑफ यू आइए और माला लेके आइए. अरे प्लीज डॉक्टर अर्चना जी
हमको भी दिखाइए.
अरे माला पहनी है. अरे ऐसे थोड़ी होता. ऐसे नहीं. अरे फिर अरे आप अभी आपको वहीं खड़े होना है. इधर नहीं आना, आपको उधर ही खड़े होना है. आपको उधर. अरे नहीं ऐसे नहीं. अरे कम पकड़ के पहना दीजिए. होली वाला काम करिए नहीं तो. अरे उधर से एक माला उठा दो ना. पड़ी है. पंकज जी एक माला और उठा दो. See what happened with a certain age, with a certain gesture, with certain experience. कोई चीज देना मतलब शायद सूरज को दिए दिखाने के बराबर होता. जो सम्मान के आप अधिकारी हैं, जिस चीज के आप राइटफुली है, तो एक बार जोरदार तालियां इस पूरी टीम के लिए बजा दीजिए. आप चारों यहीं खड़े हो जाओ. You all stay here. Come here. Come. मोमेंट फिर बाद में ले. Smart है चिंता. So there's a surprise also. अच्छा ये बढ़िया सा फोटो खींचा दीजिए. पोज देके एक बढ़िया सा. आपको भी पोज बड़ा. अच्छा वी हैव गॉट. अच्छा देन वी वर हैविंग अ. अरे वो स्टूडेंट्स के प्राइस क्या है भाई? बच्चों को तो दो. माला हटा दिया आपने यार. गलत किया. अब वी हैव गॉट 8 स्टूडेंट्स. मैं रिक्वेस्ट करूंगा सर आप आ जाएं. पवन जी आप भी आ जाइए हमारी बच्चियों को प्राइज देने के लिए. आइए सर प्लीज आप भी आ जाइए. We have got second rank in oral presentation. अच्छा, आई सपोज हमारे सारे वॉलंटियर्स यहाँ पे मौजूद हैं, नहीं है तो बुला लीजिए, बिकॉज इन नेक्स्ट 5 minutes 7 minutes विल क्लोज. Tejasvi Sharma, MSc previous botany, she has got second position in the oral presentation. ज्योति, पेन होल्डर रहेगा बच्चों के लिए गिफ्ट में, बता दो. 8 पेन होल्डर्स आर देयर, खोल के देना. क्या सोच रही थी? प्रिंसिपल अच्छा है, स्मार्ट है. तालियां बजा दीजिए, हमारे अपने कॉलेज का बच्चा है. We have got Ayushi Sharma next, second prize. जल्दी 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 जल्दी. First prize for the oral presentation, Priyanka Badala, MSc Final Chemistry on Waste Management. She has got the first prize. Priyanka Badala. फर्स्ट प्राइज एक और बच्ची को मिला है, राधिका जहांगीर फ्रॉम BA थर्ड ईयर. राधिका, शी इज प्रेजेंट. राधिका फ्रॉम BA थर्ड ईयर. नहीं है, कोई बात नहीं. पोस्टर प्रेजेंटेशन, द सेकंड प्राइज गोज टू पारू वर्मा. पारू वर्मा, MSc फाइनल ड्राइंग एंड पेंटिंग. प्रेजेंट है पारू? नहीं है. Second, we have got Aarti Sharma. Is she present? Aarti Sharma. Okay. First prize goes to Anita Kumawat. नाम बोलो, नाम बोलो, नाम बोलो. नाम क्या है बच्चा? Paru Verma. Okay. She has got second prize for the poster presentation. First prize goes to for poster presentation, Anita Kumawat. Anita Kumawat present है? Yes or no? Ekta Jangir. Ekta Jangir. Yes. First prize for poster presentation. एंकर्स पे अच्छा कर दिया, राउंड फिगर में 500 कर दिया. बड़ी चिंता हो रही थी, मतलब बांटोगे कैसे. पहले मुझे लगा चेयर्स दे देता हूँ गिफ्ट में. देन वी हैव गॉट आवर सपोर्ट स्टाफ. हमारा सारा सपोर्ट स्टाफ को मैं एक एक करके बुलाना चाहूंगा. आप लोग आ जाइए, सब एक एक करके लाइन से आ जाइए. आना तो यहीं पड़ेगा मंच पे. आइए आइए, कम कम कम. पार्वती जी कहाँ है? सबको लेके आओ. पुष्पा जी आइए आइए. गुड गुड गुड.
राजू भैया किधर हैं आप?
No, I cannot. राजू भाई जल्दी आओ यार, दौड़ के आओ, आओ, कम कम कम. अच्छा हुआ क्या, मैं एक बार ना, आई एम वेरी फॉन्ड ऑफ समवेयर, मुझे नहीं पता मुझे बच्चों को ये चीज बोलनी चाहिए नहीं बोलनी चाहिए, बट मुझे ना अभी कुछ टाइम से 2-3 साल से थोड़ा सा कम हुआ, बट अदरवाइज ना मुझे टीवी देखने का बड़ा एडिक्शन था, मुझे सालों साल टीवी देखने का बहुत शौक रहा. अब अच्छी बात यह कि आई शेयर वेरी ऑनेस्टली, तो मैं एक बार फिल्म फेयर अवार्ड देख रहा था, और फिल्म फेयर अवार्ड में, उस फिल्म फेयर अवार्ड में प्राइज जो दिया गया था लाइफ टाइम अचीवमेंट के लिए, वो दिया गया था धर्मेंद्र को. तो धर्मेंद्र जब वो प्राइज लेने आए, फिल्म फेयर प्राइज लेने आए, तो कहते हैं कि जब मैं गांव से निकला तो वो मैगजीन आई थी फिल्म फेयर, मैंने उसमें वो कटिंग देख के मैंने अपनी फोटो भेजी, और मैं चुना गया, और मैं उसके बाद एक्टर बन गया. कहता है सालों साल मैंने बड़ी हिट पिक्चरें दी, मैं हर फिल्म फेयर अवार्ड में नया सूट पहन के आता था कि शायद मुझे इस फिल्म फेयर अवार्ड मिल जाए, मुझे इस साल मिल जाए, इस साल मिल जाए. कहते कभी नहीं मिला. तो एट द एंड उसको लाइफ टाइम अचीवमेंट मिला. तो मैं राजू को देख के थोड़ा सा मुझे वही फील आ रहा था, धर्मेंद्र वाला, कि कई बार क्या होता है कि प्राइज नहीं मिला, बट जब मिला तो एक लाइफ टाइम अचीवमेंट प्राइज मिला. सो दैट वाज अ मोमेंट. कई चीजें आप कोरिलेट करते हैं, कुछ चीजें होती हैं पुरस्कार से आगे होती हैं. फॉर माय वॉलेंटियर टीम, क्योंकि मैं अब बच्चियों में डिफरेंशिएट नहीं कर सकता, तो जो प्राइज डांस कल्चरल के बच्चों के लिए था, 500 रुपीज पर स्टूडेंट, सेम 25,000 रुपीज इज फॉर माय वॉलेंटियर्स. तो ज्योति जी, ये 49 एनवलप्स आप ले लो. इधर आ जाओ, यहाँ के बोलो, इतनी दूर से हमें समझ में नहीं आएगा, और ये लैंग्वेज, साइन लैंग्वेज अभी हमें नहीं आती है. कि एक ग्रुप फोटो के लिए आ जाएं। आप सब वॉलंटियर्स आ जाइए। आप सबके लिए सेम प्राइज मनी 500 रुपीज फॉर ऑल स्टूडेंट्स, मेकिंग इट टुगेदर 25,000 रुपीज। आई थिंक गुड इनफ। कोई फर्क नहीं रखा मैंने, मैं बच्चियों में अलग भेदभाव नहीं रख सकता। गुड। माय एंकर्स वर थिंकिंग कि शायद हमें डबल प्राइज मिल जाए। भाई मेरे खड़े होने की एक छोटी सी जगह रख लेना। या आई एम कमिंग, मैं बीच में खड़ा होऊंगा। ओके, आ जाऊं। फोन आने वाला।
I want to say something for the volunteers. बेटी की मोहब्बत को कभी भुलाना नहीं, बेटे की मोहब्बत को कभी भुलाना नहीं, वह फूल है उसे कभी रुलाना नहीं। पिता का गुमान होती है बेटी, जिंदा होने की पहचान होती है बेटी। उसकी आंखें कभी नम न होने देना, उसकी जिंदगी से खुशियां कम न होने देना। बहुत छोटा सा सफर है बेटी के साथ, बहुत कम वक्त के लिए वह होती है हमारे पास। असीम दुलार पाने की हकदार है बेटी, समझो तो ईश्वर का आशीर्वाद है बेटी, आशीर्वाद है बेटी। और एक फादर का जो लव होता है, एक अफेक्शन होता है अपनी डॉटर्स के लिए, सेम वो का वो लव और अफेक्शन हमारे प्रिंसिपल सर का रहता है हमारे लिए। सो थैंक यू सो मच सर।
दूसरों की जय से पहले खुद की जय करो। We can close now. Anything else you want to say or ask for your suggestion? I need some water. दे दिए ना कल्चरल के प्राइस, दे तो दिए। 500 रुपीज ईच एनवेलप दे तो दिया, कैश दे दिया। They are included in this list. एंकर्स की लिस्ट में है। कल्चरल में कितने बच्चे कम प्रेजेंट, एक्चुअली कल्चरल टीम नहीं आई है। कल्चरल में बच्चे प्रेजेंट नहीं है ना, कितने हैं? बुला लो इनको, कॉल देम। हाँ ठीक है, आ जाओ, नाम पे टिक कर लो। दो ही है ना, दो ही तो है, ये तो दो ही है ना। कहाँ? अरे यहीं देखे, फोटो एक साथ करा देंगे, बुला लो सबको। हो गया डिक्लेयर अब। लोग ग्रुप में डाल देंगे ना, विल पुट इट इन ग्रुप। ऐसे थोड़ी दिखते हैं। अभी फोटो कर रहे हैं, फोटो करा रहे हैं, फिर भी give it to us. अच्छा we have got किसकी इसकी ओके हाँ So with this, we close the conference. Best wishes to each one, all the participants. See you in the next episode of this one. We'll go with a much bigger conference. Thank you all.